And a very good morning to all of you, ladies and gentlemen. My name is Łukasz Cioch, and it's day 2 of the European Rover Challenge here at Kielce University of Technology. Yesterday it was all about Mars, and today we're going back to the moon. It's been a while since man landed on the moon, and it looks like there's a lot of interesting stuff happening around the moon right now. We are going to spend the full day talking about it, and as usual, we have divided the day into 3 segments. Before noon, we are going to have a number of introductory keynotes, presentations, demonstrations designed predominantly for our younger audiences, as well as educators, teachers, people who would like to take their first steps into the world of space exploration, the moon in particular. So we're going to talk about things like Mars and lunar rovers, 3 segments on the subject, the history of astronomical observations on the moon, and we'll have an interactive quiz for children, as well as the live stream from the Mars Yard. Really wonderful energy there. Yesterday, as I was walking around during the day and in the afternoon, I saw quite a lot of parents and children coming, exploring, talking to our exhibitors, testing different robots, big and small, and as well as admiring the actual contests and competitions going on in the Mars Yards. In the Mars Yard itself. So we will talk about zero gravity on the moon and how astronauts deal with it. We will talk about the space habitat with remote operations. We'll talk about the Chinese space program, International Space University, and behind the scenes of the Thales Alenia Space Lunar projects. Ladies and gentlemen, without further ado, let me just invite you to the first item on our today's agenda, Mars and Lunar Rovers, Part 1, a presentation of the projects of young constructors of OMSA winners.
Świętokrzyskie. Naturalnie.
Dzień dobry Państwu. Witam serdecznie z wirtualnego studia Planetarium i Obserwatorium Astronomiczne.
Welcome from the virtual studio of the Technical High School, Copernicus Technical High School in Grudziądz. Well, the European Rover Challenge is underway, and part of the activities are carried out remotely due to the pandemic. This year we decided to talk to you about how young people in Poland take part in the space conquest. European Rover Challenge is for academic teams around the world. While we have a team from Polish high schools, that are involved in all kinds of space projects. One of these is robotic team Grudziądz. This team
związana jest z działalnością koła mechatronicznego prowadzonego przez
is
profesora
composed of members of the mechatronic circle, headed by a professor of the technical high school in Grudziądz. And there is a planetarium on the rooftop of our school. And now you're going to learn how this high school team designed a modular rover and tractor, which will find wide application due to the fact that it's modular, in fact. Maciej Jabłoński is with us, the head of the scientific circle, who will talk to us about the project before we hand over to the high school students. Antarctech is a project carried out currently, starting from May this year. The international, well-known international concern ABB noticed our activity, and our high school scientific circle has received its support in the construction of this rover. We are the first technical high school collaborating in this way with ABB. As of today, we are in the middle of the purchasing process of the elements necessary for the construction of the rover. Antarctech rover, which we are building, carries on a single working platform interchangeable elements. This is a lunar Martian rover with a robotic arm for collecting samples and their transportation. That's one part of the rover. The other part of this big project is the implementation of space solutions for Earth-based applications. The time of lockdowns, the time of the pandemic of COVID-19 has demonstrated to what extent we are dependent on external contacts, which cannot always be carried out normally. So this Earth application for the lunar rover is a drug track with the task of providing a sick person or a disabled person or quarantined person deliver drugs from the pharmacy. It can transport the drugs on the cycling ways, on sidewalks, using GPS-based navigation. And its task is to deliver the drugs to the patient. Of course, there's a loading of the load-carrying part that is secured with a special lock, and its range will be around 20 kilometers, so it can go a maximum of 10 kilometers from the pharmacy, which is enough in terms of distance to service a medium-sized town to be serviced autonomously from a single pharmacy. Right, thank you very much. That sounds really interesting. Now let's listen to the students talk about their project.
Ta prelekcja została również zaprezentowana na ogólnopolskim młodzieżowym seminarium astronomicznym.
This has been also presented during the Pan-Polish Astronomy forum which took place for the 47th time in Grudziądz this year. Hello, as Antarac Tech, we would like to present the modular space rover to be applied on Earth. Patryk Wasilewski, Robert Kobylski, Julian Wojanowski, Magdalena Szymaniak, and Jakub Ambrożak are the team. The main assumptions. The main assumption for us was reliability and modularity. We created a model of a vehicle that can be used for building space stations for astronauts or as a stop for further travel in space, and it can also be used as a transportation vehicle.
Nasz model pojazdu został wyposażony w dopracowane, wytrzymałe oraz niezależne zawieszenie.
The chassis is reliable, built with solid materials, and it is stable, and it contains few moving parts, which means lower risk of damages. And we have a high terrain capacity with possible higher loads. Big, wide wheels mean that the vehicle can travel in difficult terrain, which is oftentimes the case on different planets. There are 6 engines, which allows for transporting heavy loads. In every engine, every engine is independent, which means that it does not require frequent repairs. The steering system is very reliable. The suspension is based on pneumatic sections. There are separate front and rear axes. The solution applied means that we can regulate the pressure in the systems. We can decide about the pressure in the front or in the rear axes and influence the leveling of the whole vehicle as a result. All moving elements are connected in such a way that we have the certainty that each element is well adapted and plays its function.
Zdecydowaliśmy się na taką budowę, aby móc z łatwością poruszać się w trudnym terenie.
We decided to go for a construction that's easy to operate in difficult terrain. There is full LED lighting. Also, the system, the rear system, is based on a system that provides for security.
Ramię. Zacznijmy od mocowania w naszym modelu.
Well, let's start with the fixing of the robotic arm. It is fixed on the suspension with the connecting element with a special system, wheel-based system, minimizing the torsion with the base. The arm revolves. Its length is 75 centimeters and its capacity is 2 kilograms. Thanks to 2 mechanisms at the base of the arm with a moment of 13 Newton-meters. At the end of the arm, there is a grabbing element, which allows for loading elements, moving elements. The arm is going to be 3D printed and strengthened with metal materials where necessary. Modules. A big advantage is the fact that the device is modular, which means that it can be adapted to particular needs. The modules have fixing systems to make the entirety secure in transportation. They have different applications depending on the equipment. It's also possible to combine the modules so that small space colonies can be built. types of modules.
Sypialniane. Miejsce do odpoczynku,
Sleeping quarter,
nocnego
a
zalogu.
place for rest and sleeping of the crew with strengthened walls. A single module can be used by 4 people. It is equipped with 4 beds and casings for personal items.
Wyposażony we wszystkie narzędzia
Workshop
niezbędne do
module,
prostych
equipped with all
manewrów
kinds of basic tools for repair, with a large work table.
energii słonecznej. Główne
Solar
źródło
energy
energii na
module,
planecie.
the main source of energy on every
Może dostarczać prąd do
planet.
związku oraz przygotowany jest dużo
Equipped with an
miejsca na
accumulator
przenośną
which
energię,
provides
tak aby
energy
energii
at
starczyło dla
night
małej
time.
kolonii. Moduł
Enough
czujników.
energy for a small colony.
Moduł czujników zajmuje się
Sensor module.
pomiarem temperatury, wilgotności, zanieczyszczenia
It
powietrza
takes
oraz
care
komunikacji.
of measurements of temperature, humidity, and others.
Podzielony na wodę przygotowywaną
Filtration module, which filters water for washing and drinking. The filters are so prepared that they are very durable and as small as possible. Warehouse module,
tak, aby zapewnić
equipped
bezpieczne miejsce
with
do przechowywania jedzenia,
hangers, shelves for storing food and other necessities. Loading module for transportation.
Łącznik modułów. Jego zadaniem
The
jest łączenie
fixing, the
wszystkich
connection
modułów,
module
dzięki
that
czemu
combines
można
different
budować
modules so that you can
niezależną stację
build
kosmiczną.
an independent small space station. Visualization. You are about to see the vehicle on the ground.
Odpowiednik na naszej planecie, czyli drag track.
Now the application on Earth, drug truck. A module has been designed to adapt to the vehicle for the needs of Earthlings. One such application is a drug truck whose task is to transport drugs to ill and disabled people from the pharmacy directly to their home. It is so prepared that it can deal with all kinds of forms of terrain in the city. It carries a digital lock which makes it impossible to break in for an unauthorized person. Costs. You can see the cost calculation of both vehicles. Also possible errors in calculations in a 3D print are included, and the price stands at around 8,000 zlotys.
Współpraca z ABB.
Collaboration with ABB. The purchase of material for the construction of both vehicles will be financed under our collaboration with ABB. Let me mention that we are the first scientific circle from a technical high school that collaborates in this format with ABB. Thank you very much. Antrak Tech. Thank you for your attention.
Bardzo dziękujemy.
Thank you ever so much, dear students, for this absolutely stunning presentation of their work, their scientific and construction work so far. Who knows, perhaps the rover, then perhaps this device can, in the near or farther future, be sent into the space indeed. The Grudziądz Planetarium, from its very beginning of the European Rover Challenge, has been part of the whole activity. We are under huge impression of the competition, and we keep our fingers crossed for a good continuation of this endeavor, and hopefully maybe one day also high school students will be able to compete at a slightly lower level than the academic teams at ERC. It's worth looking at ERC before the pandemic in 2020, we were there. And we had the opportunity to see what a fantastic event that is when we can meet live. Thank you. See you soon.
Next up, how are craters on the moon formed? Here to talk to you, we have our young, brilliant students from Almukantarat, the Astronomical Society, and they will explain to you and show you how to replicate this experiment at home. Enjoy.
Cześć, jestem Marcel z klubu
Hi, my name is Marcel from the Astronomy Club Almukantarat. Today we're going to learn how the craters were formed on the moon, and we will have a short experiment that you will have an opportunity to repeat at school or during your holidays. Go outside and take a look on the moon. You will see some oval shapes and some stripes. These round elements, these are craters, and these lines, these are radius.
Zastanawiałeś się kiedyś, jak powstał taki krater?
Have you ever thought how these craters were formed? One day, meteorite or its part or a planetoid hit the surface of the moon and crushed regolith.
Na wszystkie strony?
So thus the stir got distracted and created such patterns. We will tell you how to do it. Now, ingredients. You will need some flour, cocoa, colorful pepper or its replacement, a bowl, 2 spoons or a sieve, and some stones that will be our meteorites. So firstly, cover your bowl with a thin layer of flour. That will be our moon surface.
Następnie równomiernie
Then cover it with colorful pepper, our minerals.
Na sam koniec posypmy wszystko
And
kakao.
now pour some cocoa on it. Do it by means of a sieve in order to have an even layer. But you can do it with a
Kakao będzie
spoon as
reprezentować
well.
regolit.
So cocoa will be our regolith. And it's
Aby
ready.
zasymulować uderzenie
So
skały,
now, in
należy
order to
wypuścić kamień z rozsądnej
simulate
wysokości.
the rock hitting it, just throw a rock.
Kamień stworzył bardzo ładny krater.
So we have a perfect
wgłębienie to
crater. This hole
Powierzchnia
is our
Księżyca jest bardzo
crater. The
bogata w różne
surface
minerały.
of the moon
Zastanawiałeś
is
się dlaczego?
rich in many minerals.
Właśnie dzięki
Have you
uderzeniu
ever
meteorytu.
thought why? Thanks to meteorites and their impact, because under surface material gets dispersed and minerals which were hidden under the surface go outside. You can observe it also in our experiment. You can see these little rocks that our rock has made these white patterns visible. So these are ready of our craters, similar to those present on the moon. But you have to remember that not all meteorites hit under the same angle. The angle may be different. Try like this.
Widzimy, że promienie
You can see
pochodzące od
that
tego
the
wyglądają
radii
inaczej
look
poprzednio.
totally different.
Zauważymy, że po tej
You will
stronie nie
see
powstały,
that on
nie
this
powstał żaden
side
promień.
there is no radius created
Wszystkie są po drugiej
after the
stronie.
impact. All are on the other side. So thanks to that, by taking a look on the crater, you can jump to conclusion about the angle of the impact. Now let's experiment a bit, add some new layers, or change angles, or change the size of the rock. Have fun!
Well, I don't know about you, but my favorite part was when the instruction was just remember to throw it from a reasonable height. So, personal piece of advice, just make sure you don't choose your mother's favorite piece of porcelain for this experiment. Just use a regular one. Ladies and gentlemen, our next item on the program is Mars and Lunar Rovers Part 2, presentation of the projects of young constructors of OMSA winners.
Dzień dobry Państwu. Witam
Good
serdecznie.
morning, ladies and gentlemen. Welcome from our virtual studio and the Nicholas Copernicus Planetarium in Grudziądz. Today it's another day of European Rover Challenge. University teams are competing with their rover. But let me once again take a closer look at the projects carried out by Polish students and Polish pupils with regard to technical equipment that can be applied in the outer space, including rovers, Mars or moon rovers to be precise. So in a second you will hear about a great project carried out by pupils from Gorzów Wielkopolski that was presented during 37th Youth Astronomic Festival in Grudziądz. They got to the finale, to the national finale, and I can disclose that these young people were very successful. They presented their project before 6 people jury, and they scored really high. But before you hear about this project of the Mars rover made by students, let me connect with Rafał Grabiański and let me ask him about a short summary of what is functioning now on Mars already. I know we have connected with Rafał, so the editor of Urania portal. Hello, Rafał.
Dzień dobry Państwu.
Good morning, ladies and gentlemen.
W tej chwili na Marsie
Currently, on the surface of Mars, we have 3 functioning rovers, 2 American and 1 Chinese. The oldest functioning rover is Curiosity that was sent in 2012. It's the first 1-ton rover, so quite large in comparison to a vehicle, to a car, which is carrying out experiments, geological experiments mostly. It has chemical lab on its board, thanks to which you can examine rock samples in situ. So it has also a drilling mole. It's capable of examining the content of the atmosphere. So it detects and examines all mysterious gases present in the atmosphere of Mars. When it comes to Curiosity, its main purpose is to follow the water, so to look for some geological evidence that there used to be liquid water on its surface. So that was quite important part of its mission, and it's done in the following manner. So the Curiosity is looking for some particular minerals which are characteristic for places filled with water. Based on that, we can predict that water was there on Mars. Curiosity is the first large rover with a mobile laboratory. Perseverance is another one, American rover that was launched this year, 2021. And in case of Perseverance, its objectives are quite similar, to examine and to carry out research on the history of Mars and water. It landed near G0 crater. It's quite a complicated place in terms of its geological features and formations. So it's very difficult to land autonomously in such a difficult terrain. Fortunately, it succeeded, and it fulfills its mission of detecting minerals, examining minerals. However, it is not equipped with a mobile lab. The mobile lab has been replaced with some device for processing of rock samples and encapsulating them in special boxes. So this rover Perseverance is looking for some interesting samples, and then it gets them encapsulated. So these samples will be collected by some future mission realized in cooperation by the Americans and Europeans. We have also Tianwen-1, a Chinese mission, and its rover present on Mars. This is the first autonomous mission, Chinese mission on Mars. Up to now, the Chinese got some experience from sending rovers to the moon. And in case of the Chinese mission, this is a technical demonstration. This is to show that the Chinese technologies allow for safe landing on Mars. The rover is much lighter than the American ones, than Perseverance or Curiosity. However, on its surface, you can find a lot of different instruments to carry out research on its environment. So it has spent 100 Martian days on Mars already, and it was its planned lifetime. However, the mission team decided to extend the mission as it proved highly successful. The rover is still functioning and all its equipment is working. Thank you very much for this summary on what we can see and what we have on Mars. Thank you very much and see you soon. And now ahead of us, a short presentation, short lecture on the research and construction project delivered by people from Ostrów Wielkopolski, learning in the Technical Schools Complex. This is a school that has been very active and famous for many construction and robotics talents. So many people from this school scored a high in AMSA competition. So let's start. Possibility rover. So we got inspired by Perseverance missions. Soon after this event, we came up with the idea to build our version of a rover. Let me present you what we achieved with regard to this undertaking. So Perseverance is now active on the territory of Mars. It landed in G0 crater in 2021, so its place was not selected by mistake, because in this location we have some evidence that water might have been present there in a liquid form. So the objective of Perseverance is to prove that we had a liquid water on the surface of Mars. All the information collected by Perseverance will allow us to answer the question about the atmosphere and the climate on Mars thousands or even millions years ago. So let me present what we constructed. In order to provide mobility, we proposed a suspension that was also used by Curiosity and Perseverance. We have a very differentiating feature that makes this suspension really unique. We have a rocker, one on the left and one on the right, which is connecting both wheels. While moving and maneuvering through an uneven terrain, this suspension levels it and stabilizes the rover, especially when dealing with some really difficult landscape features and geological formations. It can operate on sandy terrain as well as on rocks. We use special durable materials and very hard plastic. All elements of the suspension were designed and made by us. It doesn't matter whether they were aluminium or plastic. The body work of our rover is made by aluminium steel. To be precise, we've used special power batteries, 5,500 ampere hours. Thanks to that, it can operate 12 hours long. In order to exchange information between computers, we used Ethernet network. When it comes to the arm, we have a special manipulator to allow it to interact with the surrounding and to make its movements really precise. So that provides great lifting power to our rover. Thanks to reverse kinematics, we can achieve a given and precise position. So it easily allows the rover to operate forward and backward. The rover doesn't need high computing power to operate. We have designed our own algorithm. Perseverance, apart from its advanced arm, has 38 empty tubes to take samples. They are adapted to be collected and taken back to the Earth. The objective of Perseverance is to collect diverse samples, as different as possible. It's possible that it will provide us with some information about former life on Mars. Cameras. It's a 6-watt camera. Thanks to that, we can observe the landscape, and its vision is 250 degrees. It also the camera is also active at night. Sensors. On the bodywork near the tower, we have a set of sensors. Thanks to them, we can get information from the surrounding. So we have the pressure meter, we have magnetometer, temperature sensor, humidity sensor, CO2 sensor, and others. One of the objectives was to look for some forms of life on a distant planet. We want to detect methane or other organic material. We want to find an answer to the question whether water was present on Mars in a liquid form. So the Perseverance is looking for some evidence of some microbiological form being active on Mars in the past. So we will examine all materials and all substances for some presence of life. We have sensors detecting organic material. We can sense their concentration in a given location. So we know such organisms on Earth which are called extremophiles, which are able to survive in very difficult conditions. It is possible they're present also on Mars. And they are very resilient to radiation, more than any other animal. Perseverance, apart from standard sensors, it has some some technologies of the future. One of them is MAXI. It's to capture oxygen from the Mars atmosphere. Another one is MEDA, to carry out other research on the atmosphere. LiDAR will allow us to measure temperature and the force of wind. Thanks to this examination and this research, we will understand Mars better. Apart from taking samples from the ground, Perseverance will also capture some information about the environment while landing. It's also equipped with so-called Sherlock equipment. We have several antennas for communication with different frequencies in order to allow for swift communication. Sometimes you have to wait about 20 minutes to get response to your signals. So the rover have to complete its task on the surface of Mars and send its signal. The largest distance, when the distance on of Earth and Mars is the largest, this communication time is even longer. So that is why we work in 3 waves. To be sure that each information will be received by the base, we have defined the protocol similar to CPT computer networks. We had to adapt it that this radio is just a duplex. We had to secure the data from any damage of the equipment. The server is an intermediate between user interface and rover software, so that procures data in the right manner. It is written in Python and it's based on JSON, a popular communication format. We wanted to do it in order to limit the transfer of data from rover. It has to be transmitted in the most condensed manner possible.
Interfejs użytkownika.
User interface. The user interface uses state-of-the-art framework used in Discord, Skype, or Microsoft Teams. So SpaceX used quite similar technology in its Dragon. And in its displays, the program is informing about every change that happens to a rover. It displays image from the camera, allows for steering and controlling the rover, and is controlled with a joystick or with a mouse. So you can manipulate with the lighting settings and with camera. In the future, we will learn more about the surrounding world, and we will see something which is not possible to see today. For example, distant planets. Thank you very much. Thank you very much, dear students, for their great presentation. We can see that Polish students, even at high school, they are ready to complete such an advanced tasks. Let's keep our fingers crossed for them. Maybe in the future, thanks to their possibility to develop their passions during their studies and in the companies from the Polish space industry, maybe someday we will learn that Polish rover is present on the surface of Mars. I wish that to all of us. Thank you.
Ladies and gentlemen, and now let's take a look at the history of astronomical observations of the moon. We have a film prepared for you by young space enthusiasts from Go Natura Kielce. We hope you enjoy it.
Witam was! To ja, Paxi. Dzisiaj
Hi,
będzie...
this is me, Paxi. We're going to discover the moon today.
Czy księżyc istniał na niebie od zawsze?
What do you think? Has it always been there or not? Let's go back 4.5 billion years and see with our own eyes. Most scientists believe that the moon was created as a result of an impact of a young planet with the Earth. That was an impact indeed, and huge amounts of material were blown into the space, which combined formed the moon. If you want to learn more about the moon, follow me. Most planets in our solar system have their moons, or, as they're called, their natural satellites. Some have a few, and Jupiter even has 79 of these. These are really quite a number. The Earth only has a single one, but a very special one, and it's so beautiful as well. And it's so light because it reflects the sun's light. It orbits around the Earth, and at the same time it revolves. The Earth and the Moon go together around the Sun. The Moon takes around a month to go around the Earth, and different phases occur during on the way, and depending on which way the sun shines on the moon. Well, looking from the southern hemisphere, when the moon is on the same side as the sun, that's the first phase, and the moon is invisible. When it goes 1/4 of its way, it's seen as half the moon, that is the first quarter. It looks like a huge D. Halfway through, 14 days from the start, we see the full moon. This is my favorite phase of the moon, because the full moon is visible. Just look at it. After 21 days, it has gone 3/4 of the way, and this is the last part of the way. This is also a D letter, but turned around. And now, looking from the northern hemisphere is the other way around again. So, well, after going the full way around the Earth, it goes back to square one and everything starts anew. So, the moon is always there in the sky, but not always visible.
So clearly that was the history of astronomical observations of the moon, as you could see, very much clearly designed for the benefit and enjoyment of children. And now we go to our next item of the program, interactive quiz, also for children. Explore the moon and Igluna. Here to talk to you about it, Tatiana Benavides, representing Igluna.
Thank you, Lucas, for the kind introduction. Indeed, I'm Tatiana Benavides. I'm working at Space Innovation. We are formerly the Swiss Space Center, located at both Swiss Federal Institutes of Technologies in Lausanne and in Zurich. And I'm here today to do this interactive quiz with everyone, children, of course, but if you're an adult, you can also participate. So the website will appear in the YouTube chat soon. And I will just say it slowly in case you're typing it. It's www.space, like written here on top, SPACE hyphen innovation, INNOVATION.ch. So if you type that address and I let you get your phone, your iPad, whatever you have in there, you will come to this website. And that's our website of Space Innovation. I invite you, not now, but afterwards, if you want to scroll and know about our activities, who we are, and contact us, you feel free to navigate there in our website. But now let's go to the quiz. Here you see the bottom, join the quiz. So we click here and the quiz page appears. So we will start. I let everyone connect. I give another second. It takes, here it says 3 minutes, but we will take longer because we will go slowly question by question. So there's 10 questions in total. And there are, well, for general culture, you will learn a lot and for sure you will have fun. And let's see how much you know about the moon. I saw yesterday there was Mars, but there was also some moon topics coming up, and also this morning. So maybe you're already a moon expert. Let's test your knowledge. And if not, don't worry, you will learn here. And the last question will be actually, it's 11 questions because the last one will ask you your email address if you would like. We will choose a raffle, depends how many people are getting so many points. So the ones with the highest score will get a small gift. If you would like us to send you a small gift, please write your email address. And if you're one of the lucky winners, we will contact you to get your postal address. Okay, so are you ready? Let's start now. We click on start. And the first question is, what was the space probe flying by the moon? Do you know the answer? We have 4 options. A is Luna 1, B is Luna 3, C, Ranger 7, or D, Apollo 8. What do you think? What is the best or what is the right answer actually? Let's check it out. I hope you clicked already on your choice. Let's see what is the right answer. It's Luna 1. It's from Russia. It was the first mission to fly by the moon in January 1959, so already a long, long time ago. Later the same year, Luna 3 photographed the far side of the moon, never visible from Earth actually. And Ranger 7 from the United States transmitted close images of the lunar surface back to Earth in 1964. Then the American Apollo 8 mission was in 1968, so a bit later, and it was the first crewed spacecraft that circled the moon. So it was the first humans going around the moon, but not yet landing on it. That was in 1969. So let's see now the following question. When did the first vehicle landed safely on the moon? You had already some dates there from the previous question. Is it letter A, 1960, B, 1963, C, 1966, or 1969? So which one landed safely on the moon, not just going around, but actually landing there? Do you know the answer? Let's check if you have the correct one. The correct one is 1969, and that was the Soviet spacecraft Luna 9, and it became the first vehicle to land safely on the lunar surface. It was stocked with scientific and communications equipment, and the small spacecraft photographed a ground-level lunar panorama. So this was really great for us to know how the moon looked like very closely there. Question number 3, who has been to the moon? Is it only men, women and men, some dogs, or no one? What do you think is the right answer? So now you click on it and let's check if you have it right. The right answer is only men. Actually, we need future missions that will benefit from grooming astronauts as well. We need also women to go to the moon. And of course, also maybe dogs in the future and all other species. Let's have a look at the fourth question. How many men have been to the moon so far? Is it 5, 12, 25, or 52? What do you think? Let's have a look. The correct answer is 12. All of them were part of the American program Apollo from 1969 to 1972. It's been a while now, so it's time to go again to the moon. Great. So we're halfway there with the fifth question. And this one says, when is the next human mission to the moon planned? So that's actually coming up soon. Is it next year already in 2022? Or maybe 2023, 2024, or 2025? What do you think? Let's see if you got it right. Well, it's actually planned for 2024 with the Artemis 3 mission from NASA. Let's hope there's no delays. And this should be the first crewed lunar landing mission since 1972. So more than 50 years later, we're going back to the moon, or forward to the moon, as we say. And now, question number 6. What is the main danger of living on the moon? Option A, there is no candy. So that could be dangerous if you really like candy. Option B, the lack of atmosphere. C, it's gray. Or D, because it's smaller than Earth. What do you think it's the most dangerous? I let you have a minute to think about it. And now let's see. The correct answer is the lack of atmosphere. So at the moon, it makes it impossible, this lack of atmosphere, for humans to breathe. There is no oxygen like here on Earth. So they need a support system, and it doesn't protect them from micrometeorite impacts and harmful radiation passing through the surface. It also fails to provide a constant temperature, so there's extreme changes. It's very hot at 100 degrees, but it could also get very cold at minus 170 degrees. So really the lack of atmosphere is the main issue we have to tackle to go and live on the moon, or one of the main issues, actually. Question number 7, what systems are needed to start a colony on the moon? So here you will see some options, and here you can click on one, or maybe you should think it's all of the above. So letter A is life support systems are needed, or B, power systems, C, communication and navigation systems, D, construction, or E, all of the above. What do you think? Which one do we need, or do we need all of them? Let's see if you got it right. So the correct answer is all of the above. Of course, we need a shelter to be constructed with a life support system to provide oxygen, food, and take care of the waste. So at the moon, there's nothing like here, like you have trees, you have, well, just breathing oxygen like we have, it's not over there possible. There's no food from trees for plants. It's not like here we have the farms. And also to take care of waste. So there's usually not at the moment the pipes to take care of all the waste humans produce. So astronauts will also need to communicate not only within the moon with different parts of the moon. If, for instance, one is in the habitat and one is outside doing an extravehicular activity or with a rover, but they also need to communicate back with Earth. So they need communication and navigation. And all of these systems, of course, require power. So we need everything to colonize the moon. Moving forward to question 8, what is this? Is it intelligent plants, a robotic greenhouse, a refrigerator, or an oven? What do you think? So there's the picture there. We see an astronaut. We see something green, could be like plants in boxes, and looks like a funny structure. What do you think it is? Let's see if you got it right. It's a robotic greenhouse. It's actually from the Luna project, and the team is called Grobot Hub. They're at EPFL in Lausanne. And this team of students aim to for a fully automated system to grow and harvest vegetables in an extreme environment. And you can learn later about Tigluna. I'll be doing a presentation about it at 12:10 Central European Time today, so you can stay tuned in the YouTube, or if you're watching there on site, well, of course, stay for the whole program, but if not, come back at 12:10 to learn more about Tigluna. So now let's see the next question. It's another one of what is this? What do you think it's this picture? A new type of insect, an ant living on Mars, a small rover, or a lamp? Looks interesting, right? It has white, it has something like some legs and something on top of it. What do you think it is? Let's check it out. It's a small rover from the Luna team called Lunar Zero. They are from TU Delft in Netherlands. And their objective is to have a swarm of small rovers like this one to scout and explore rough surfaces, craters, caves, and lava tubes. Could be in extreme environments here on Earth, but also in the moon. So you can learn more about Igluna and all the teams that have participated later today at 12:10 for the presentation I'll be doing later on today. And now the last question, why should we go to the moon? You can actually click on all of them, in many of them, as much as you want. So this is a multiple choice question. Is it for a fancy vacation? Is it to learn more about the solar system? To develop technologies that could be useful for Earth? Or to inspire people of all ages? So this is, I think, a personal question. Everyone can have their own motivation, and you can have one or several. So what do you choose? And let's see now the explanation. So actually, it could be any of them. For a fancy vacation, of course, could be nice. And now space tourism is flourishing, creating the possibility for humans to travel to the moon for recreational purposes. They're actually now going at the, well, just on the limit of space with the new technologies of the flights that are being developed. And soon the purpose is to go to bring tourists also to the moon. But also, it's an important aspect, at least on my side, is to learn more about our solar system and the universe. So a lot can be learned from the moon. It is a geological time capsule that can explain what happened in the solar system's past and also help us understand more about our Earth and how it was created. It's also important to enable human exploration and colonization of the moon, and it creates inspiration, so making dreams come true and encourages the development of innovative technologies, of course, that are useful to continue space exploration, but they also benefit life on Earth as well. So those were the 10 questions of the quiz. Now, as a last point, you have here, if you want to enter your email address, we have prepared some stickers, some space patches. If you would like to have them, enter your email address. Depends how many of you got the answers right. We will do a raffle, or maybe everyone wins. Let's see if we have enough prizes for everyone. So just type in your email address, and then we will be in touch with you if you're one of the winners. So you can give us your postal address and we'll send it to you by post. So now that was it for the quiz. You can click submit. Thank you very much for joining our presentation today, our quiz today, this morning. I hope you enjoy it and you learned also some important facts of the moon. You can also share now with your friends that you know these important things and really interesting things about the moon. And please stay tuned. Watch the whole event today, tomorrow. Rewatch yesterday's event in the YouTube channels, and also join me later at 12:10 Central European Time for the Igluna presentation. Thank you. Have a good day. See you later. Bye.
Ladies and gentlemen, time for us to visit the Mars Yard. I've already been there today and I saw it's really hectic. It's like a hive already, but it's barely 11 o'clock in the morning. Yesterday it was packed, so take a look.
at Kielce University of Technology. My name is Remco Timmermans and I will take you live into the action during these live stream intermezzos. I will talk with the people who make this event the biggest space and robotics event in Europe. This morning I'll be talking to Dr. Anna Wozniak, the chief scientist at ERC, if I may say so, and the designer of the Mars Yard. So Anja, every year the ERC Mars Yard is redesigned, reflecting different areas on Mars and different features. Can you take us through the design of the 2021 edition and the scientific ideas behind it?
Of course, yes. As you mentioned, every year we are trying to have some new tricks and new ideas to show our teams and our people that visit our competition. This year we are going to visit, virtually kind of, visit Elysium on Mars. Elysium is a very interesting location because it's a place where volcanoes are meeting ice. So very interesting from the geological and also potentially astrobiological point of view. But this area was selected for this particular year, 2021, not by chance. We have selected the region of Elysium because there were a couple of publications released this year that were pointing to possibility of still having active volcanoes on Mars surface. The first publication was released in the beginning of this year, and this was actually the reason why we set it up on this team, because the design of Mars Yard takes a long time. It really starts very shortly after the previous edition of ERC is done. So the paper that I'm referring to suggested that in the section of Elysium there can be geologically active volcanoes. And it was based by kind of standard planetary geology method, some mapping of the area, how fresh it looks, crater counting, all that stuff. And additionally, a lot of people were not believing this paper because this is kind of shocking suggestion to make. However, only 2 months ago, data from InSight was released, and this data actually suggests that not only the inside of Mars may be still hot, so may still produce some magma, but also around the same location that was suggested in this previous paper, there are a lot of Marsquakes. Marsquakes that may suggest that lava is moving there, exactly at the same spot. So I would like to say that we are very up to date with the current state of geological research on Mars, and also quite exciting because our volcanoes are also erupting.
Excellent. Well, thank you. That was a very good introduction. Now, not only does the Mars Yard reflect the latest in science on Mars, it should also offer interesting challenges to the teams that we see behind us here. What are the key challenges built into the Mars Yard to challenge the teams? Yeah, so actually the first thing is that it's challenged to prepare that to be challenging enough for some of the teams and easy enough for others, so that everyone can participate, even though maybe something broke down and they are not able to participate on their full capacity, or the team is just starting, so they need also some easy parts to travel through, and also very complicated and tricky parts. For example, some of the, I think, the most evil parts that we have designed this year are not only the impact craters that are pretty deep, and some of the rovers may, once they go down, they may never go up. But we also have a very sneaky lava caves. Down there, if they are not driving carefully, if they are not paying attention to their surroundings, that may be their last movement on this Mars Yard. So plenty of places for the rovers to get stuck. And right behind us, we see this one, Escape one of the craters. So so far so good for
That's a very easy crater, very old, a very eroded crater.
Okay.
The other ones are not like that. Again, we have different levels of complication for different teams.
Right. Looking at the images from Mars, we see a cold, seemingly endless, dead desert. Yet scientists, much like yourself, look at the Moon and Mars for clues about the origin of our solar system. What can we find on the Moon and Mars that we cannot find on Earth? I mean, Earth has rocks and deserts too.
Yes, we do, but those are different rocks and deserts. Some are quite similar, some are others, but for example, only by going to the Moon and to Mars, we can learn a lot about the very, very early Earth. And it's a very important question because we really don't have much information about how our own planet looked like when the life was being formed here. We do not understand the situation, and this is caused by the fact that we have very, very active geological processes happening on our planet. We have plate tectonics that are constantly crushing, remelting, recycling rocks, which means that all the information that we had, all the rocks that were formed this 4 billion years ago are just gone. There are only like really, really resistant pieces of minerals that are left over that survived all this time, but they are very limited in what they can say about Earth. However, on other planetary bodies, like on the Moon, like on Mars, geology is less enthusiastic, less active, which means that all those interesting rocks from the beginning of solar system have survived. So we are going to Mars and Moon not only to learn about those other bodies, but also to learn about our own planet, to figure out how life was formed and why we are here.
Okay. Thank you very much. Now, you said this Mars Yard is designed specifically for this year's competition based on papers that you read early on this year.
Not only me, I would like to clarify that I'm not the only person that works on all of that. I would never be able to do that alone without my amazing team. We are really 6 to 8 people working for a year to make sure that this looks and works as it does.
Fantastic. Yeah, of course, this whole event is teamwork.
Yes.
It's all people who are doing the work. So a very good point that you're making here. But have you read anything after doing the work here that has already inspired you for maybe subsequent editions?
Oh, I'm not spilling the tea. No. That will be the thing to think about after we are done with this edition. Maybe I have some ideas. I'm not saying no, but we cannot exclude that there will be a paper that will show up that will be saying something extremely interesting, and we'll decide to replicate that in our current Mars Yard or next year, I mean, as we did that for this Mars Yard here.
Right.
We were not imagining that we will have active volcanoes on Mars Yard.
Fair enough. Let me ask you the same question the other way around. What are the key lessons learned from previous editions that are now built in here?
Oh, that's a very interesting question. Well, I think that the important thing is to make sure that all of the features that we see here or some of the features are clearly interacting geologically and others are not so clear. Because what the scientific task is all about actually is not only, just drive around the Mars Yard. It's not a pile of rocks randomly distributed. No, there is a geological story that is within this piece of environment that the teams are supposed to figure out based on the remote sensing data, aka drone data, that they get before the mission. They analyze the data and they prepare a geological map. Based on that, they figure out how to where to go to, where to analyze everything, and during the mission they have to execute their own plan. So the main important thing is to not to make it too easy and not to make it too hard,
Right.
because some teams will not be able
Right,
to
that makes
figure it out.
perfect sense. Okay, well, thank you very much for this introduction, Anya. Please keep watching the live stream. We have a lot more coming on. Follow us on social media. We are on Twitter, on Facebook, on LinkedIn,
And
on
come
Instagram.
to Kielce.
And of
next
course,
year.
if you can, today it's a beautiful day. We're continuing tomorrow. Come to Kielce.
This year
and-
or next year, wherever we will have the ERC.
Of course. So thank you very much.
Manual. Manual.
Nie możesz nic zrobić? To, rybka.
Dobra.
Dzień dobry Państwu. Marek
Good morning,
Banaszkiewicz,
ladies
kierownik
and gentlemen.
oddziału
Marek
Centrum Badań
Banaszkiewicz,
Kosmicznych w
the head of the Central of Space Research of the Polish Academy of Sciences, would like to show you our robot with manipulator, the robotic arm that we've constructed recently to use it for testing and for controlling, to experiment with artificial intelligence. So I will tell you what's going on in that respect. I can see that the film is on. So our unit was set up about 18 months ago, and this is just a sneak peek to what we can do in cosmic and space robotics. This is an example how we can perform a maneuver or even a whole procedure of maintenance of one satellite by another one on an orbit. It may happen that some parts have to be replaced and one satellite has to approach another one with its robotic arm. It has to maneuver aptly to get closer to another satellite and to perform some operations. For example, to get rid of some broken part, replace it, or just perform an inspection of another satellite. Sometimes one satellite is inactive, becomes inactive, and it has to be removed from the orbit. Now another film. So that shows the sequence of preparation of such a complex project, how many years it lasts. And one of the elements of this process is test. Here we'd like to show you a little robot that we constructed. It was constructed on the basis of another project, so we bought a platform separately and a robot separately, and it's capable of different operations. It can collect things, it can make observations. It can detect some kind of mineral. It can be equipped with optical spectrometer to examine the spectra of the surface and of objects on it. So it can inform us about the types of minerals being present on the surface, and then by means of a robotic arm it can collect such samples. So this is a thing of the future, and everybody is trying to do it in the space industry now, because we have the perspective of colonization of the Moon and Mars and other planets then. So as far as I understood, we will have another film, or was it everything we have? Okay, so that was all we have. So I strongly encourage young talents, young engineering and robotics talents to engage in this sector, because it's very prosperous. We have great outlook for the future in this sector. We have an institute in Warsaw and in Zielona Góra, and we are willing to hire young people. Thank you.
Ladies and gentlemen, that was the Space Research Center. Next up, we have a very interesting topic to address: how not to freeze on the moon, thermal control system. Here to talk to you, Piotr Rosica, Spaceiv. Enjoy.
Nazywam się Piotr Rosica i reprezentuję firmę Spaceif.
My name is Piotr Rosica, I represent Spaceif. Let me start by telling you about temperatures up there, thermal control up there. There are three main ways to exchange heat. That's radiation, convection.
Mamy na co dzień do czynienia u nas na Ziemi. Natomiast w przestrzeni kosmicznej nie mamy do czynienia z konwekcją. Nie wiem, jak mogę to
And conduction. I don't know how to change slides. What can I do? Well, these three ways to exchange heat take place on the Earth, while on the Moon it's a bit different. In the space it's a bit different. You will see the second slide in a minute to see what the situation is like on the Earth, on the Moon, and in the space in general. So on the left you have radiation, and importantly here, radiation is very dependent on temperatures. To the fourth power.
Natomiast tutaj, jak widzimy na prezentacji, w przestrzeni kosmicznej nie ma konwekcji.
While in the space there is no convection, which means heat exchange is much more difficult for our systems, the ones that are designed in satellites, for satellites, and pieces of equipment working on the Moon.
Tutaj mamy przedstawione, jakie parametry mniej więcej możemy...
This shows you what parameters are expected on the Earth, on the Moon, and in the space. On the Earth, the highest temperatures are present in the Death Valley in the US, in deserts, and the coldest on the poles, maximum 56 degrees, minimum -93, while on the Moon this variance is much higher because there is no convection, there is no atmosphere. Because it's the presence of atmosphere on the Earth creates this friendly environment, friendly for life. Going back to the previous slide, this shows you that there is an atmosphere around the Earth which reflects part of the Sun's radiation to the space. Such atmosphere is not present on the Moon, so the entire radiation reaches the surface of the Moon. An interesting question, what is the temperature in the space? Well, the general understanding is that it is very cold, and indeed, it is true, but for something to have a temperature, then you need something to be there, some particles, some body. While the space is mainly vacuum, atoms are very few and far between, so it's difficult to say that it's cold. But, you know, the assumption is that the temperature is around 4 Kelvin, and that is -269 Celsius. This is a question we often ask our candidates. What is the space's temperature, and does it have a temperature? Now, what are the goals of thermal control? Since there is no convection in the vacuum, then we cannot use all the nice technical solutions that we use on the Earth. There are no radiators, there is no convection-based solutions. We need to use different solutions that are broken down into active and passive. The active ones are those that require some amount of energy for these things to work, to play the role. For example, one such solution are louvers. These cover part of the external surface of the satellite so that we change the thermal optic parameters of the satellite in order to influence how much of the sun's radiation reaches the satellite. Then we have heaters. Batteries are very sensitive to temperatures. Everybody knows that if your telephone is cold in the winter, then the battery loses its efficiency. The same takes place in the space. Another solution is a cryo-cooler, which we use to cool down pieces of equipment, particularly scientific equipment, so that its readouts are as precise as possible. For example, space radiation is measured by this equipment, and the lower its temperature, the better it measures the parameters. Then we have passive technologies, including heat pipes, MLI, layer insulation, radiators, and what's often used is surfaces of different thermal optic parameters, and that is, it has different parameters in terms of giving away heat and reflecting heat. A lot of these technologies were first used in space missions. This shows you these pipes. This is a piece of equipment that transfers heat very efficiently. Such materials that transfer heat very well are silver, gold, copper. But these materials are heavy, and when we send something into the outer space, we want it to be as light as possible, because sending anything into the space is very, very expensive. And this is a solution that is very light and they have very good thermal parameters. Now, this solution is very widely applied in laptops for cooling processors. The upper right corner shows you such an application for cooling processors, and down there is the same solution applied for rooftops. They absorb a lot of heat from the sun, and the whole element is about the pipe transferring the heat up there where it is used to heat up water for our domestic use. Another solution is MLI. That is special foil. It's a great insulator, but it only works in vacuum. This is because there is no convection in the vacuum. This kind of foil is multi-layered. Because there is no convection between the layers, because there is no gas between the layers. These layers cannot touch each other, so a special net, a special spacer is put in between the layers so that they do not touch each other. We use this material with very good thermal optical parameters, so they transfer very little energy from one side to the other. So this is one of the best types of insulation because it is very light and it is being used in most satellites.
Tutaj troszeczkę o historii misji kosmicznej.
To talk to you a little bit about the history of space missions. In fact, most of these missions, it all started with the Apollo missions. This shows you between Apollo 7 to Apollo 17. It all started with Apollo 1. Apollo 13, Apollo 1, was rather unfortunate because it ended up in a disaster. So 2 to 6 were crewless to make sure that the systems work, and only Apollo 7 to Apollo 10 were man crew missions without landing, though. They were based on going around the moon, then with testing a lunar module, and then on Apollo 11, after all the systems were tested, finally man landed on the moon. And up to 17 they were again all crew missions. And Apollo 13 was one where there was a failure of the systems, which was very dangerous, but fortunately the astronauts got safely back to the Earth. Thanks to the Apollo missions, we collected a lot of valuable data about what happened, what is there on the surface and under the moon's surface, under the ground. Most interestingly for me personally, a lot of equipment was installed on Apollo 12 and Apollo 14. They used all kinds of equipment that checked what was happening below the surface of the moon, what the regolith is like, what is its temperature, what is its composition. All these things are very important to design future missions. There were a lot of analyses, a lot of studies carried out during Apollo 15 and 17. Unfortunately, some things are unforeseen by man. For example, the moon dust's presence. I will talk to you about it in a minute. Before that, let me mention current lunar missions. On the left-hand side, you can see a successful Chinese mission that was carried out last year. And there have been a number of other missions, Indian and Israeli missions. The latter was unsuccessful. The probe crashed against the moon's surface. And if I'm not mistaken, the former Soviet mission Luna that was carried out by the Soviets is going to be continued now by Russia. As far as I know, they want to go back to that concept. Now, the topic of the presentation is not true entirely, because at night you can freeze to death because it's very cold, while at daytime you can get really, really hot. The situation on the moon is comparable to the desert on Earth, because the temperatures at daytime are very high and at night they are very, very low. Interestingly, the day on the moon takes around 14 days, Earth days, and the same goes for the night. So there are very long periods of very high temperatures and very long periods of time of very low temperatures. Around the equator, the temperature is the highest, around 120 degrees, while at night the temperatures are around negative 130 degrees. The situation is even more severe on the poles. Then, if you find yourself in the shade of a crater, then the temperature might be even minus 100 in the shade, although the sun shines on the other slope where the temperature is 120 degrees Celsius. So these are extreme situations. Then moon dust is a great insulator and is very particular. It is very absorptive in visible light, and it likes sticking to all kinds of surfaces. So even if we decide to paint something with white paint with white paint because it does not absorb much invisible light, but after a few hours moon dust tends to completely cover the white paint and it completely changes the parameters of the device. So then all the analyses that we carried out for the paint are no longer true. And that was the case for the Apollo mission. That was the problem during the missions. That is, the moon dust covered the equipment and they overheated. Then also with the moon dust that enters all kinds of mechanisms, they tend to disrupt the operation of all kinds of devices. But in this presentation we're focusing on thermal issues. How do we deal with such situations? We as SpaceIF collaborate with the Polish Academy of Sciences, the Mining Academy of Krakow, DRI, CBK, and European Space Agency. We are working on a device for collecting samples on the moon and carrying out tests on those samples. We are at the stage of analysis of such device, and all that I just mentioned was proven by these analyses. So a device working on the surface of the moon might heat up to 110 degrees. It works at 60 degrees if we cover it with white paint, which is rather high temperature in terms of electrical devices which heat up on their own. But if they are covered with moon dust, then it overheats. On the other hand, if it operates at night and it is not heated up, then its temperature will go down to -140. The nights are very long, so you need a lot of temperature to heat the device up to a temperature that's enough for it to operate. So lunar missions are very difficult, even more difficult than space missions, especially if you take into account that there is no atmosphere where you can evacuate the heat. So how do we deal with that? One of the ideas that we have at hand is using this device mounted on an arm on a lander. And we can then use the device in the shade of the lander in order to avoid overheating. Of course, at night we have to still deal with too low temperatures. Then we can try and insulate with MLI so that very little energy is enough to heat the device up to temperatures necessary for its survival to at least 40 degrees negative. This slide talks about how to test such a piece of equipment before we assume that it's suitable for operation on the moon. This is a series of tests, among which the most important, most interesting ones are thermal vacuum tests and functional tests in thermal vacuum chamber with regolith. Unfortunately, my time has run out and I have to conclude at this point. I hope this has been informative and interesting for you, and I hope this will encourage you to look more into the study of the moon. Thank you.
Very much, Piotr. Do we have any question? A quick question, not necessarily. One? Yeah.
Witaj Piotrze, mam pytanie, czy rozważacie na
Hi
przykład
Piotr, have you been thinking about other solutions instead of keeping this piece of equipment in the shade of a lander? For example, the solution of building regolith houses to house these pieces of equipment protected against temperature variance and radiation. Well, indeed, we are at an early stage of the project and we are looking into all kinds of solutions that will meet our needs. So protection in any form, for example, in the form of digging a hole in the surface of the moon or building some kind of hut, definitely these are solutions that are worth looking into. The problem is that these missions are short. They are difficult because such a device can be operated only at daytime because the night is too cold. So, assuming that we can first dig a hole in the regolith could be a potential solution.
Thank you very much, sir.
Dziękuję bardzo.
Ladies and gentlemen, we've just talked about temperatures, how not to freeze on the moon, and now it's high time to talk about zero gravity, how do the astronauts deal with it. Here to talk to you, we have the interview with Tim Peake, European Space Agency astronaut, special guest of VRC 2019, the interview by editors of Urania.
Hi, I'm European Space Agency astronaut Tim Peake, and I'd like to send my best wishes to the audience of Urania TV. Now, something that happens when astronauts first come into space is that they usually feel pretty rough for about the first 24 hours, a mixture of dizziness and becoming disorientated and sometimes nauseous as well. And I think a lot of this has to do with the fact that the vestibular system is a little bit messed up. All the fluid in the inner ear is in microgravity, so it's just floating, and so the brain is getting these mixed signals from the ear versus the eyes. Weightlessness is quite hard, but one of the things I say to people is, firstly, is the body's posture. One of the things that struck me, I mean, here on Earth, for example, is our shoulders always get pulled down by gravity, but in weightlessness, your shoulders are up here, there's nothing pulling you down, your whole body position changes into the most relaxed position it can be. So it's a very liberating feeling, and also it makes you appreciate the volume, how much you can use the volume of the space station. On Earth, we're used to just, sitting at desks or using walls only at eye level, but in the space station, of course, you can use the ceiling, you can use the whole volume of the space station, and your brain has to adapt to be able to work in any orientation. So it's not just a sort of physical change, it's a psychological change as well, getting used to weightlessness, but it's a great feeling. When I arrived on the space station, Scott Kelly was my first commander, and he had already been there for 8 months out of a year-long stay. Now, a year is a long time to spend on a space station, but he was in great shape physically and psychologically. The space station is a very, very busy place to work. So people often say, well, you're not bored up there. It's quite the contrary. We don't actually have that much free time, and when we do get free time, we love to spend it taking photographs of Earth. So I had the opportunity to run the London Marathon on the treadmill whilst I was in space, which was a lot of fun, but also I was doing a lot of running anyway, so for me it made sense to take part in the marathon at the same time. Parts of it are easier and parts of it are more difficult. What's easier is that you can only generate about 70% of your body weight by wearing a harness with bungees, and that harness keeps us down on the treadmill, but it gets about 70% of our body weight, so it's not 100% body weight. But what's harder is it's only designed to be worn for about 20, 30 minutes because all the weight is on our shoulders and a little bit around our waist. So after about half an hour, it becomes very uncomfortable. So to run for 3.5 hours was not easy. My greatest advice to someone who wants to become an astronaut is to try and decide what it is you want to do before you become an astronaut, because nobody leaves school or university and becomes an astronaut. And it's so critical to follow what you're good at and to follow what you're passionate about. And that way you can have a really interesting career, and from there you can be selected as an astronaut. And if you don't make it as an astronaut, you've still got a really interesting career to fall back on.
Ladies and gentlemen, we've already talked about temperatures and gravity, and for those of you who have already watched Alfonso Cuarón's 2013 blockbuster, The Gravity, those of you know that space junk is increasingly becoming an issue, and well, we are going to talk about that as well soon. In our next presentation, Kacper Synowiec, AGH University of Science and Technology. We'll meet Kacper soon, but let's first watch something together.
Dzień dobry, z tej strony Kacper Synowiec, reprezentuję zespół Black Spheres. Dzisiaj trochę porozmawiamy o problemie śmieci kosmicznych, a także
space debris and waste and scientific experiments related to that.
O czym będziemy dzisiaj
So, what are we going to talk about today? Firstly, I will present the very problem of space debris. Then I will move over to the very topic of our presentation, which is our experiment and possible solution to it, to the problem. Then I will move over to the experiment procedure and our project, and then the outcomes achieved. So, starting from the beginning, the issue of the space debris is becoming more and more evident. During the last few years, more and more objects and space missions became more popular. Satellites are sent and launched to space. It's something simple and something very popular. That's why lower Earth orbit gets polluted with some flying objects. During the last few years, we had 2 accidents, 2 crashes that increased dramatically the number of debris flying. It was the catastrophe of the Chinese satellite and the crash of two satellites recently. So why these space debris are so important? Because even a tiny element, this is a very micro element, but it can have a great impact on the International Space Station and on future missions. Because of hypervelocities, the effects might be serious and dire. On top of that, there is so-called Kessler syndrome that says that crashing elements generate other crashes, subsequent accidents. So that creates a cascade of space debris, and the probability of another crash increases. And it appears that the cost of space debris, they represent about 10% of the total cost of a new space mission. So, because new missions have to apply new shields in order to protect their shuttles from an aircraft from this debris. So the number of waste and pollution on the lower Earth orbit is increasing rapidly. You've been hearing recently about Starlink's and Elon Musk's SpaceX project that will boost in the number of these unwanted objects on the orbit. So going towards our project, there's a lot of initiatives aiming at reducing or capturing or intercepting the objects from the orbit and getting them back on Earth. There are special nets being created and robotic equipment, but there's something different, which is programming and designing future mission so that this new object could be maintained and repaired in this space, not to create and not to produce new flying objects and waste. Sometimes some objects can have some content of fuel which causes that they weight is in time is different. So our objective is to examine how this weight is shaped in time, so how they would behave based on their trajectory and observations. We were able to predict their physical features, like, for example, the inertia point or other physical and chemical parameters. Let me present our team. From the very left, upper left, it's Kamil Świtek, then Kamil Maraj, Michał Błażejczyk, and me, Kacper. So, as I've said before, we wanted to examine how these objects behave, but how to do that? We won Drop Tower contest in Bremen, where we were asked to examine the behavior of bodies in microgravity. But how to do it? The most obvious seems to send an object to the Earth orbit. But there's a simple manner, which is launching a capsule with the experiment to some distance. So we get a few seconds or some or more. In our case, it was 9 seconds. And we could carry out 5 experiments in microgravity conditions. Each of them lasted 9 seconds. So the components of our experiment were as follows. So the heart of it, these were these spheres with changing mass. Apart from that, we had a special release mechanism in order to apply and give given velocity to our objects, and a set of cameras with an adequate algorithm informing about location that was also put in the capsule. So just in short, the procedure of our experiment, and then you will see it on the movie. So in the first phase, in normal Earth conditions, so shortly before the experiment, this sphere was given a given velocity, and then in microgravity conditions the sphere was released by the mechanism, and in 9 seconds more or less of the experiment we could record the movement of a sphere with our camera. Moving forward to details of our observations. As I've said before, we wanted to measure and to examine objects with changing mass distribution. So they were put on a spring in order to have more diverse set of data. We put some masses on servo motor and on a spring, but pushed with additional servo motor. We had 5 experiments, and thanks to that we had more time for examination, for experimenting. Here, as it looked like in short, we had a mass on spring, we had some thing that was verifying what were the angle velocities. We had a distance sensor checking the location of the mass, which was very important for verification of our further algorithm in order to know how the mass changed in time. And then some nut. A short scheme, digital scheme, a simplified one to let you know how it looked like. Additional communication with our computer. Additionally, data were recorded on a memory card, but we can skip that. Here you can see a sphere which is active with the mass moved by servo motor.
Moment. O, dobra. Tutaj jak to wyglądało w środku.
So here how it looked like inside. So we printed the spheres in 3D printer. Not all of them survived the experiment because of high pressure applied at the end. So they were designed in a simple thing. So our release mechanism with this nut and spring given velocity, then the spring velocity changed and the linear velocity was applied. Then with MATLAB or Simscape multi-body, we tried to simulate as much as possible, so to try and to verify everything before the very experiment. So this is another simplified picture of how it looked like, and not in a spring, but it's also important because you have less things that can go wrong if the equipment is limited. So in short, how the sphere was released.
była nadawana odpowiednia prędkość
So
obrotowa.
firstly, the given velocity was applied. When the spring was released, then in the microgravity conditions, the direction was changed.
Inercję nadaną wcześniej wykręcała się ze śruby. I działało to
And
całkiem
then
nieźle
the sphere was released and sprung out from the spring.
Jeszcze w skrócie, że wykorzystaliśmy wcześniej
Just in short, what we did before to create our simulation environment.
Parametry, czy to silnika, czy to tarcia między
We wanted
śrubą
to identify the friction between the sphere and the nut that allowed us to create the simulator of our experiment and to predict what can we expect and what are the boundary conditions, what components should be applied.
Zaraz jak będzie jeszcze film z samego eksperymentu, będziemy mogli zobaczyć, że
And we will see a movie from the experiment to see whether it worked. So here with multi-body we simulated changing mass of the sphere.
Jeszcze, tak jak mówiłem, ważne było
What was important here was to apply good parameters. That's why we created many simulations for different sets of parameters. What was the second velocity of the spring in order to predict trajectories?
No i w końcu przechodzimy do systemu wizyjnego, gdzie
And then vision system, so by means of some adequate scripts, we were, and thanks to video analysis and thanks to markers placed on spheres, we were able to locate and orientate the sphere. And now the movie itself presenting our experiment.
Który trwał tylko 9 sekund.
So only 9 seconds.
Jak widzimy, zakończenie jest dosyć...
As you can see, the sphere crushed spectacularly at the end.
Tak jak mówiłem, udało nam się zrekonstruować, czy to...
As I've mentioned, we managed to reconstruct the trajectories of the spheres and their orientation.
Tutaj jeszcze jest, myślę, że dobre wyjaśnienie, jak to wszystko wyglądało. W sensie,
you can see, and we explain on this chart how everything looked like thanks to diagrams from different sensors that we have installed, but unfortunately we have run out of time, so let me move over. The whole campaign, releasing campaign, lasted about 2 weeks. It was very fruitful, but very tough in terms of the work value. This is one of the quotes from our managers. So fingers crossed is not a solution. We had to check everything, test everything prior to the experiment. Thank you for your attention.
Kacper, synowie.
Dobra. Dobra, bierzesz habitata.
Next up in the inspiration section, ESA Lab at CH Igluna Space Habitat with remote operations. Here to talk to you about it, Tatiana Benavides, Igluna.
Hi, and welcome to the presentation of Igluna ESA Lab at CH. I'm Tatiana Benavides. Thank you, Lucas, for the introduction. I'm the project manager of Igluna and I work at Space Innovation. So I'd like to start with a few words about space innovation. We are a center in Switzerland, and our mission is to strengthen Switzerland's space capabilities and involve players in space innovation, not only in Switzerland, but also internationally. We want to enable space technologies and contribute to sustainable development, so not only for space, but also for Earth. And we have a solid national and international recognition and network with access to cutting edge technologies. We have members all around Switzerland and we help them with their goals, and we also establish projects with partners. So this is our network of members here in Switzerland. You can see the little dots all around, and we have two white dots, which are EPFL, that's the Swiss Federal Institute of Technology in Lausanne, and then the other one is in Zurich. And that's where our offices are. But of course, we are nationally with all our members available, connecting them also internationally. So people doing something related to space, becoming from industry, from academia, or research organizations, they're part of our members. And one of the projects we do, we have many activities at Space Innovation, but what I'm going to talk about today, it's about Igluna. It's part of the ESA Lab initiative, so with the European Space Agency, and it has been powered by the Swiss Space Office here in Switzerland. And the focus on the target is to engage students to showcase innovative technologies. We focus on the topic of sustaining life in an extreme environment. This is, of course, for the future of space exploration, like we want to go to the moon and Mars, but it is also good for here for Earth. We use space as an inspiration, so it's something on space we have limited resources, so it's something we want also to have here on Earth, this type of mentality, so we can reuse, recycle, reduce what we consume. So that's how we also go into the sustainability aspect. And we also like to educate and train the next generation of space experts by inspiring them, by training them about systems engineering, about how space projects work, and connecting them, also expanding their network and their career opportunities. And it's a very interdisciplinary project. So we have students joining from engineering backgrounds, from scientific backgrounds as well, but also life support and design projects. It's bottom up, so it's whatever students want to create, as long as it fits this main topic of sustaining life in an extreme environment. It's welcome, and we also focus on technology transfer, so that's transferring the academic research to commercial applications. And so far, we had 3 Igluna editions. More than 500 students have joined, and they come from more than 20 universities across the world. So in the next slide, you will see what's Igluna in a nutshell. I went a bit too fast. There I go. And what it is, it's a platform for students to develop space technologies and increase their readiness level while learning about space project management. Why are we doing this? Well, we want to boost space exploration. Of course, we're passionate about space, and we believe we should be doing more for space. And how do we do it? We build collaborations between universities, industry, research organizations, and space agencies. So we have an expert board to support the student teams, and we follow them through an academic year. We have so far 3 Igluna editions, like you can see the patches here on the screen. And where do we do it? It's locally, the teams are working on their own university, supervised by their professor. But in Switzerland, we are coaching them, we're following them throughout the year, and then we organize different events, like you will see in the next few slides. We have kickoff, we have midterm, and we have a field campaign specialist. So that's to conclude a test bed, to conclude their projects, where they can come to Switzerland and do their tests, their experiments, show their functional prototypes, and also showcase what they have developed. So why Igluna? Why this topic? What does it mean? So Igluna is like a lunar igloo, and it goes in vision with the Moon Village concept that was developed by the former Director General at ESA. It takes a village to do a village at the moon. So very interdisciplinary, international collaboration, and that's why we thought of this topic like a space habitat, because we have, of course, the architects doing conception and structure, so that's how to construct the habitat, but we also have biologists, agronomists taking care of life support systems, so that's the food we need and the waste and the oxygen, also taking care of these circular loops. We have lots of engineering students doing power management, communication, and navigation. So they come from computer sciences. They come, for instance, now machine learning, artificial intelligence, but also more engineering like electronical engineering, mechanical engineering, aerospace engineering, for instance. And then we have the aspect of human well-being. So this is also something more psychological aspect to ensure that astronauts are not only living on space, but are also happy in there. So this is also designers taking part of this aspect. And of course, radiation monitoring if we go to space, habitability, and for instance, science, there's experiments going on about geology, astrobiology. So you can see it's a very complete topic. And that's why we chose this. So we include more student teams coming and doing whatever they're doing, and they can join if they fit under these topics. So this is how we run. It's an academic year from September to July, and we start in September with a kickoff event. Then in March, we have a midterm event. Usually we try to do them in Switzerland, like a workshop, 3 days, 4 days, something like that. Lately, because of COVID, they have been remotely in the last in the last year and a half, almost 2 years now. So that's how we're doing it. But the field campaign, it's something that we try to do also here in Switzerland. You'll see from the 3 editions, the first one was here present, the second was virtual, and the third one, we had a hybrid, so a little bit of both. And then we have these milestones called preliminary design review, critical design review, and readiness review. These are reviews used for systems engineering best practices, so how space projects are run, and this is how we evaluate the student projects, and we also help them to improve them so they can reach successfully their goal in the field campaign. And with this, we invite an expert board. So depending on the expertise of the student team and the expert, we put them together so they can give them feedback and inputs and help them improve their projects. So with the first edition we had was Igluna 2018-2019. We started in September 2018, finishing July 2019, and the topic was a habitat in ice. So our idea here was to do the habitat like it would be in the moon inside of the craters, that there is an evidence that potentially there could be enough water there of ice to make a habitat inside of the craters to be protected from the meteorites, also the radiation, and have a more constant temperature. So this first edition of Igluna was a demonstrator project to see how this ESA Lab initiative could work, establishing this platform of universities, linking them to industry and research organizations. And we collected lots of lessons learned. So the idea is to be improving every year and learning a lot from this, and also sharing our expertise with everyone else, and to engage students. Actually, not only are Europe, we also have students joining from USA, from Canada. So it's really now an international effort. As it was a habitat in ice, we are lucky here in Switzerland. We still have glaciers, at least some of them, that have ice in summer. So we went in Zermatt to the Matterhorn Glacier Paradise inside a glacier cave. And that's the highest cable car in Europe at almost 4,000 meters. So it's a bit of extreme conditions there for students to work because you have less oxygen. You have to really pace yourself. You get tired. It's also cold. It's -4 degrees. So the technologies they develop, they have to be fitting these requirements, as well as the humidity. It's high humidity in there. So they have to be working under these conditions, testing their technologies. And we also had downtown at the Backstage Hotel Vernissage an art gallery. So we had their exhibition there where students decorated it and showed their concepts also about living on the moon. And this was in downtown Zermatt, also to increase the outreach with the general public. And here's some pictures how it looked like. So you can see here we have our guest. We had MIT coming from the USA and doing the drill you see on the right, and on the left you see CERN doing an experiment about radiation. So our theory was that this big layer of ice, so we were -15 meters covered inside the cave 15 meters of ice was protecting the cave that you will see in the next picture. And we thought, okay, this should be enough to protect from radiations. And they were checking that for us. And they did see that the layer of ice protected from radiation. This is how it looked inside. So under 15 meters of ice, the students created this habitat. They built it themselves. And the condition for them was to keep the plants warm because it was very cold there. So the plants inside had to be at 25 degrees so they would grow. You can see here it was the architect students doing the structure. Then we had an interdisciplinary team doing this robotic greenhouse. We had experiments also inside, but also on the side of the habitat there. And we also had downtown. This is more or less how the exhibition looked like in the art gallery. Concepts about human well-being, about how the habitat would look on the moon. So it was really nice to see. And we had, of course, very important guests visiting us. This is the former Director General Jan Werner from ESA, the European Space Agency. We had Swiss Space Office representatives from the Swiss government. We had general public, of course. We had journalists coming, school tours, so younger generation being inspired by these projects. We had as well industry tours, so connecting the students with the industry. And we were very happy that we had astronauts joining as well. This was 2019, so it was the 50th anniversary of the moon landing of Apollo, the first moon landing there with Neil Armstrong, Buzz Aldrin. So there was lots of event going on, and there was one event called Starmus in Zurich happening at the same time, and they let us, the astronauts, to visit us and discover the student project. So this was really a nice experience, welcoming the astronauts there, including our Swiss astronaut, Claude Nicollier. And these were our partners and sponsors. We're very thankful to them for making this possible. The universities that participated, you can see here, they were coming from different countries, and as well all our local partners here in Switzerland. So we got very positive feedback to move forward, and then we did a second edition of Igluna. This time we put the level of the challenge up. So it was not anymore focused on an ice habitat, but we focus now on remote operations, because we figured that would be the first moon missions. They would be sending robots as they're doing now, but they're controlled from here, from Earth, from control centers here. So we wanted to teach students that how to develop a technology that you are not there to control, but you control it from another place and you monitor it from far away. So this was based in the ESA Lab initiative, building up on our lessons learned from the previous Igluna, and still developing these bottom-up ideas into technologies. And the concept we had the second time was to go to Lucerne. We have the Mount Pilatus there, and we have the Verkehrshaus, which is the Swiss Museum of Transportation. That's the most visited museum in Switzerland. It's really nice. If you get a chance to be around in Lucerne, and please go visit it. It has different exhibitions about space, of course, but also trains, boats, and different sorts of transportation. So the idea of this field campaign was to place the student projects on top of Mount Pilatus, so that would be the test bed, but then operate them from the museum. So across, you can see the two dots in the picture there on the top, the two red dots across the lake on the other side of Lucerne. There would have been the control room and an exhibition, of course, for the general public. You know, Igluna the year 2020, there was COVID. Of course, last summer, we were not allowed to do many events. So we updated it and did a virtual campaign. It's all available in our YouTube channel. It was running from these almost 2 weeks in July. And the student projects did shows. We had space expert presentations, something similar as you're watching now with this ERC, also hybrid campaign. And the students also had bilateral talks with experts. In total, we had 25 live events. And of course, you can look them up. They're still available. If you look for space innovation in YouTube, you find our channel and you can rewatch them all if you're interested. This is just to give you a peek how it looked like. So this was the habitat construction team and how they developed their concept. So they show that. This was a team Celestial, also from Germany, and they went to their partner PTS to test their communication that they developed with their antenna. And these were some of our special guests. Alexander Gerst is astronaut. We had the former Director General Jan Werner. We had industry, Astrocast, also iSpace, giving presentations and interacting there with students and also the public. We're very thankful for everyone who joined and also everyone who participated from the universities you see here who was involved, and also, of course, our partners that made this possible. So now for the last edition we had of Igluna, concluding now this last July. Also, we kept the topic of space habitat with remote operations. We really aim now to really be in Lucerne as it was originally planned, but to put the level of the challenge up, now we figured we should include potential commercial applications for Earth and for space. So this year we taught students about business models and how they could commercialize their research and their technologies. And this is how I explained, and now with a different map, because we had the top of Mount Pilatus there on the top, but also at Kinserek, a lower station, there was a test bed. And then at the Verkehrshaus, the Swiss Museum of Transport, it was where we had our exhibition and control room. So we were very happy this year. We had a hybrid campaign. Some student teams came to Lucerne, but still we had some restrictions, so some of them stayed home. And then we had everything in our YouTube channel. So you can see here, this is in the museum. There was the exhibition. In the bottom, you can see part of the control room with a computer there, some tables we had and monitors. And of course, we broadcasted all our ceremonies for the general public, but also for the students that could not be on site. We had project shows, and we had also the live demonstrations there on top of Mount Pilatus. This is on the top, where we had the tent with some student projects, like you can see here, the robotic greenhouse and the rover also sintering sand, as it would be on the moon with the moon regolith. We had also important guests. Here you see in the center, if you can find him, is Thomas Reiter, is an astronaut as well. And we had other ESA representatives joining, also from the Swiss government, and also general public, industry tours, media tours, and everyone who was there. We were very happy to welcome them. And well, if you want to learn more about the student teams, here you can see their universities. And we will have in 2 weeks, on Thursday, September 23rd, we will have a webinar from 3 to 4 p.m. Central European time. And you can join. It's open to everyone. The students will be pitching their projects, and then we will have a Q&A session at the end. So you can interact with them, ask them questions, and find out more about their projects. So you can join us. You can see also in our website, we have more information. We'll post there also the link to connect soon. And we will be putting now in the YouTube chat this information for you to have it there. And please join us. Don't forget, Thursday, September 23rd from 3 to 4 p.m. Central European time. And taking the opportunity, I would like to thank once again our partners and sponsors. And now leave you with what's going to happen next. So with Igluna, we of course try to push the student technology so that they can land on the moon and maybe further away in Mars. And that's what we want to keep doing. But at the moment, we are lacking funding for future Igluna editions. So we are open to explore together. If you have any ideas, any inputs on how we can work together, please contact us. Here is our email address, our website. And yes, we will be happy if you would contact us. And thank you very much. This is now the end of the presentation. And if you have questions, I don't know, maybe you can use, if you're watching the presentation online, you can use the YouTube chat. And if you are there on site, I'm very happy to answer them also for you. Okay, I've been informed there's no time for questions. So in case you have a question, you can write to us by email. You have it there, igluna@space-innovation.ch. And there you can ask your questions and we'll be happy to answer them. Thank you very much and see you next time.
Ladies and gentlemen, next up we have a topic that many of you probably find really fascinating for the exact reason that perhaps it's a little more challenging to find out about it and to learn more about it. And the topic of our next keynote is Chinese space program. Here to talk to you about it, Rafał Grabiński from Urania. Hello, Rafał. The floor is yours.
Okay. Dzień dobry. Tematem dzisiejszej prezentacji na początku się może przedstawię.
Today's presentation, maybe let me present. Firstly, my name is Rafał Gdabiański. I'm the editor of Urania portal. Every day we write about the space exploration from the astronomical point of view and astronautic point of view. So sending, launching probes and other pieces of equipment. And today we will focus on the Chinese space program. Because we might say that since the last decade, the Chinese became a real power in space. So we have only 2 orbital manned stations. This is the International Space Station, bringing together Japan, Europe, Canada, and the US, and the Chinese space station, and its first module that was launched only this year. So that will be the topic of my presentations. Firstly, I will outline the history of the Chinese space program, beginning of in cooperation with the former Soviet Union. Then we will move over with rocket and launch system techniques. Then we'll talk about manned missions and moon mission and the recent first Chinese mission. So what is the background of the Chinese space program? They are related to the Soviet Russia. So the Chinese became aware that on their own they do not have enough good infrastructure in order to develop this branch of industry. So before they dispute with Russia, they were in close cooperation. So they planned to do more or less the same as the Soviet Union did in the 50s. So these plans had to be revised due to the fact that the Soviet Union turned their back on China, and that is what happened. So when it comes to the structure, if we take a close look on how the space programs are developed in China, they are very similar to the Soviet and Russian manner of doing it. So they are related to the communist times, and there are some characteristic features of them. So one of these features is the project bureaus, which are competing with ourselves. There are a few such project bureaus in China, so this competition is about to boost development. And second thing, this is the mysterious aspect of this sector. In the US, we have great public relations, great marketing activities. We can read about almost everything that is going there in the space industry, but in order to get to any information in China, that requires a lot of effort, even if you are based in China. The second thing, the projects are not named as in the US or in the Western world, where each rover has its name, and there is a special contest to name a new rover. In China, they are just starting with that. Before, projects had their numbers, so we had 911, 561. The projects had its numerical names for many years, and it was very difficult to orientate what is the objective of a given project. So the father of the rocket system was Qian Suishen. It was a guy who was brought in Shanghai in China. But before the Second World War, as many talented Chinese scientists, he got a scholarship in the US. He became a student of MIT, so Massachusetts Institute of Technology. When he got inspired by the topic of rockets, then he continued at Caltech, California Institute of Technology, and that was the man who was a member of academia, but he was an active participant of the business. He got recommendations Americans from the Air Force, the U.S. Air Force, as he was focused on development of a new fuel, there was the proposition for him to start his career in the American Air Forces, but with time the Americans started to look for communists in their governmental structures and in official functions, and for that reason Chen Shen was allegedly a spy, so he had a home arrest for many years, and only in 1956 he was released from this arrest, but he stopped working on the American space program. He was deported to China instead. Before his deportation, during the Second World War, he visited Berlin. He met von Braun, who became the father of American rockets and father of Saturn V. So at the same time, on the other side of the Berlin Wall, there was another great scientist working for the Soviet Union. So we had three great guys working on rockets at the time. In the 60s, when he went back to China, he arrived in very poor infrastructural conditions, so he didn't have the access to the same infrastructure as in the US. There was no aircraft plant even based in China at the time. So Mao Zedong, of course, wanted to have his space program. He visited the Soviet Union in 1958 or 59, and he could see how this rocket and launch system looks like in Russia. He had an opportunity to watch Sputnik launch, but China couldn't afford such an infrastructure and program, and at some point China made a great leap forward. China started to make up for the gap in development and started to chase Europe and the US. But this great leap was not managed well. It resulted in the drop in agricultural production by 50% and economic crisis, so plans related to satellites had to be postponed. Only in the 60s we had Project 651, the project to construct the first long-range rocket. So a serious plans of thinking about space exploration started. Of course, it was based on ballistic missile, as in the US, this space programs had this military background. They could carry about 30 kilometers of payload, so not much at the time. After the first, we don't know much about the first launch because it remained secret by 2001. Only the second mission was successful. In fact, the Dongfang 1 was launched. It was a satellite whose objective was to play the revolutionary chant from its radio. It's the name of the song, Dongfang Hong in Chinese. The first real satellite became active a bit later. And so it was called Shijian-1, which was launched a year after. So this is this Long March 1 rocket. Two first stages are fueled with hyperbolic fuel, the simplest possible technically. The second stage has some stable fuel, and it was developed in China. Then there were the 60s, the second half of the 60s, And next, political crisis in China that postponed the space program development. Then Ling Yao government took over, and they started to think seriously about space exploration from the practical perspective. So Feng Bao said that Deng Xiaoping said that they want to use the space program for the public, for the society. It was the time of the Project 701 satellite JSSW, a military satellite for intelligence purposes, and then other satellite projects, Fan Huishi facing, so special 2-ton capsules that were supposed to, it was an observation satellite that was supposed to take pictures of military areas and objects, record them on a special film and carry it back to the Earth. Now it's possible to send it digital. Now both Russia and the US did the same, so that was a high quality spying method that allowed to develop manned missions then, because the Chinese had to develop many other technologies. They had to build a ground control system. They needed some orientation devices, because if we have a satellite we need to, and that is supposed to take any pictures, we have to position it just above this object. There in the entry atmosphere, the temperature is about 1000 degrees centigrade, so that allowed the Chinese to develop. They sent about 20 such satellites, the first one in 2005, so that was a long project. It lost its military aspect. In the meantime, they sent some animals, some microgravity experiments as well. But in order to send this capsule, they had to develop a new rocket, and this is how March 2 was developed, also two-stage with better lifting power. It could carry 2.5 tons on the lower Earth orbit. It had several iterations in the history of space program, and until now it is used in China. At the end of the 70s, telecommunication satellites were going back to politics. The visit of the US president in China, that for the first time in 1972, Richard Nixon visited China, and China became popular and visible on the global scale. It was sanctioned as a Republic of China. So the US visitors came with some transmission broadcast vehicles, and the Chinese got fascinated with their satellites, and in the project Bureau they came up with the idea to make a leap forward. They skipped the telecommunication antennas and went straight forward to telecommunication satellites. The project was signed by Mao Zedong himself, and that was a great decision taken in 1976. Mao Zedong died in the end. So thanks to that, telecommunication satellites had to be sent to geostationary orbits, so that required a rocket with higher lifting power and liquid hydrogen fuel. This is a very difficult substance to be processed in such an engine, so it was another technological leap forward. And the engine was developed by a lady. It was very rare, especially at the time when the space programs were related closely to the military project. So that was really something outstanding, that woman used to be the main constructor within that project. Here you have a different type of rocket, Long March 3B and C, 3A, 3B and 3C, lifting power depending whether it is stationary orbit or lower Earth orbit. So this lifting capacity was similar to American program. So it was supposed to be promoted as commercial rocket. They were present at the Paris Air Show, and they wanted to make their rockets 15% less costly. The US didn't like that, and they imposed an embargo on the Chinese satellites, and they questioned it as a weapon, and they limited the possibility to send Chinese satellites to space. Why? Of course, they could send satellites from other countries, but in practice, the satellite has always some American components. So in fact, they would have to build such satellites that had no American components. Europe started to do it at some point, but for some time. Then the Chinese applied these rocket technologies to a little bit more complex projects. Then we had Long March 4C that was adapted to sending payload to polar orbits, which were used together for the purpose of weather satellites. Then we had a manned program, the first recruitment of astronauts in 1970, but the first real manned mission started in the 90s. In 1996, they started to recruit for the second astronauts corps. They came up with Shenzhou aircraft, which was similar to Soyuz. They used Russian technology, but they adapted it to their needs. They were a bit concerned with this predominant thinking that it's a copy of Soyuz. They didn't like that view, and they presented it as a product made in China totally. So they stressed that it is totally made in their country. So we are running out of time. So if you have any questions about Shenzhou mission and shuttle, I will present you all details and differences. Then we had first manned missions in 2003. Yang Liwei was launched to lower Earth orbit. The manned missions are continued until now. To test orbital station Tiangong 1 and 2 were developed. Now the Chinese space station is being developed, is multi-modular, and the Chinese start from the 21st century. They go to the moon, they send their landers there. As the first ones, they landed on the other side of the moon. They have taken some samples from the moon, a lot of interesting things. And first and foremost, this year, on its first attempt, the Chinese mission landed on the surface of Mars. Thank you very much. That's all.
Ladies and gentlemen, I promised you it was going to be interesting, and interesting it no doubt was. I hope you enjoyed it. Once again, Rafał Grabiański, Urania. Thank you. And I suppose we can proceed to the next item on our agenda. Next up, we have Chris Welsh, International. Ladies and gentlemen, next up we have Chris Welsh joining us, International Space University, and the topic is International Space University lunar-themed team projects. Over to you, Chris. Enjoy.
Thank you very much. Is it working? Yeah. Not really. Okay. Now is it working? Excellent. Right, that's good. Get the technology working then.
Okay, my name is Chris Welch. I'm a professor at the International Space University, and I can see a number of ISU alumni in the audience, which is always nice at space events. I'm going to tell you, first of all, a little bit about the International Space University so you understand the sort of projects that we've been doing, and then I will tell you about the projects that we've carried out to do with the moon, since today is Moon Day, over the last 30 years. And I think that's the way forward. Okay, so the International Space University was founded in 1987 by these three handsome and at that time young men. They had an idea for an institution which would bring people together from around the world, from different cultures, from different societies, to work on future international space projects. And so ISU believes in a peaceful, prosperous and boundless future for humanity through the exploration and development of space, basically. So that's what ISU has been striving to do for 30 years or so now. These are our chancellors so far. The first one was Arthur C. Clarke, who I hope some of you will know is a famous science fiction writer and futurist. The second one was the then Director General of the European Space Agency. And then we had an even more, Jean-Jacques Dordain, I should say his name is. Then we had an even more famous person who's actually been to the moon, so relevant to today, Buzz Aldrin. And most recently we had Pascale Ehrenfreund. She's no longer Chancellor because just over a week ago she became President of the International Space University. So shortly we will be appointing a new Chancellor. So when we say, the special source, if you like, of ISU, we talk about the three I's. We talk about being interdisciplinary, international and intercultural. So some people say, well, is ISU a science school? Is it an engineering school, a business school? And the answer is no, it's a space school. It's everything to do with space. When we say we're interdisciplinary, you can see, on the right-hand side there, how we categorize the disciplines. So you can see there are ones that you might expect, like engineering and science. There's also human performance in space, which is everything to do with the psychological, physiological, and other aspects of sending human beings into space. Space applications, I mean, that's telecommunications, navigation, remote sensing and so on. And then the other necessary parts, management and business, policy, economics and law, and lastly, but not least, the space humanities. So if you're on an ISU program, you might get a lecture on orbit mechanics, followed by one on space ethics, followed by one on space policy in developing countries. It's a very, very broad curriculum. This is where I work, the ISU main building in Strasbourg. We're not a big organization. We only actually employ about 25 to 30 people, 8 or 9 professors on site, of which I'm one. We run a series of different courses. This week that's just passed, the master's program started. I'm the program director of that. And then we have a series of summer schools and shorter courses down to a week, which we deliver all over the world. And we bring in people from our networks. So we can't do all the teaching ourselves. So we invite space experts from space agencies, space companies, universities to come and lecture on our programs. And part of our programs is what we call a 3 I's excuse me, team project. And this is a topic that we choose for, which is a complicated topic. It's not a straightforward topic, but it's not just a technical topic. It has to have aspects of many of these different disciplines. And so we get a group of students and we throw this problem at them, and they have to organize themselves and decide how they're going to manage this. And you imagine you've got a Chinese engineer, and you've got an American lawyer, and a Greek economist, and they're all in the same team. And they have to decide for themselves how are they going to organize, because that's why we make them do the team projects, so that they can experiment with working together in this sort of environment before they go out into the real world. But we have to give them a significant problem to deal with. And there are many different topics, but the ones I'm going to talk about today, oops, I'm going the wrong way, are the lunar ones. And since we were founded, we've done 17 lunar-themed team projects. And I have just under 12 minutes left, so clearly I'm not going to talk in any detail about any of them. I'm going to show them to you in quick succession, say a few words about them, and then at the end I'm going to show you the web link so that if you want to find out more about them, you can go and download them for yourselves. Okay, so this is the menu, if you like. Imagine I'm the waiter, and I'm saying, this is what we have on the menu today for you. So the first one was actually the very first year we ran a summer school, and this was the International Lunar Initiative Organization. And this was a very wide-ranging one, looking at how you could develop future habitations on the moon, because we're ISU obviously wanted to make it an international activity. Obviously, it's 30 years old or so now, so maybe a little bit out of date, but this was the first one. And then the next year, ISU was already thinking about space resources. So the next team project was one actually to map the resources on the moon. And as you can see, we were well ahead of the Americans in choosing the name Artemis, beat them by 26 years or whatever. So that was the name of this team project, and it came up with this satellite which would map the moon. And all the things that were needed to happen to make this a viable project. This one, Iliphos, this was a project about creating a radio telescope on the far side of the moon. One of the difficulties for radio astronomers who have their instruments on Earth is that there's a lot of radio noise around, especially since we all started using mobile phones. So if you go at the moment to the far side of the moon, there are no human activities there, so it's very quiet in radio terms. And so they looked at this project to design and build and operate a radio astronomy observatory on the far side of the moon. The next one was called Metzli. Metzli is, if I remember correctly, that's an Aztec name for a lunar god or goddess. And this was looking, this was in 2003, so looking forward to the end of space station life and saying, well, rather than just taking the space station apart and deorbiting the modules, what else could you do with it, particularly to support lunar exploration? And so this team of students came with the idea of reconfiguring it slightly and then using low thrust propulsion to put it into lunar orbit, so to reuse it as a lunar orbiting space station. Not in the same sort of orbit maybe as currently being suggested for Lunar Gateway, but that was their idea, back in 2003. The next one is called Lunaries. Particularly in Poland, I'm aware that there's an analog called Lunaries, and again, ISU had the name first, but for something different. This was for a team project that was looking towards exploration of Mars, but was trying to identify what could be done on the moon to prepare for going to Mars, which is actually what some of the things that Artemis is doing at the moment. And you can't obviously read that list, but this was their ranked list of things in order of importance. And the one that was right at the top was psychosocial issues. How do you keep people sane and healthy in rather isolated, distant environments? And the idea, and they rank these by different means. But on the moon, you can experiment with this, and if anything goes wrong, you can bring people back in a few days, whereas you clearly can't do that on Mars. So the idea was we get better at dealing with people in these sort of environments. So you can think of it, instead of Lunaries analog on the ground, this would be a Lunaries analog for Mars, but on the moon. So we're getting further and further away with our analogs. Fertile Moon was looking at how you could, it was especially looking to model, and it produced models which are shown diagrammatically there, for lunar production and technologies for oxygen, hydrogen and water production, to determine what sort of level you could extract to support what sort of activities on the moon. And they actually came up with a piece of software that you could plug numbers into, for different numbers of people, that would tell you that the different scope based on different initial conditions. This was connected somewhat to the next one, which is Lunar Gaia. Okay, so this was about the design of a lunar habitat using a closed environmental life support system. Broadly in space, there were two ways to keep people alive. You either take along all the water, all the oxygen, all the hydrogen, and everything else you need, or you have a system such as we have, on the whole Earth that constantly recycles these things. You put energy in, and they recycle. And that way you don't have to send so many resupply missions. So this was a design for a biologically based environmental control system lunar base. The next one, full moon, this comes back to the production of oxygen and hydrogen, and it was particularly interested in the sort of transportation infrastructure, depending on one of two cases. Either there was water at the south pole of the moon, which you could use, or you could extract these actually directly from lunar rock. More complicated, obviously. But then how do you transport them, particularly if it's all at the south pole of the moon? And what they discovered after they did their analysis, that were basically, particularly if you made it at the south pole of the moon, if you wanted to take it somewhere else on the moon a certain distance away, a longer distance, then you needed a sort of suborbital transporter that would sort of actually fly under rocket power. But for smaller distances, you needed something more like a kind of road train pulling a series of tanks behind it to distribute these fuels to closer places. So that was what that project was about. This one here, Phoenix, was an interesting one. This was a lunar data archive. It was assuming that there was a risk to humanity, that civilization on Earth might be damaged, might collapse, and so the idea was to have a backup of this on the moon, integrated with ways of communicating with the ground, so that if civilization did collapse at a certain point, people could start to recover the knowledge of the previous civilization, from this archive. So a sort of insurance policy, I guess. Alerts, this was to do with robotic support for humans, so very appropriate for ERC. So if you're sending humans to the moon, there are things that they can do, there are things that robots are maybe better at doing, or it's safer to have the robots. And so they did a comprehensive analysis, and you can see the decision tree there, about which tasks to have done by humans and which tasks to have done by robots. And then they designed some example robots to carry out these tasks. Next one was Numenia. This was a follow-on from the Google Lunar X Prize, which some of you may know about. Google offered a prize to the first private company that could land on the moon and then drive 500 meters and take photographs and so on. No company actually ever won the Google Lunar X Prize, it has to be said, although it did stimulate a lot of private companies to start looking at the moon. And this was what this project was looking at. What could you do after something like the Google Lunar X Prize to increase engagement with the moon. 4 minutes left. So, okay, the next one then, Lunar Hathor. This was a lunar deep drilling mission, which was also intended to be funded partially commercially. So the question is, how do you, one of the technical questions is, how do you drill deep? We've had sort of fairly kind of narrow, shallow core samples so far. So they looked at a variety of drilling technologies, including this one on the bottom, which is a sort of plasma torch, which kind of burns its way down to get an idea of what the moon is like deep down. But then you have a long hole deep under the surface. It's protected from radiation. It's very thermally stable. You could again use this as a location for a data archive. There was even a British idea for this called Lunar Mission 1, which was planning to do this and fund the cost of the science by sending memories or samples of your hair so that you could have your DNA buried in a hole, on the moon, if you would care to do that. I don't know. I was never quite sure about that. And then more recently, lunar night survival. Obviously, there's a 2-week day and a 2-week night on the moon. And the question is, what do you do about staying alive during that 2-week night. And this team designed this modular system. So that body there, it has solar arrays, it has a nuclear reactor, it has lithium-ion batteries, and it also has reactant fuel tanks, so that it effectively covers all the bases that you might need. And then you could, increase these, modularly depending on how many you needed. Then a couple of years ago, Sustainable Moon. This was looking at how we can go back to the moon and create lunar infrastructure and habitations in a sustainable sort of way, so that maybe we don't repeat the sort of mistakes that we have, in some cases, executed on the Earth. And amongst other things, this team project came up with a set of sustainable lunar development goals, which you can see listed there. Then there was lunar agriculture. This was another one looking at how to grow plants on the moon to best support future human settlers there. Lunar base design. This one was actually done just this summer. It's quite an interesting idea. It's a way of constructing a lunar base quickly. What you see there is one of Elon Musk's starships. You land it on the moon and then carefully tip it over on its side, cover it up with lunar regolith, and then change the inside of it. And they figure this way, in 6 months, you can have a lunar base that way. And then also another one that was done this summer, this one called Moonport. I find that a little bit confusing in terms of a title, to be honest, because it's about a sort of tug or cycling spacecraft which travels between the Earth and the Moon continuously, and allows you to hop on and hop off and deliver things to the Moon. But it's another piece of technology to enable future lunar missions. So that was a very rapid trip through 17 team projects. I realise it would have been a little difficult to take it in, but if you want to, you can go to the ISU library website, which you can see there, isulibrary.isunet.edu, and you can see I've circled in the bottom left-hand corner a link where it has the team projects and all of our team projects, not just the moon ones, all the ones we've ever done over the last 30 years or so, and we've done anywhere between 1 and 6 a year. It's been going up as time goes on, is there. So thank you very much for your attention.
Ladies and gentlemen, that was Professor Chris Welsh with a fascinating array of projects and initiatives at International Space University. And now we proceed to the next item on our agenda, Jordan Space Research Initiative, Sustainable Development and the Moon Village. Here to talk about it, Sahba El-Shawa.
Good afternoon, everyone. Thank you so much to the organizers for this amazing event. I'm very happy to be here. My name is Sahba. I'm the founder of the Jordan Space Research Initiative, and today I'll be telling you a bit more about JISTI, our goals for sustainable development, and the Moon Village and how it came to be. So our mission at JISTI is to foster space R&D in Jordan while also contributing to lunar exploration and working towards sustainable development in the country, focusing on our national priorities. So for countries like Jordan that don't have a space program and have limited resources, it's essential to show that space also has its benefits. So we also aim to educate and engage the general public in order to show this viability and the benefits that space technology and research can help bring to life on Earth. So for a bit of background, Jordan is a country with a very high youth population and growing interest in space. However, as I mentioned, it's lacking in opportunities and it has limited natural and financial resources. So unfortunately, what this means is that for people who are interested in space in Jordan, typically they have to go somewhere else if they want to pursue that. And then on the other hand, when space projects are pursued, they're seen as unnecessary or as a waste of resources. So that's the issue really that we're trying to tackle. And the way JISTI came to be is through two initiatives, really. So a roadmap for Jordan's participation in lunar exploration was created last year under the Moon Village Association's Participation of Emerging Space Countries program, or PESC. And the building blocks that we chose in this roadmap not only contribute to the Moon Village goals, but they were also chosen based on a preliminary roadmap that I created while I was doing my master's at the International Space University, focusing on Jordan's implementation of the UN Space 2030 Agenda and the SDGs, or the Sustainable Development Goals, which I will talk about in a bit. So the main goals of JISTI are twofold. The first is establishing an analog facility for technological research, and the second is community and stakeholder engagement. So as I mentioned, sustainable development is one of the core driving factors behind the goals that we chose. This was driven by the UN Space 2030 Agenda. And I would like to mention that even though we chose these 9 SDGs to focus on, I do truly believe all of the goals are interconnected. So by trying to tackle one of the goals, you have to address all of the goals kind of simultaneously. But what this gives us is a view of the national priorities. So for example, tackling gender equality, water scarcity, these are things that are also very high in importance to Jordan as a country. So that's why we chose these 9 SDGs: quality education, gender equality, clean water and sanitation, affordable and clean energy, decent work and economic growth, industry, innovation and infrastructure, reduced inequalities, sustainable cities and communities, and climate action. And so I won't go into why each of these individually was chosen, but you'll see when I talk about the research areas, they either build on addressing issues that Jordan has as a country, or building on the strength that it has and the technologies that are already at the focus of the country's initiatives. So these are the research areas that were chosen. They not only contribute to Jordan's priorities, but also are building blocks that we will need to establish the Moon Village. So this is where the two ideas intersect of contributing to space exploration while simultaneously focusing on aspects that will help life on Earth. And so I will explain each of these separately now, so I won't read them off this slide. But the first one, which is water resource management, of course, this will be essential for the Moon Village, but it's also a priority here on Earth, where our resources are precious and limited, and especially now with climate change, where it's becoming increasingly unpredictable. And in Jordan in particular as well, one of the main national challenges is water scarcity. There's a huge strain on the resources. And so we would like to incorporate space technology and research into existing initiatives in Jordan, focusing on recycling and resource management so that we can bridge these two ideas. The second is renewable energy. So due to a very large population growth in recent years and the refugee crisis, Jordan is a country that hosts a lot of refugees in the region. And so the national resources are quite strained. And so renewable energy is one of the main priorities at the heart of its strategies, with many ongoing initiatives, as well as a lot of commercial entities that are focusing on renewable energy. So in that sense, we wanted to focus on both the weaknesses and the strengths by developing more efficient and sustainable technologies, which we will also require for the Moon Village. That brings me to ISRU and robotics, so in situ resource utilization, or using the resources that are available to us. The Jordanian desert, and particularly Wadi Rum, is often compared to Mars. I'm sure you've seen The Martian, which was actually filmed there. So it's very similar in terms of the topography and the terrain. But beyond just the aesthetics, this also provides us a unique opportunity for analog testing. For simulating as closely as possible what the environment would be. And so we're planning to implement these space analog missions relating to ISRU and robotics to test the technologies that we will need to even begin building what is going to become the Moon Village. And similarly, for dust mitigation, this will be one of the biggest issues to tackle, particularly in lunar exploration. And as I mentioned, the Jordanian desert provides us with this unique platform to test our strategies and technologies, and also to learn from how indigenous people survive in similar conditions. So the Bedouin tribes in Wadi Rum still live there, and we can really gain from trying to learn from their ways. And this doesn't just apply to this particular research area, but also to how we are approaching the creation of the Moon Village in general. So this is because, again, it provides a more accurate representation of what it would be like with relation to the environment. So smart city infrastructure, this is actually building on one of Jordan's strengths. So it's introducing and has been introducing smart solution systems to its municipalities in order to enhance and sustain their services. There's ongoing initiatives in communication and IoT, or Internet of Things. So we want to build upon these solutions that are already ongoing to create a lunar smart base strategy. So this will allow us to improve connectivity and also standardization for the future Moon Village. In terms of agriculture, of course, food and agriculture is an important part of any community, but also a sustainable community here on Earth or in space, and particularly when our resources are limited and when the environment is not what is typically optimal for agriculture. And so we're building on existing initiatives that Jordan has. For example, it has a partnership with Norway aiming to grow food in the desert. And so this is already a harsh environment, and we can gain from looking at similar technologies and developing them for future lunar bases. And finally, that brings me to women's health, which I believe is arguably one of the most important research areas that we've selected. This is because Jordan, one of the main priorities in Jordan is actually improving accessibility to healthcare in women. Women they play an extremely important role, but they're often disadvantaged, and not only in the Jordanian society in particular, but around the world and in the space industry as well, where the research into women's health in space is severely lacking. I think only something like 11 or 12% of all astronauts have been women. We don't have the data. Of course, there's some initiatives starting now, but our goal really is to focus on this area to not only improve it for future Moon Village, but also for women who live in remote areas and harsh environments and refugee camps, to be able to provide them with better access to medical and pharmaceutical solutions. So with that, all of these research areas are going to feed into the type of technological research that goes into the analog facility. This is a long-term endeavor, of course. We would like to establish it in Wadi Rum, which is locally known as the Valley of the Moon. And we would like to incorporate all of the building blocks that I mentioned. So then how are we going to do that? So the Moon Village Association has these three scenarios, if you're not familiar with them, of how the Moon Village can potentially come to be implemented. And we're actually pursuing all three. So the first scenario, scenario alpha, is government and human spaceflight driven. So for us, this is the actual establishment of the analog facility, the plan for it. Of course, it needs to be government driven due to restrictions relating to the land. It's a protected area. But then also to foster collaborations between governments, national and international, so that we can have this integrated platform where we can test human spaceflight mission concepts in a way that is more similar to the environment that we would be in. The second scenario, beta, is government or science-driven. So not only working with the government organizations, but also technical universities, research institutes, identifying specific scientific research goals, as well as programs relating to the construction, as I mentioned, using ISRU, for example, as well as the development of the facility itself with the selected building blocks. And developing the technologies based on existing initiatives such as the Sahara Forest Project, which is the partnership with Norway that I mentioned earlier. And then finally, we have scenario gamma, which is private venture driven. So identifying the relevant goals for partnerships with commercial entities, again, both national and international. This is especially important in terms of procuring funding from commercial partners and investors. As I mentioned, we have limited financial resources, so we don't expect that the Jordanian government is going to fund this. So we need to find partners whose values and goals align with ours. And we would also like to use this as a platform to foster new space ventures, developing these technologies based on our existing capabilities. As I mentioned, the strengths in renewable energy and smart city infrastructure, robotics. These are things that we can build on and potentially also start to organize for missions and payloads relating to these building blocks to ensure that Jordan plays a role in lunar exploration. That brings me to community and stakeholder engagement. So this is extremely essential if we want this roadmap and just these goals to succeed. So again, as I mentioned, in a country with limited resources, we need to close this communication gap and show that space does actually, it could potentially have benefits. Of course, that's not to say that every space initiative is going to benefit life on Earth, but the way that we're choosing to approach this from the lens of the SDGs, from the national priorities, will allow us to show and educate people with regards to how space exploration can actually benefit them as well. And it's not just a far-fetched goal that has no applications here on Earth. And our target stakeholders here are not only government institutions, but also urban and traditional communities, the people who live in Wadi Rum, the students and universities and research institutes. So it's really encompassing all these different audiences, which will require, some education, some convincing that why should we care about space, in fact. And so two ongoing competitions that we have right now are a spacesuit and rover design competition, which are the first of their kind in Jordan. We've partnered with a few different organizations, both national and international. And our goal here in our, beginning stages is to start educating and provide these opportunities to young Jordanians who are very interested in these topics, but they just don't have any opportunities to explore them. And so for the rover competition, they're designing a rover with an ISRU payload for the moon or Mars, up to them. and then also designing an analog spacesuit addressing specific challenges that we learned through our discussions with astronauts. And so the teams are going to be presenting their prototypes for these competitions in October, right before the IAC. We're heading to Wadi Rum, and at the IAC, we will also be presenting some of our results, as well as more about GISTI and the implications on Jordanian society. So to wrap up, I truly believe that countries, even with limited resources, can play a role in lunar exploration, and in fact, they must, but they should do it while still putting their national priorities and sustainable development goals at the forefront of their efforts. So for us at GISTI, there are two main goals: the establishment of the analog facility, fostering technological research initiatives, and then the community and stakeholder engagement. So we welcome input from potential partners in any of the research areas that I mentioned, or anything else from international stakeholders, of course, is very welcome. So thank you for listening. You can check out our website, gisti.space. It is a work in progress, so if anything doesn't work, please let us know. And I will leave you with a video that our team prepared, just recapping our goals and research areas, as well as our partners. So thank you again for listening, and I hope you enjoy the rest of the event.
Ladies and gentlemen, that was Sahba, and the music theme we heard a while ago, interestingly enough, the title of it was probably Space Spine, if I'm not mistaken. You can check it. Next up, ladies and gentlemen, behind the scenes of the Thales Alenia Space Lunar Project, an interview with engineers Maria Antonietta Perino and Franco Fenoglio. Enjoy.
Maybe not many people from our audience know that the International Space Station holds a special place in the hearts of Thales Alenia Space engineers based in Turin, Italy. In fact, you supplied fully half of the pressurized volume on ISS, like nodes 2 and 3, logistics modules, cupola, and the Columbus lab structure, along with ATV resupply vessels. Could you please tell me more about your work for ISS?
Yes, definitely. ISS, I think, is the experience where we got highest knowledge of our activity in space business. Obviously, we already started before, but you were mentioning and remembering that we contributed to a very crucial pressurized volume of this space station. You mentioned already the several modules on which we were involved. And I would have to say that basically we span through different type of modules and infrastructure, and we cover more or less whatever is needed in the frame of such a big infrastructure, because we contributed to laboratory, to service module like the nodes that are born in order to provide the resources to the other attached vehicles. We provided the cupola, which is the observatory platform of the space station, and that it has become a sort of icon of the space station. It's probably the smallest modules among the ones that we have built and provided, but it's really one of the modules in which the crew, as soon as they have the time, they spend the hours to try to relax beyond doing the observation of EVA extravehicular activity, rather than operations when, for instance, the vehicles or the shuttle was coming to the space station. And now we are still active in the ISS because we are contributing to the pressurized cargo module of the Cygnus, and we have contract for already 18 flight units. More than half of those ones already flew successfully to the space station, so we will continue, and I think there are opportunities to further expand this collaboration that I think was one sort of industry-to-industry business. Of course, Cygnus is provided by Northrop Grumman for the space station, but we have a contract directly with this US American company. Definitely, this is one, I think, of the principal example of a collaboration at industrial level. We are still following also the operation of the Columbus, and we contribute when needed to the nodes. So I think really that the space station, it's our major adventure so far, but I would say it's also the point from which we are starting for the future and the exploration of beyond the low Earth orbit.
So, based on your past successful experience in building module for the ISS, Thales Alenia Space has signed a contract for the development of 2 key pressurized elements of Axiom space stations, the world's first commercial space station, scheduled for launch in 2024 and 25 respectively. Please tell us about your contribution to this project and idea behind developing this completely new space station.
Well, you are right. It's a new station, even if the first part of this station will still rely on the ISS, because Axiom is considered to be a commercial station, but will have a first period in which they will dock to one of the ports of the International Space Station to get the resources. So they will spend some time attached to the space station. And then in the second step, it is foreseen that the modules of Axiom will detach from the space station. There they will have additional module like a thermal and power module to ensure their autonomy. Since that point on, they will work as an actual commercial station in low Earth orbit. It is conceived for some major purposes. One is, let's say, to promote science and experiment also for commercial enterprises. The second one is to be used as a training station for the astronauts, and not necessarily only the institutional astronauts. And then the new frontier could be to be used also as, let's say, as a base for space tourism. So this is definitely one of the objectives of the station. I think we were contacted and engaged. We will provide the structure of is a two pressurized module together with the micrometeoroid and the pre-protection. We are discussing about windows. They will have docking ports, and I think that definitely this is thanks to what we did in the International Space Station, and of course what we are providing is a sort of a mix between the heritage that we can bring with us from the space station, at the same time trying to inject within the new design possible innovation in terms of materials or solution which can allow the module to be lighter in terms of structure. I think the other key point for us is that we are typically very flexible and very quick in producing the module. We have adopted in the meanwhile also different type, for instance, of welding techniques. Now we have, I think in Europe, we are the company that has the biggest friction steel welding plant, and so, as I said, it's really a sort of mix between what we can get and herited from the past experience, the great knowledge from ISS, and what at the same time we are bringing on in terms of continuous innovation, also thanks to some R&D from that we are bringing on internal.
Thank you. The next question is regarding the Lunar Space Station Gateway. This is one of the pillars of NASA's Artemis project, and it's a joint international program, and Thales Alenia Space is responsible for thermomechanical systems on the European Service Module for Orion, the pressurized module for habitation and logistics outpost HALO, one of the first two elements of the Lunar Gateway. In addition, you were also chosen by Italian Space Agency to conduct a feasibility study of 16 design concepts to support the human presence on the moon. And my question is, what is the most difficult part of designing and developing such systems to ensure that astronauts can safely fly and then stay in space station or land in the moon?
I can say that again, the first point is we can definitely for the modules take benefit of what we did in the ISS. HALO, the habitation and laboratory modules, the first one that will be part of the core of the gateway, and that we do for Northrop Grumman, is a sort of evolution for exploration of the Cygnus pressurized cargo module. And on that, it's clear, I mentioned before, that one of the key points is to be capable to make the structure lighter. Because with the new launcher, either the current SLS or the commercial launcher, like for instance the Falcon Heavy, one of the problems is that the mass target launcher, so in order to be able to outfit on ground as much as possible those modules, you need to try to recover mass from the first part which is built, which is the mechanical part. Then we will, let's say, exploit the fact that HALO is done before in order to go to build the international habitation, which is promoted by our Italian Space Agency. Is a contract that we acquire as a prime contractor for ESA. It is called international because it's a module which will be provided by ESA, but with contribution from the other agency participating to the gateway, like the Japanese or the Canadians and NASA themselves. And this is the module which will be smaller than the one of the space station. In the space station, we were talking of module around 4.4 meter diameter, whereas for the gateway, we will have both a halo and international. And then, as Thales Alenia Space, we will be prime contractor also for the S3, which is another module for propulsion and refueling on orbit. And will include also a pressurized tunnel with windows that could represent, I would say, a sort of cupola or new cupola for the gateway infrastructure as well.
Franco, you have big experience in space engineering. Which project is one of your favorites?
I cannot say differently that the Node 3 or Tranquility, as it is called, of the space station, basically for two reasons, I would have to say. The first one is that I was the chief engineer and the technical manager of this module. The program lasted something like 10 years. We worked in a fully international environment and was one of the most complicated modules of this space station. I was lucky to have the opportunity to bring it until the final ground campaign, launch ground campaign at Kennedy Space Center, and then to the launch itself. And it's a module on which really we had the opportunity to experience all the system, subsystem, and equipment aspect. There was a huge and large team, so it was definitely, I have to say, a great either work but also human experience. So that is still my favorite, even if the lunar now adventure offer definitely some possible opportunity which are very, very interesting. But I was also younger, so you know, it was easier to spend also night in working because it was amazing to do in any case.
Thank you very much. Now I have a question to Maria, because the last one was for Maria, right? Maria, it's also good to have you here on ERC. So my question is, what is the most important in your job as a space engineer? What's your advice for young people dreaming about joining space industry?
Well, before giving advices, I can really, how can I say, hope for you is a path that is similar to the one Franco and I had the opportunity to follow. It's beautiful to work in space. You need to be very motivated. You don't have to pay too much attention to the time you devote to a project, because as Franco mentioned before, you fall in love with space, and it's a privilege really to contribute within a large team to the realization of a little, how can I say, piece of humanity to be brought into a different context. So you ask me for advices to the young colleagues, because the people that are listening to us will become sooner or later our colleagues. Be motivated, be brave, never give up. Yes, you face a challenge. Good. Is a good reason to try to do your best to meet it. You need to, obviously, to study a lot. You need to be open-minded and don't believe that you can do everything by yourself. If you work in space, you need to be a person like an astronaut. You know, an astronaut is not a superhero, maybe in the cartoon or in a movie. In fact, the astronauts are wonderful human beings that need the help and the support of a huge number of other human beings with different skills, with different backgrounds. So if you want to work in space, guys, you need to be ready to share and to work together. That's my advice.
Thank you very much. Thank you for your precious time. I hope that we will see you soon in person on the next VRC. And once again, thank you that you find out. I know that there is a lot of things happening right now in Thales Alenia Space, and I really appreciate that you find time for us. Thank you once again.
Thank you.
It was a pleasure. Thank you.
2, 5, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.
Ladies and gentlemen, time to address one of the most imaginatively interesting topics of today. There's a lot of talk about creating propellant on the actual satellite or planet, depending on where we are, because that might actually solve the long-term issues and challenges. So here now, we'll talk about propellant production on the moon. In the studio, I'm joined by Rasmus Pedersen, representing DSAR, and if I understand correctly, online we are also joined by Gordon Wasilewski, representing Astronica, correct? The other way around. Yeah, so a funny component to start with. Yeah, can we see the full studio now? All right, so I'm going to join Gordon, and let's see if we can have this conversation.
Zaczynamy.
Right. I suppose we might want to start with the big discussion. Why the whole debate in the first place now? Why are we talking about propellant generation on the moon?
Well, first of all, pleasure to be here. Well, we're talking about that for many reasons, but the most important reason is that it's a fantastic opportunity for all of the humanity to increase our exploration capabilities. We are very much limited on Earth in space exploration when we depend on Earth. It's very hard to get out of the Earth. It costs a lot of fuel, a lot of money. Every kilogram of mass is just so precious, and 90% of each rocket is fuel. So for the last couple of years, we tried to solve that issue, and we tried to solve that with reusing the rocket component, so the dry component of the rocket, first with boosters reusability, and second right now with upper stage reusability with heavy systems by SpaceX. But that's not enough. It still leaves us 90% of non-reusable component. That is very crucial for leaving the Earth and for going out to the other nodes, other places within the solar system. So that's why the space missions have to be very compact, very lightweight, because we can't simply afford anything else. And even with the most powerful rocket engines, even with the most complex staging systems within our rockets, we still hit that limit. We can't go beyond that. We can't go faster. We can't lift more payload. So it's challenging. And the only thing that
can you think of anything that is not challenging about?
Oh, there's a lot of challenges here. But the only thing that shifts that, the only thing that increases that our efficiency in lifting objects to space and to other places within the solar system is refueling. And that changes the whole equation, that changes the whole situation. We can expand further on because that increases our payload capability, our delta V capability by orders of magnitude. So where do we source fuel in space? That is a very important question, and that was answered pretty recently, about 10 years ago, by confirming that we have on the moon significant amounts of water ice that we could use potentially to build extraction systems, capture systems, and processing infrastructure that could change it from water vapor, from liquid water to oxygen and hydrogen. And oxygen and hydrogen that are in the liquid form are actually the very primary rocket fuels that are used. They are used, I think, on ULA rockets, on Orion rockets. So we use that quite often, and they're pretty powerful. So we have that place where we can source fuel from, and we see that it just brings so much potential for refueling of large space missions, for servicing of satellites that are already on orbit that could increase their longevity. So we have clients for that, we have resource, and now we're developing a technology that we could hopefully successfully use within the next decade or so.
So you're at a stage where you're actually working on the technology itself, not yet the actual infrastructure part that needs to be set up on the moon, but the technical process, the chemical process.
Well, we actually we are trying to solve very basic questions about that. Even
I can just add to this actually. Talking about the whole chemical process of producing this rocket fuel in space. Like Gordon, you were bringing up hydrogen, which you would create from electrolysis with water. Something that's actually very interesting to consider in the context of propellant production in space is that many of these fundamental processes that we need, like for example the electrolysis, and in some cases also methanation reactions on Mars, for example, have been used in industry actually for quite a lot of years. So one of the key challenges in doing this is not so much figuring out from scratch how are we going to do this, because this is already pretty well established actually on Earth. The difficulty is how do we then bring all of this stuff to space? How do we actually get, say for hydrogen production and oxygen production, how do we actually get access to the water in space that we need to do this?
And how would you describe this, the current stage where we're at? Obviously, there are a number of bottlenecks to such a complex problem, but where are we? What kind of time frame are we talking about, looking at all the companies who are trying to address this issue?
Well, that's a pretty good question, because it's hard to say. Of course, depends on the development process going forward. But like I just mentioned, say you're producing liquid hydrogen, liquid oxygen, right? Fundamental rocket fuel, like Gordon mentioned. You would need to perform some kind of extraction, depending on where you are. Say on the moon, you might be digging out lunar regolith and then processing that somehow. You need to separate the ice from the moon sand itself. This we can do on Earth already. We can separate materials that we've dug out of the Earth. We've been doing this for hundreds of years. Then once you have the water on its own, which you need in order to produce the hydrogen and the oxygen, you would perform what's known as an electrolysis. You probably all did this in like middle school physics classes, where you have two test tubes and you apply a voltage potential in like small bucket of water. So this technology is actually also pretty well understood. Now that you have the hydrogen and the oxygen at hand, you need to perform some kind of liquefaction. Liquefaction of oxygen here on Earth, you produce oxygen here on Earth by cooling down the air, but in space, when you have the oxygen, you can just like only cool down the oxygen. So actually you simplify the process of making oxygen to some extent. And hydrogen is a bit of a different beast, because the liquid temperature of hydrogen is around 20 Kelvin. So 20 degrees above absolute zero. So getting to those temperatures is quite difficult. But all of these individual steps are already performed on Earth. The difficulty in doing this is like putting this together in space. So it's really not so much a question of like technology maturity. It's more like a question of when does someone see the funding needed in order to put this in space? Like there has to be some kind of incentive to actually put this in space. There's a lot of talk about producing fuel in space, But let's imagine that tomorrow I have 3 megatons of liquid hydrogen on the moon. Who's going to use it, right?
Rasmus, correct me if I'm wrong, but the way I see it, the biggest challenge seems to be that all of these individual processes here on Earth are not exactly nanotechnologies. In other words, you need production lines for that. You need major infrastructure, and you need very specific chemical conditions, atmosphere conditions, etc., etc. So essentially what we are talking about is establishing heavy infrastructure necessary on site before we can even start the conversation. Is that the case, or am I missing something?
That's absolutely the case. You need these massive production lines, like what you're saying.
Which, given the price per kilo in space, the transportation price, that itself answers the question why we're not yet there, right?
Right, and then you want to take a step back, like could we even produce the material needed for these things in space, right? Let's say you would just produce the plant itself on the moon from moon material instead of actually shipping the things on Earth. That would be like the next step to this. But no, you're completely right. The cost of bringing a kilogram to space just to low Earth orbit is extremely expensive. But like now going to the moon, you need to add on top of this another margin, because just like Gordon also was mentioning, when you're going to space, 90% of your spacecraft has to be pure fuel, but that's just to get to like approximately orbit around Earth. Then actually getting to the moon now, another good part of your spacecraft has to be just fuel. So by the time you get to the moon, it's only like a very, very, very small fraction of your spacecraft, which is actually your production line. And what you just mentioned, you need these massive production lines to fuel these spacecraft. So no, it's an extremely difficult question, but it's mostly like a logistics challenge much more than it's like a technological challenge.
So I'm not sure if you had a chance to watch our conversation with Robert Kobani yesterday, where we asked him about the prospect of people coming to Mars and what it will take, the sheer travel period alone, but the actual infrastructure to make sure people survive even for a short period of time on Mars requires bringing all that infrastructure. That brings me to the next question. Rasmus, allow me please to ask Gordon that question first, so we'll have a little more time to think about the answer. Lucky you. So the question is, if that looks like such a remote prospect, why should the respective businesses and institutions you represent be interested in the first place?
That is a great question. And I think we could use a couple of terrestrial examples why we develop very expensive...
Tomorrow is all about terrestrial, so come back.
Yeah, but why we develop, in the first place, very heavy, expensive terrestrial infrastructure. Why do we develop a nuclear power plant that costs tens of billions of dollars?
Oh, that's actually quite easy,
and
isn't it?
It pays off after 50 years. Why do we do that? Because it provides you resources to build a business on. That provides you a strategic resource to build infrastructure, to build your life, your economy. So basically...
Gordon, but you will agree that the cost to value ratio here is very different from even building a nuclear power plant.
Not actually. Well, if we look at the thermal mining infrastructure for the moon, so the very basic concept of how we can extract water from the permanently shadowed regions deposits, then we are talking about $2, $3, maybe $4 billion per the infrastructure. And even without...
Just pennies.
Actually, it is, because it actually, if you develop that infrastructure to pay it off by selling the rocket propellant to the customers that are very much interested in doing that, because we need to service a lot of satellites, we need to service a lot of space missions, we're actually looking at a break-even in the investment after just a couple of years, and the return on investment, actually quite a significant return on investment in just 10 years. So it actually, it's already promising a business case, even without that strategic benefits of inducing economy, of providing a resources for the economy to flourish. So we already have a business case for that. And what we don't have is a will to pay that.
All right, fair enough.
Quite a couple of billions of dollars.
You're talking about the business case and obviously significant amounts of money. So tell me, how would you describe how easy or how challenging is it now? Because I would presume the funding we're talking about is government grants, agency grants, big players. So are we really coming any closer to private investors really thinking about the prospect of, return on investment coming in 10 years, and the likability, the probability of it really still quite low.
Yeah, I'll come back to the same argument with the nuclear power plant or a tunnel or a bridge. So how we develop those infrastructures.
You're making it easier from nuclear power plant to tunnel to bridge.
Yeah, but they
hardly same investments, are they?
They cost billions of euro, dollars, whatever. And the model for constructing them is mostly public-private partnerships. So we have a government that funds those enterprises through private contractors, and that's actually the era in the space industry right now. We have government agencies that fund a bunch of different contractors, small and medium enterprises like Astronica or larger integrators to develop those systems. And we have a lot of examples in the space industry where the space industry actually develops those systems quite well and at a lower cost, quicker. SpaceX developed Falcon Heavy and Falcon system, and now the Super Heavy way faster than the SLS by NASA. So you're shifting the risk, and you're shifting basically you're shifting the risk on private contractors, so they take it on themselves, but they actually are quite well with spending their money and spending those resources. So we have a good business model for developing that. We need a political will to actually say that, well, there's an agency or there's a customer that says right now we're going to buy 500 tons or 100 tons of rocket propellant in 10 years. We're going to pay this and this amount of money for it. And if is there anyone out there that takes that challenge on themselves? Well, there's definitely a couple of people that will do that. I mean, the first space resources contract that we just recently seen, it was a contract granted by NASA to Lunar Outpost, who said that they're going to extract a regolith from the lunar ground by the rover for just $1 per that bulk regolith. So that was the first very symbolical contract. And we also, within the last couple of months, we've seen the first actual production of resource in space by Perseverance and Moxie, who first produced oxygen on another planet, on another solar system body. So we're getting there. We have a lot of significant knowledge gaps about the regolith, about those resources, about those deposits right now, and that's why NASA CLIPS and other programs are trying to address that with prospecting. But
Gordon, let me make it a little bit more tougher for you.
Yeah.
Of all the things you could be doing about space-related technologies, why would you be especially interested in the propellant technologies, given the complexities you have just explained? I mean, you have a lot of choice, and you're doing quite a lot of other things as well.
I mean, supply chains are complex. Supply chains are complex, but they are fueling our economy. The construction of a highway with gas stations may be complex, but we need that to get from point A to point B sustainably. So we need those critical infrastructure, orbital infrastructure, lunar outposts to explore space sustainably. So sustainability here is the key. And that actually also induces new economy, new space economy, and it's not a new concept actually. It was dwelled into in the Apollo times, and it just recently came back online. But yeah, we do that because we have this drive for space. I mean, we just want to be in space, and there's a lot of riches out there that we can explore and develop, that we can enrich ourselves with.
Gordon, what you've just said reminded me of an anecdote I overheard this morning accidentally at the Mars Yard, because you could see like almost 100 kids there asking their parents different questions about the rovers in the Mars Yard, but there was also an elderly person with a bike, and he looked at the Mars Yard, he looked at the rover, and he said something like that. And he said, so, they can already solve problems in space, but they haven't solved the ones on Earth yet. So that's also a perspective, isn't it?
It's a recurring argument about this space industry in itself, space exploration. So,
exactly.
Yeah.
Let's go back to Rasmus. Rasmus, you've had quite some time to think about the answer. Why would the institution, the business you represent be interested in propellants?
In propellants, just the propellants, like the what fuels the rocket,
and everything linked to it, of course. Yeah.
I mean, it's key. I mean, the thing with rockets as a mode of transportation compared to like regular vehicles, like how you would have planes or trucks or boats, ships here on Earth, is that rockets really don't need a medium to travel in. So for example, you for a boat you need water, for a plane you need some kind of atmosphere, for a truck you need some ground to drive on. And when you start messing with physics in this way, it just becomes very expensive because there's some energy that you need to pay, and you need to find this in the propellant. And all of the things you guys have just been talking about, like doing stuff in space, is going to require a huge amount of logistics, like we were all also talking about just before, which entails moving like lots of mass around in space, which in down the line means we're going to need a lot of propellant. We're going to need a lot of rocket fuel to do this, and until someone comes up with a much better idea than like expulsion-based transportation in space, then we're kind of really just stuck where we are now. So any kind of process or any kind of research that dives into how can we maybe spend less rocket fuel doing the same stuff? How can we maybe make rocket fuel cheaper? How can we make it, on Earth, how can we make it greener? There's, of course, quite a lot of, like you produce a bunch of CO2 and other molecules in the combustion of rocket fuel. Like any kind of progress that tries to address one of those questions I just asked is interesting because just like with technology and innovation, you're going to be wanting to drive things forward. So, and that's really where it is going forward with propellant, right? Because rockets and rocket fuels have been a thing for hundreds and hundreds of years now. I think the Chinese were the first to use it as unfortunately, as a military thing back in the 13th century or something like that. It's old technology.
Tell me, it's obviously a hugely interesting topic in itself, but tell me, do you think there's a probability of some kind of disruptive innovation happening, in the sense that we are still thinking about combustible technologies, not in space, of course, but here on Earth to a large extent? There is some talk about nuclear-powered rockets, which might actually prove to be the future. We've heard of electric versions of it and thermal versions of it being properly researched. We hear some about it, but do you think there's a probability, just like in the world of batteries? Of course, we're working on traditional lithium-ion batteries, but at the same time, you hear of solid-state batteries, which might actually reverse the whole market, change it entirely. So, is it likely that in the next 5 to 10 years we'll see a completely new technology? Do you think there are any signs of that happening now for propellants?
So I think that's a great question. So like just before I jump onto that, you need to ask yourself, what is a rocket engine? And a rocket engine is really just a device which throws out mass in the other direction of the direction you want to go. So any kind of system which does that has the potential to change the propulsion industry and the space transportation industry. Really, what it all boils down to is how many kilograms do I need to throw away in order for me to produce some amount of thrust? And people have been exploring different ways of doing this for a very long time. And chemical rocket engines, like what we see everywhere today for putting things in space, is a very, at least on a high level, a very well understood area. So within chemical rocket engines, there are some signs of like progress that might happen in the future. There's something called rotary detonation engines, which are extremely complex compared to the normal counterparts. But another one, like what you mentioned, is the nuclear technology, right? Where you're not really relying on a combustion anymore. You're just relying on another way to generate energy. I think definitely could have a chance. NASA abandoned their own nuclear project many, many years ago for, I think, largely political reasons and largely because NASA stopped getting funding after they landed on the moon. At least they started receiving less and less. But for sure, I think there are some technologies out there which haven't been explored, which I hope to see be explored in the coming years now that the space sector is becoming more and more privatized.
Rasmus, you've just provoked me asking this question, the question of the famous or notorious space isotope that we know of since at least the 60s and the Apollo program. We're talking obviously about helium-3. What's happening about it? Because this could technically, rumor has it we are running out of this resource here on Earth. There's a lot of it on the moon. So is this one of the directions do you think will be the future? Gordon and Rasmus, how do you think?
So I'll try to answer that. Well, there are significant amounts of helium-3 on the moon. I mean, significant relative to Earth, but we're still talking about parts per million, parts per billion in each regolith, bulk regolith mass or volume. So we need to extract and process hundreds of thousands of tons of regolith to
Which
have
brings us
meaningful...
back to a production line on the
Yeah,
moon.
so we need to develop those heavy machinery, heavy infrastructure for it to actually go forward with it. So I think we're quite a long way to go with that, but that's definitely something for the future and prior development in technology for regolith excavation and for ice excavation would definitely help scale it up to the scales that we needed in helium-3. And I think by that time we might be able to develop those fusion reactors on Earth that we could actually fuel them with that resource. So yeah, I think there's a quite a good roadmap for it for the next couple of decades.
Gentlemen, it's absolutely fascinating to talk to you. In the closing sentence for both of you, I would like to kindly ask you to say something that would send our ERC audience to an interesting reference point or a website or study materials that they should read about, be familiar with in that context. Maybe what Astronica is doing, for instance.
Yeah, definitely check out our webpage. But for space resources, repository knowledge, you should definitely check Space Resources Roundtable conference webpage. So there's this conference every year that there's great presentations about the recent developments in space resources technologies, business model, things like that. And they have a repository. You can read anything from the last 20 years that they developed. So yeah, you should check on that.
Thank you very much, Gordon. Rasmus?
The Mars Society recently, a couple of years ago, they played a big role, I believe, in a huge study which was conducted on the conditions on Mars and how they would allow people to live on Mars. And it's a 100-page study where they went through like everything from like cell biology to fuel production. You can find this by Googling SR-SAG2. I actually don't remember the full name for it. I just remember reading it, I think, a year or so ago, and I was blown back by the amount of detail they covered in this. So I would definitely encourage anybody who's interested in the colonization of space to just read all of this, no matter if like they understand the technical facets of this, because they cover everything. They go through biology, they go through propellant production, and everything in between.
Absolutely fantastic recommendations from both of you. Thank you for joining us here at ERC, remotely, Rasmus, and here on site, Gordon. Thank you, gentlemen. It's been a pleasure to talk to you.
Thank you.
Pleasure. Thanks.
Next up, new robotics project by Stardust, and you will hear about it from Jason Michaud, Stardust Technologies. Enjoy.
Hello, everyone. My name is Jason Michaud, CEO of Stardust Technologies. I hope everyone can hear me. So essentially today, what I wanted to cover is the project we've been quietly crafting and just unveiled not too long ago. The One for All project, which is a robotics haptic arm that will be equipped on a lunar rover by iSpace that we tentatively will have on the moon for 2024, of course, if all goes well logistically. So the desired objective of this project is to ultimately explore the south pole of the moon with the intention of analyzing and collecting lunar resources. So basically what this whole project is about is ultimately this crazy idea that we came up with, arming a robotic arm on the rover so that it could actually feel and touch the surface of the moon and translate this to an haptic glove on Earth or on a space station and whatnot, if you will. So basically, you would be wearing this haptic glove, and you would be feeling these sensations that would be recorded while utilizing the robotics arm, and will be able to actually remotely control, obviously factoring the delays between the moon and the Earth, and ultimately you will be once the project is fully completed, able to utilize this for cases such as repairing other rovers on the moon or utilizing it to operate other tools that you would for lunar extractions. So basically, in other words, we'll give you the opportunity to be able to touch the moon itself. That's kind of the fun tidbit from it, but really the main goal is to provide STEM opportunities and research opportunities so that we can leverage new capabilities that we've never actually had in the past. To say the least, I would love to show more details on the robotic arms. It is still quite in development as we are speaking, but we are really hoping to present it at the next year's events and to releasing a bit more information on the future. But ultimately, why I'm here today is really to share a bit more details, what we're doing, and how can you get involved in how we got to there. I'm gonna keep this pretty brief. I don't want to keep it too boring for everyone, but I was just very happy to share this project. We are hoping to also show you a bit more glimpse as we proceed with this project. This robotic arm, as I said, will be equipped between this collaboration that we've developed between Australia, Canada, and Luxembourg, and also the team of iSpace in Japan, which will be going on the Akuto lander and a newer generation rover, which we are still going to be unveiling. Well, it will be unveiled by iSpace in the future. Without further ado, I'd love to put the video. Not as I said, I don't have too much to share today, but I'm really more here to inspire, let you get inspired, and really hope that people that are listening are knowing that space is really for everyone, and people should really not be scared about jumping in challenges head first. Sometimes we can be crazy in Canada, but we need to be crazy in space, and it's all about collaboration. And I'm really excited to be part of this wonderful community and to be part of this wonderful event that is happening right now. So thank you so much for having me. Merci beaucoup. And without further ado, you can play the video. Nothing very big. We just wanted to just put a small little teaser that we're going to the moon, which is for Canada. It is quite a newer endeavor because we haven't really been to the moon. We tend to be new to this game, but we're really excited to be part of this, and I think it's all about the international collaboration, which really makes it important for space. So, merci beaucoup, everyone.
Studenckie Koło Naukowe Integra działa od ponad 10 lat przy Katedrze Automatyki i Robotyki na Wydziale Elektrotechniki, Automatyki, Informatyki i Inżynierii Biomedycznej. Poszerzamy w nim nasze zainteresowania związane m.in. z modelowaniem, elektroniką czy też robotyką. Aktualnie zajmujemy się projektami robotów do walki sumo, wyścigowych czy też kroczących, które w poprzednich latach zajmowały wysokie miejsca w różnych zawodach, także międzynarodowych. Oprócz tego mamy projekty autonomicznych pojazdów, które mogą same poruszać się w wyznaczonym terenie. W kole zajmujemy się nie tylko działalnością naukową, ale też co roku organizujemy festiwal robotyki Robocomp i nieraz pomagaliśmy w organizacji warsztatów czy konferencji.
Next up, we have a really complex topic to address: how to overcome technological, physical and biological difficulties on the ISS, but also space habitats and space exploration in that context. A presentation by Jawad El Hussein, Stardust Technologies. Enjoy.
Thank you, Rikas. Hello, everyone. My name is Jawad El-Hussein, and I am the CTO of Stardust Technology. So this is a quite interesting question, actually. So I'll try to be efficient to reply this great and difficult question. The first thing we need to know that space is a dangerous and non-friendly environment with a lot of challenges for the human space exploration. When I said human space exploration, I mean all of the difficulties we can encounter, such as technological aspect and medical aspect. Actually, and to be honest, the topic is too wide and large to talk in 20 minutes and answering those questions. So I will try to be fast and efficient. Then sorry in advance if I'm missing some important stuff. Let's talk about the difficulties that astronauts and space agencies met for the ISS in the first time. The International Space Station is in orbit more than 2 decades. In 1988, it is the most complex megastructure ever made in the whole humankind. A permanent house, in 400 kilometers above the sky. Building such piece of technology like this has spent billions of dollars. But beyond the cost, one of the major issues was how can we build such complex and big laboratory in orbit? Technologically speaking, at this time, there was no rocket capable of carrying the ISS in a single flight. Only the Space Shuttle and Soyuz could carry piece by piece the station in several missions during over 10 years. I will not talk about how technologies are using in the ISS for the daily life, such as toilet, cooking, or even the machine for drinking, and how they succeed to carry them in the ISS, because it will ask us a lot of time. But beyond this, one of the possibilities to overcome technological difficulties in the ISS could be using 3D printing technology, for example. Last year, I was talking with an engineer in the Canadian Space Agency who is responsible for the Canadarm in the ISS. So the Canadarm is a big robotic arm you can see in the International Space Station. And he told us developing a complete deck for using this arm is very expensive. One of small piece could be over 50,000 US dollar. So if a piece doesn't work anymore, they will need to wait a cargo before having the possibility to use the robotic arm again. In the ISS, it is easy as the Earth is very close. But what about in the Moon or Mars? The CSA and Canadian companies are involved to the Gateway Station in the Moon, and this engineer see a potential of 3D printing to rebuild the broken piece in orbit and save time and money, because yes, money is an important thing for space exploration. Imagine 100 years or even 200 years later having the possibility to build space station with robots and 3D printing. It will be definitely a big step for the human space exploration. About the medical difficulty in space generally, I will only talk about the psychological aspect regarding our project Eden we are developing in collaboration with the Canadian Space Agency and the National Research Council of Canada, because again, the topic is too large. The Eden project is a psychological experience allowing astronauts to help them for the confinement in space through medical activities and entertainment. We are using several technologies such as virtual reality, augmented reality, and haptic feedback to measure and evaluate astronaut level of stress, and our artificial intelligence will generate exercise for reducing the stress of the subject. NASA and other space agencies around the world measure the negative impact that long-term isolation has on the psychological level on astronauts. It's not good. For more details about this NASA report, you can check on the NASA website in research topic with ID 964. Just as Sigmund Freud, the father of modern psychoanalysis, did for soldiers during the First World War, we are tricking the brain through our virtual experience. Dr. Freud has conducted several psychoanalytic exercises to treat soldiers who suffered from severe trauma from the horror of war. By tricking the human brain, he succeeds in reducing the stress of the soldier until they were completely cured. For him, unconsciousness is the key to cure all psychological illness. With Eden, we trap the human brain using virtual reality and our haptic combination. We generate terrestrial environments such as a forest, a desert, and we are adding sensation of weather, such as wind or rain, thanks to haptic technology. Because when an astronaut goes to space, he will not longer be able to feel the simple things we are feeling on Earth, right? Living in a constant small place, it is not good for the human. We also can see nowadays the side effect of the global confinement on Earth because of the pandemic outbreak. A lot of people are suffering of PTSD illness. Exploring the unknown is not a new thing for the humankind. 600 years ago, our ancestors in Europe meant the exactly same issue about how to overcome technological, physical, and biological difficulties, but not on a spaceship, on a boat. It wasn't easy it wasn't an easy task to cross the ocean at this time. Oceans like space for us in the 21st centuries. Didn't know what's on the other side of the ocean. No one knows at this time during those expeditions when they will be back or if they will be back alive. Millions of people died during the conquistador time when people from Europe traveled to America. We are facing the same issue, and as Elon Musk said recently, people will die for sure during those deep space missions. So we need to learn from the past. How did they overcome all of this challenging during this time? One of the key of success was entertainment. It was important for the crew to find activities during those long journeys in the middle of the ocean. It will be same for astronauts in the middle of the space. Doing sports, playing cards, singing, dancing, even fighting or military training was the exercise, the activity at this whole time. It was tough, psychologically speaking. Astronauts need to escape sometime from the permanent confinement. You know the problem why we cannot go to Mars as soon as possible. It is not really about the technological aspect. Of course, they have the danger of space radiation, but let's say we have unlimited funds for such mission and we can solve this problem. The huge issue will be how the crew of the mission will feel when they will see the planet Earth like a teeny star in the middle of the space. They will know it is impossible for them in a short term to go back to Earth when the vessel will go to Mars. One important thing, a crazy thing for me, they won't be able to feel the wind or even take a normal challenge during years. They won't be able to eat normally or even drifting normally because of lack of gravity. The gravity on space, well, they now have no gravity on space, and on Mars in 1/3 of the Earth's gravity. And it affects, biologically speaking, the body. What's gonna happen? We don't know because we never met such things before. And Space Habitat or analog mission will never answer those questions because those people who are doing those analog missions instinctively know they are on Earth and safe. If someone in analog mission have a heart attack, that's okay. We call 911 and we bring the person to the nearest hospital. And end of story. The crew will not stressing and the victim can be saved in time. What about someone having a health issue in the middle of nowhere, hundreds of millions of kilometers from Earth? No 911 at this time. No one gonna save you. Talking with the Earth will take dozens of minutes because of the distance. It could be a very stressful and difficult situation for the entire crew, not only for the guys who have a problem. Unfortunately, and in my opinion, space agencies, they are not focusing too much about the psychological aspects in space. For what we saw during our research for the Eden project, and even for me, it's definitely a huge mistake. As technology said, is not the problem for space exploration. We can make it. And if we can't make it today, or right now, we will be able to make it in the future. Because science technology constantly evolves. But the human psychology is not like this. We are not robots. One day we will feel great, and the other day it won't be the case. We need to know why, and how can we solve that? And if it's happened, how can we cure that? Or even, how can we prevent that? Human psychology is the main and big problem for the space exploration. The European Space Agency took the problem in the other side. They said, what if we put all of the crew in stasis? Artificial coma during the travel and make them wake up a few months before they arrive. It could be an incredible discovery for space medicine, but also conventional medicine. It could solve definitively the problem for deep space travel, and everyone will be able to go to Mars on another planet. The main idea of this technology that the European Space Agency are working right now is to copy what bears do during winter. Biologically speaking, bears are mammals, like us, humans. They are saving 75% of their own metabolism when they are sleeping during winter. But unlike humans, bears can wake up in perfect heat condition. For humans, sleeping a long time can bring a lot of heat disease, such as a lack of motricity, and it could take months for to fully recover these things. So of course, and unfortunately, we are very far to get this solution ready. The only way right now to overcome the biological difficulties on space generally is to have a specific training for those long-term confinement. Medication have a huge role to play on this, obviously. What we observe during our research using virtual reality and haptic feedback here in Canada is we can recruit stress event for subject. And it is working pretty well. Stardust are involved to the safety security in the mining industry here in Canada. Miners are facing similar issues like astronauts when it comes to small place and confinement. Some young miners, they think they can do the job 100 meters under the ground. But when they face the real environment, they feel uncomfortable. And of course, the job won't be done in the right way. With VR, we recreate this environment and we are measuring the psychological, physiological, stress on different kind of situations that the miner can meet under the ground. At this time, we can know if the person is good to the specific task or no. We can prevent an accident like this. Another promising result we find in the microgravity when we are doing zero-G flight. We are not feeling the up and the down. It's mechanical actually. The inner Earth is like disabled because no gravity. It affects a lot of astronauts in the International Space Station, especially for reading a speed when someone throws an object, for example. We call that vacuum. Or astronauts can be sick during days because the brain is kind of lost. For us, when we were testing Eden, we were virtually in a kind of environment with the ground and sky. The interesting things during the short time in micro-G by testing Eden, we did not feel any disorientation. When we pull on the headset, the uncomfortable feelings start to come back again. Unfortunately, we cannot share any footage from our project right now. So in the video you are watching, you are not watching this. So we're only showing a small exercise we did to test the equipment in the zero-G. Anyway, building this kind of training for astronauts is absolutely meaningful. As again, in my personal opinion, psychology is more important than everything when it comes to exploration. In space or on Earth, it doesn't matter. And another idea could be to set up a truly analog mission in space by putting a small crew in 1 million kilometers from the Earth and see what's gonna happen. It could be an interesting experience, as it could take just a week to reach this orbit, and I'm pretty sure doctors and scientists could get great results about this. So, to give a conclusion to my presentation, is we need a lot of patience and ingenuity to overcome all of problems associated with space exploration. But above all, we have to learn what's happened before in our history. Because finally, history always repeats. Thank you everyone for listening to me.
Ladies and gentlemen, wonderful sunshine here in Kielce at the Kielce University of Technology, and we are joining Anna and Remco to give us a broadcast from our Mars yard. Let's see.
Mars Yard of the European Rover Challenge 2021. My name is Remco Timmermans, and I'm going to take you on a little tour of the Inspiration Zone, and I will explain to you in a minute what that is, because we start at the edge of the Mars Yard here, where we will talk very briefly about the maintenance task that our teams here in the competition need to accomplish. In front of me we have a panel with switches, with a few plugs that are here for the rovers to perform their maintenance task on. And this is simulating the rovers on Mars or on the Moon basically maintaining each other. So we have a rover performing maintenance tasks on another rover, or in this case the Mars Society Polska lander. So one of the challenges for the teams is, for example, to set these switches or measure the currents going into these plugs here. So now, as I said, I will take you into the Inspiration Zone, which is just a little bit further down. And the Inspiration Zone is really one of the three zones that we have here in the European Rover Challenge this weekend. Three parallel events, if you like. We have the Mars Yard, the competition on the Mars Yard here, and the rovers are at the far end for the competition. We have the conference, and hopefully you have seen the conference in the live stream that we put out there all day. But in the middle of that, we have what we call the Inspiration Zone. And the Inspiration Zone really is for the local audience to see what's going on in space and robotics. So let me take you into the Inspiration Zone area, which consists basically of a number of booths where we have different partners presenting the latest and greatest on space and robotics technology. So let me just take you through a few examples, starting with well, our own tent, the European Rover Challenge tent, which is right here, where our science team is presenting examples of the science that is being done by the teams on the Mars Yard, and showing the real applications of those experiments, but also allowing kids that we can see here to perform some experiments themselves and to learn about the basics of planetary geology and planetary science. So very exciting. Let's move on. If to be a little bit careful. It is a busy day. It's a beautiful sunny day here in Kielce today. It's not just about space and rovers, it's also about application of some of the technology that we see here. Like, for example, in these university-built cars that use some of the same technology that our rovers on the Mars yard are using. Okay, let's move on. Be careful for rovers on the footpath here. But let's move on to, we'll take a right here. Let's move on to one of the actual teams that has a booth here. Not only does the Arcos team, the Swiss Arcos team, compete in the rover competition, they also have a booth here where they show some of their technology and some of their well, the technology on board of the rovers to the people here in Kielce. The EPFL Explore team from Switzerland. So thank you for having us in a minute. Can you tell us a little bit about what the audience can see here?
With pleasure, yeah, sure. So we have mainly here on the side, we have our model of the Mars yard that we used to plan our course yesterday. So we started out in this little corner here, did our first navigation task to go around this crater.
This is actually a model of the Mars yard here.
Yeah,
oh, that's brilliant.
So this way, we could have done all of this, of course, on a computer with the 3D software, but it's much more interesting to have something physically there because you realize also the in quotes, dangers of the Mars yard. You have these, the steep inclines that when you see them this way, you know immediately there's no chance the rover can go up that.
And tell me a little bit about these test tubes that you have here, because we have NASA Perseverance right now filling test tubes, and I see test tubes here. What can you tell us about that?
Exactly. So this is our science base. So this is where we do our scientific analysis. So we have basically we can analyze the color, we can analyze the grain size, and we can analyze the density of the samples. And if we take samples at different locations, we can perfectly compare these samples to each other and perform, so we can verify our geological assumptions and hypotheses.
Wow, that's brilliant. Is this on board of your rover as well?
Yes, exactly. It was on board yesterday.
Oh, excellent, excellent. Well, thank you very much for this quick introduction, and let's move on to the next tent here.
Have a nice day.
Thank you. All right, and our final destination for now is the Lunaris team, and Lunaris is going to tell us about the human exploration side of Mars, because what we see on the Mars yard, of course, is the robotic side of things, but what the Lunaris team is doing here, as you can see in their astronaut uniforms, is really showing what human exploration on Mars looks like. So I'm very happy to have Leszek here, who can tell us a little bit about what the human side of Mars exploration or lunar exploration looks like. So can you introduce yourself and tell us what Lunaris is doing?
Certainly. So my name is Leszek Orzechowski. I'm a facility director of Lunaris Research Station, and Lunaris is an analog habitat. This is a place where we are simulating Moon and Mars missions using, well, analog astronauts. So real people are isolated there, and scientists are, well, getting a lot of data on how these people perform in a group in this isolation, because obviously there's a robotic exploration of space, and rovers can always break down. But when it comes to human life, it's better to test everything here on Earth to see, because humans could be like a weakest link on any mission, and we need to make sure that the crew is very well prepared, or we have the right people there. There is no tensions, and all tensions first must happen here in an analog habitat.
Can you show us some details?
Sure. So this is a model of a station where currently 6 analog astronauts are isolated. This is where they live. So modules where they sleep, work, where they prototype new tools. and are growing plants using some hydroponic setups.
Right, and let me ask you before you continue. This station is not on the moon. Where is this station physically located?
In Poland, on a former military airfield in Piła, and we are using one of the former hangars from the Soviet era to have our isolated moon yard or Mars yard, where they perform EVAs, so extracurricular activities. And currently we are streaming one because crew is isolated there, and they are, well, we wanted to show participants of ERC how such extracurricular activity looks like. But obviously, crew is doing their job, and psychologists and sociologists are doing their study on this group, so group dynamics and how to, well, avoid third quarter phenomena, so exactly when the tensions arise during any expedition, and they're exactly in the third quarter now, and hopefully due to their this event like ERC, they're extremely focused and motivated to do the best possible EVA right now. Maybe we will not see anything disturbing in their behavior, but maybe it will sprout some tensions inside the crew. So we will see after the event how they survive this stressful situation of showing.
Okay. So is the Lunaris analog, is it all about psychology and about the human factor, or is it also about technology like what we're seeing here?
Certainly, because we are architects, so it's also a testing ground for us how to design healthy living space, because it's not all about choosing the right crew, it's also creating the best living conditions for them. Also, it's all about sustainability, so how you manage your water supplies. So right now we are testing our grey water system, where they are gathering water used in from their showers or for washing hands, and if they can use it for growing plants. So it's something that could be used on the moon, but also obviously on Earth. So this is for us as architects, it's very important to create this sustainable facility as well.
Okay, brilliant. Well, thank you very much. I hope people will have the opportunity to visit you and to actually see, because I see you have monitors inside the hangar and inside the analog, where people can see live what's going on. They can ask you all the questions. That's it for the Mars Yard and for the Inspiration Zone now. Keep following us on the live stream. Keep following us on social media. We are on Twitter, LinkedIn, Facebook and Instagram on hashtag ERC21. And I am looking very much forward to seeing you again live from the Mars Yard tomorrow.
5, 6, 7, 8, 9, 0.
Ladies and gentlemen, time to get deeper into some of the topics we are addressing. And as you all remember, at the center of it all is the moon. The second day of the European Rover Challenge 2021 is about the moon. Ahead of us, still, one debate, one space talk, and another, hopefully hugely interesting debate. That's what all of us expect from here. Now, business case for the moon, a very interesting topic. We've touched on it a number of times in different ways already and discovered that some of this is still in the wishful thinking and fantasizing area. Some of it is existing technology that just needs to be scaled down, and the cost of bringing it to the moon just needs to fall very significantly for anything like that to happen. Business case for the moon, with the participation of Katarzyna Malinowska, Koźmiński University, Aleksandra Bukała, Polish Space Agency. Hopefully Gianfranco Vincentin from European Space Agency will also be able to join us. We have Ken Davidian, Federal Aviation Administration. We have Maria Antonietta Perino, Thales Alenia Space. And we are starting in a moment.
We are live. Okay. Good afternoon, ladies and gentlemen. Good afternoon, Maria Antonietta. Good afternoon, Ken. I know that for Ken it's actually early morning because Ken speaks to us from Washington, D.C. And hopefully we will have on board with us Gianfranco Vicentin. Alexandra, we have a topic today which we are not fully compliant with each other. Well, yeah, so to say, we decided to focus on a few questions. And these questions, I hope we will be able to see them on the screen in a moment. Yes. We are going to talk about why are we going to do the business on Moon. We are going to talk about who is going to do that, who is willing, who is going to make a business out of it. And then what and how. What kind of business? What kind of business? What are the risks? There are maybe only the risks. Okay, starting from why, as Simon Sinek claims, why are we going to make the business on Moon? I have my mantra, don't we have enough problems on Earth? Can we save the Earth doing business on Moon? And maybe we don't need space or Moon to live happily and save our lives. And just one thing I know, I see Alexandra raising up, but just a moment. Usually when we talk about making a business, it has two whys. The first one is solving a problem. So there must be a need, a real need or extraordinary need. Or there is something like capturing opportunity. Is there something about it? Alexandra, I have my doubts.
Yeah, well, I know that many people now in our economies think only business-wise, and in that case, it is not a simple business. It is not like opening a shop and making money out of that. The Moon is for us still something new, something challenging, something which is also an adventure. But without this spirit of our adventurous spirit, our explorers' need, we wouldn't even go out of the cage when we were there. But let's maybe listen to our speakers, and Ken, maybe you could share your opinion. Why, and if there is any sense of going back to the Moon?
To make business, be precise.
Yeah,
yes, to make business.
To make business. Hello, everybody. Thank you very much for having me today. My name is Ken Davidian. I work at the United States Federal Aviation Administration Office of Commercial Space Transportation. I tend to look at business from a theoretical perspective, looking downward in. So to me, making business, doing something commercially, there are many components to it. There are at least 3 components to doing this. This is the variation, selection, and retention. So what are the sources of innovation? What are the sources of financing? And what are the sources of demand? So there's got to be all these 3 different components getting there. But before I dig down into that, I want to address what Katrina said, talking about should we be looking at the Moon when we have problems on Earth? And you know, every technology, any activity has 2 sides, at least 2 sides to it. There's a side for good, and there's a side that's not so good. And so there's a saying here in the United States, not really a saying, but a philosophy that says you want to minimize the bad stuff and maximize the good stuff. So going to the Moon, you want to make sure that you're doing it to minimize the bad things on Earth, but also to maximize the benefits that you can go there. So I'm absolutely sure that there are benefits to be had on Earth by going to the Moon. But now the question is whether or not there's a business case for that. And when you're talking about what is a business case, you're talking about both a business model, which is value creation and value capture, as well as the operating model of how the business is done. And when I talked about variation and selection and retention, the variation and retention part of that, the innovation and the demand, those are parts of the business case. And so that's what we're kind of focusing on. But the selection, the financing of this is also important, because when you start looking at those three components, that tells you whether or not this is actually a real business. And so it brings up the question of what do you mean by commercial and all that. But I think there are real businesses here when you start looking at what are the different sources of innovation and how many innovations do you have? What are the sources of financing? And then what is the source of demand? So this is the framework to try to answer that question.
Okay, but is it, we are talking about the need, yes? So it's why are we going to try to make business on the moon?
So there are two different kinds of needs.
Yeah.
There are rights of a citizenry, and there are privileges, right? And it turns out that when a need is a right, let's say a need for healthcare or a need for freedom of expression or whatever it is, those tend to be things that can be provided by the sovereign nation, by the government. When it's a privilege, that should be not necessarily provided by the government. That's something that could be provided by a non-governmental organization, let's say a private or a commercial organization. So depending on the need, it could be that this would be proper to be done by the government and paid for by the taxpayers, at least from the United States perspective. So going on a suborbital flight or going on a space tourism trip to the moon, let's say.
That's the point. That's the point.
Right.
It's
that's
one of the
privilege.
It's an extraordinary need. Yeah, it's not real one.
It's not a right.
But I would stress a little bit the other point about the real advantages or the real benefits that society has from being to the moon. We have been to the moon already, and it has created a lot of things that somehow defines our lives today. I always like to use an example of the smartphones. The progress in electronics needed for the Apollo program was the driving factor for what we have today in every pocket. So it has changed a lot of our lives a lot, and it has created a lot of businesses out of that. I don't know, maybe Maria Antonietta,
yes.
Maybe you could comment on that.
Yeah, because both of you are from governmental structures. So I would love to hear the comment from a prime contractor. Yes, Maria Antonietta.
Yes. Again, as Ken said, thanks a lot for inviting me to join this discussion. By the way, among friends. Ken is a dear friend of mine. We have been knowing each other and working together for decades. Well, let me briefly tell the audience who I am. My name is Maria Antonietta Perino. I work in Italy, in Torino, in Thales Alenia Space. I am an engineer. In fact, I'm a nuclear engineer who fell in love for space. And it's precisely to the point we are discussing. My thesis 35 years ago was about using lunar resources to build solar cells on the moon to provide power, not only for the lunar infrastructure, but for the benefit of, in fact, in reply to terrestrial needs. So, having said that, I come to your point, Alessandra. I fully agree with you. We cannot stop progress. We cannot prevent people from exploring. The need to discover what there is behind the corner is inside our soul, is part of our human nature. So then we can discuss the business case. But the need to go and know better what there is around us is a must. is really something that has been there to push people exploring seas in the past, and the current seas are just the stars around us. So yes, we go to the moon because it's a natural evolutionary path, and we won't stop there. We will move further to Mars and beyond. In fact, there are many reasons also from an economical point of view to go back to the moon. The moon is full of resources. There is silicon, as I said before, iron, aluminium, oxygen, a little bit of helium-3 that we don't have, is an isotope of helium that we don't have on our planet, and that could in fact have a huge economical plus for helium-3 to be used in fusion reactors, both on the moon and for sure on Earth. And so I fully share the opinion of Alessandra. By going there, by learning how to extract these resources, by learning how to live in a different environment, we develop technologies that are not only good to meet that objective, but these technologies are good and important to be used and to improve our life here on Earth. Then we can discuss ethical aspect, for sure commercial aspect, but we won't stop that. So it's a simple equation. The moon is there, Mars is there, we want to be there as well.
Okay.
My opinion. And also, sorry. Also, I want to give an industrial point of view. So up to now, I spoke from a humankind point of view. But for a company, a larger space company integrator like Thales Alenia Space, exploration is really providing a new boost. Thanks to Artemis and all what flies around Artemis, we are really hiring new people. We are, advancing in new technologies. So I think that the value is not just the commercial value of the moon per se, but the big value is how can I say, the spin-off in our society.
Yeah, to be honest, I'm very happy to hear that. Asking you, Maria Antonietta, I was a bit afraid of talking that the why is the money, but you haven't mentioned it. I'm really happy to hear that.
Not yet. We can discuss about that too, because for sure we need to invest a lot. We are not becoming rich since the very beginning. But I don't think that that's the point. You can be rich for many other reasons than just money.
Okay.
My opinion.
Very true. Very true.
Thank you, Maria Antonietta, for agreeing with me. I think that we all agree that there is something more in coming to the moon. Not just a business case, but also I think that we all agree that the business case is there. Difficult to measure at that point exactly. But I believe that the benefits that we are going to make, also the benefits that companies are going to make out of that business, are far beyond any expectations that we can make at that point. But I would like to come back what has been said by both of you, that we need a kind of a framework to execute that project. And we need a legal framework, and that's for sure. We have a lot of issues about how to utilize resources from the moon and how we can legalize that, and in the frame of current legal framework that we have. We have a lot of risks also.
Wait, but who is going to make it?
Exactly.
Who is going to make it? Okay, that's the discussion. Is there a business case? I think we should be honest to each other. We don't have to have a business case on the moon, but just because, as Maria Antonietta said, and I think we agree on that the money is not the only driver we should have. But we should be very transparent. Maybe there is no business case on the moon, and it's still okay to go for to the moon and explore it.
And maybe if there is even a business case,
maybe there is a side effect.
The question who is a very important question.
Who is going to make it?
For
who
us?
Who should make it?
Yeah, institutional.
Well, for sure, there are many new actors. The space sector is changing super fast. Until I would say 10 years ago, it was a matter of space agencies and large industries. It's no longer like that. The players you agree with me, have different colors. There are still space agencies, there are still major companies, but there are a huge variety of brilliant new enterprises that enter and want to play the game, also for economical reasons. There are countries that are scommettere, how do you say in English? Betting on this business case. Think about Luxembourg. A few years ago, they decided to put on the table 40 million euro to sustain new companies that would address the business case to go out and mine asteroids. For sure, it's a complex architectures where each of us has to find the proper place to contribute to the big picture. It's like a puzzle. Ken?
What I would say is Maria brings up a lot of really good points. And I think one of the points that were brought up that are really good is that there have been a lot of new actors, a lot of new ideas, a lot of new innovations, which is a really strong indication of this variation force that I talked about. And this is part of the value creation part of the business case. So in that component of the business case is strong. But the other side of that, and which would make me wonder whether or not there really is a business case here, is that the value capture, which is the demand right now, the only, like you said, it's Luxembourg, it's ESA, it's NASA, it's government agencies, it's not non-government agencies. So you've really got a unidimensional source of demand. So I would say that that's an indication of a weaker business case. So you've got a strong component of a lot of companies thinking about doing this, but they're not doing it for privilege, or they're not doing it for private customers. They're doing it for government customers.
Yeah, that's true. But there are big, and we know who I'm thinking about, big commercial companies that have devoted money and resources to build the infrastructure to go there, Ken.
Yeah, right. But so this is where I would say, are these activities commercial? A company can do both commercial and non-commercial activities. So are these if these activities are for governments, then I would argue that these are at best monopsony market. And these are markets these are single customer markets, basically, where the government says, I want this. So industry, not commercial, industry and commercial are different things. Industry steps up and serves the government purpose. And so that's great. And there are many things, as has been pointed out, the technology developments through the space program that have benefited the citizenry, that have benefited all of the people.
Yeah, you talked before about privilege. Don't forget also that this increasing demand of space tourism. This is not government. This
That's
is
right.
public.
And
This is public.
we're talking about the moon, and there has been some indication of cislunar transports on a
Precisely.
SpaceX flight. It hasn't happened yet.
No.
On Wednesday, Inspiration 4 is flying. SpaceX is flying four people.
Yes.
Three
Civilian. Yes.
It's not lunar, but you're right. It's space tourism. So we are seeing it. So there are glimmers of hope, or glimmers of non-governmental demand, and that's why I'm saying the business case is not super strong, but I think it's
growing. It's growing.
I think it's there, and there are plenty of ideas for operating models. What type of methodologies or processes or technologies could be used to carry it out. So I think that part is also strong. To get to the question that Katarzyna was asking about, which is who is financing this, and I think that currently it's primarily governments. There is some non-governmental finance in lunar activities, which is good. So that tells us that there's at least a weak or moderate selection force. So again, I bring it down to this three-dimensional axis kind of perspective of a commercial market, of one axis being variation, one axis being selection, and one axis being retention. You've got three dimensions there. And if you're on one of the planes, if any one of those forces are zero, then it's probably better and easier and faster for the government to carry it out. If it's a monopoly, we have government organizations carrying out monopoly type of functions. If you have monopsonies, which is like what the space race is, where you have a lot of industry competitors, but you have one government leading the charge, then that's the government does it. Also, if you have state-owned enterprises, the government is kind of calling the shots there. So these are all teleological motors of change. So it's a central agency saying, this is the direction we want to go, and this is how we're going to get there. And they get there fast, and they get there with the best technical solution. Commercial markets are not the fastest. They don't give you the best technical solutions. And, they can't, it's sort of not random, but it's sort of kind of groping in the dark of what actually works. And so commercial is not the best way to do some of these things. So to maximize the benefits to society from the space program in the 60s, it was good that the governments led that, because that's how we made sure that those benefits came back to people. If you let the commercial sector do it, it would take a lot longer, and you might not get the best solution. So it's a trade-off. When you're spending people's money, taxpayers' money, you want to be more efficient. When it's a privilege, and it's about tourism, then fine. The commercial sector can do it. So I think in terms of the lunar market, I think there's evidence that there can be a business model because there's a lot of innovation. There's some non-governmental, there's some variation, let's say, in funding, but the level of demand tends to be predominantly government. So there hasn't been enough there in terms of non-governmental demand, but it'll come.
I heard you saying, Ken, that when is the government the driver, things move faster. From my point of view, I don't know. Well, I love so much exploration and Mars that honestly, I would have expected to have humankind back on the moon years ago. For sure, government has plenty of resources. So when a country decides to do something, there is they find a way to move. But I think that private entities can speed up, especially when there is competition, among countries / companies. Let's say competition between 2 actors, 3 actors, then somehow there is a sort of push. For sure, the nature of this type of missions is very demanding, so it makes a lot of sense to sit all together around the table and understand who can contribute what. And we are lucky because this is precisely what happened starting, 10 years ago. more or less, when the different space agencies decided to draw a shared roadmap for exploration. So the path is clear. Vicinity of the moon, and then Mars. Don't forget the asteroids around you, whenever it's convenient to go and grasp something interesting. But I think that the private sector can, with respect to what you just said, the private sector can in fact inject a push in the plans that have been shared, countries/agencies level.
No, I think a good I was going to say a good counterexample to what I just said is SpaceX. Look at what they're doing in terms of development of Starship and Booster. Absolutely, you're right. But I would also say that number one, Artemis is a government stated goal. This is not a goal that's set by a consumer market. So this is not by definition, it's a teleological motor of change. It's not an evolutionary market. It's not a commercial market, because the government set the goal. And a lot of the slowness that we're seeing, you're right. If there was a single company or two companies that said, let's say there's 2 countries and the goal is get to the moon and back safely, it can do it in 9 years, no problem. But they can do it. But when a lot of the slowness comes when now you have to negotiate the relationships of multiple parties, and this is what we have with international organizations. And the more the parties, the harder it gets to coordinate, and so the slower it can go, or the higher the cost of that coordination gets. But like I said, that if the goal is being set by a central organization, it's hard to make that commercial. There can be commercial aspects to it, but if the goal is being set by consumer demand, whatever that is, or however that's created, consumers don't even know what they want, right? And a lot of times the suppliers have to figure out what the consumer wants. The consumer has to figure out what the supplier's giving and how they can use it. So it's an evolutionary process, and that's why I would say that the evolutionary process goes slower than a driven process, something that's teleological, where there's a goal to find. And
that they share. Okay.
And this is exactly what I wanted to say, and I fully agree with Ken here that okay, we have been to the moon almost 60 years ago, and nothing has progressed so much. So for there was no obstacle to do it commercially, to do it through the private investment. But this is such a complex endeavor that it needs some kind of a institutional framework, especially that it is multi-country, to move it forward. And so now we have this discussion, which is quite advanced, on how we want to go back to the moon and then maybe go forward to Mars. And we have so many countries involved. It's not 2 countries anymore. There are multiple players that agree that this is necessary, and there are a lot of institutions, and Polsa is one of them that is involved in this process. And I believe that this is the best way we can come back to the moon and enable a commercial exploration, enable this real business case that can be then be led by industries. But I would like to come back to the question that Katarzyna asked, or the doubt that she has been expressing in the beginning. How can we convince taxpayers that there is a business case for the moon, and that there is the need for institutional investment? We are all here, let's say, experts, people that do this business for every day. But sometimes when we meet with a larger audience, we have a question that we have a lot of problems on Earth. Why the hell we should spend money on exploring the moon. So I know this is not an easy question, but I would really like to hear your opinion on that, Ken.
Maybe
So
we
again,
don't need. Sorry, just to interrupt.
No
Additional question to that. Maybe we don't need a business case to convince the society to pay for it. Is it the business case which would be convincing solely business case?
Yeah. So I don't think the business case would be convincing to people. I mean, the taxpayers, again, shouldn't be. I mean, we talk about commercial exploration. Exploration is to my mind, it's human-based research. It's using humans in research. It's a research question. The return on investment in research on a global, in the macro perspective, is always less than 1. Yes, you might identify a certain technology that makes major returns beyond what the investment is, and you have a return of investment greater than 1. But on the average, right now, the way we manage technology and the way we manage information and change, ROI on research is less than 1. We don't know what we're doing. There are going to be failures. Therefore, you're going to put in more than you get out. That's kind of standard. There are ways to try to change that. And Alibaba in China and different companies, being the way they're setting up, are trying to change that ratio. And so the space agencies need to change as well. We have to change the way we operate our business to enable to increase the return on investment, maybe approach 1 or even get greater than 1 when it comes to research. So should the taxpayer be asked to pay for something that would create a business opportunity for commercial ventures? And if there's going to be in the United States, we don't tax our companies very much, right? So the companies make a lot of money, but when they have a lot of losses, the government bails them out, and people have problems with this. In other countries, it's different. They tax their companies more, so there might be more of an interest in investing in companies to make more money, like Luxembourg, right? Luxembourg is not doing this out of the benefit of the goodness of their heart. Luxembourg is trying to generate some return on investment, and so that's why they see the next best thing as asteroid mining and in situ resource utilization. So they're doing it to benefit their citizenry. So that decision has to be made on a government by government basis, I guess.
If I may complement what Ken rightly said, Katrina, 2 minutes ago you said we went to the moon about 60 years ago, and then nothing happened since. I don't agree with that statement. In fact, many things happen, not on the moon precisely, but in the last decades, plural, we develop enabling technologies that will make possible a return to the moon with a completely different approach. In the 60s, it was a matter of go there, plant a flag and come back. We cannot defend any longer in front of the public opinion this type of approach. We need to really substantiate our return to the moon with services and benefits that we can provide to the humankind back on our planet. And so, in the meantime, from the Apollo times to now, all the human activities on board the International Space Station allow us to learn better the space environment. We learn how to live in a different way, how to work in a different way. We have technologies now that will allow us to go there and, as I said, mine the resources. We'll go there, and from there we will sustain a lot of, Ken mentioned science, a lot of scientific activities that have, how can I say, an economic value that we cannot even, name how big it is. But coming to your question, why the taxpayer shall be happy of few of us spending money to go back to the moon? We have to show the value for humankind, and there are many advantages, both for technological advancement, but also for materials, but also to further develop the economy out of our planet. So we somehow the space sector is moving from how can I say, a sector where we were only building elements, pieces of technologies, is moving to a sector where we are developing services. So it's really different mindset. We provide a service. For example, we satisfy the need for scientific research. For example, we satisfy the wish of tourism, I mentioned before. For example, we find materials that we cannot find on our planet, for example, to generate energy. And energy is an increasing need on our planet.
Wow. Yeah, I fully share your point, especially the last one on the energy, and in general, I would say on the use of resources. This is a big discussion. This is a big debate that we have now on the climate change on Earth, and that we should change the way we are living. And this is exactly what we are facing in space every day. We are lacking everything. We are lacking gravity. We are lacking oxygen. We are lacking water. We are lacking energy. And these are challenges that we are going to face on the moon. And maybe this is one of the ways we can come to the general public and tell them, yes, this is important, because this will help us to better manage ourselves
on
and our planet.
Yes, the learning that we have in space, how to reuse, how to regenerate the resources is a key issue for our planet,
Yeah.
for sure.
I was going to start a discussion about what we can do on the moon, but I see Łukasz raising up and to say farewell to us. Let me just say a few words. If I'm convinced, I will not reveal, but I'm very happy to see that maybe there is business case on the moon, maybe not. But most importantly is probably there is. But most importantly, this is not the main goal. The business case can go as a side effect, very positive side effect. And maybe this is enough for us.
I would say that the business case is there, but also there are other important issues apart from our need to explore, and that is part of our nature, human nature. I would say that this thing of managing ourselves in a harsh environment would be one of the important issues. But I can see that we are out of time.
Thank you a lot. Yes, but only me said the word money. So, and we are discussing business. Thank you a lot. It was lovely to have you here. And I think we should proceed with this discussion, but later on.
We will continue for sure. Thank you, Maria Antonieta. Thank you, Ken. Thank you, Katarzyna.
Thank you, Alexandra. Bye.
Bye.
Thank you. Ciao, Ken.
Ciao, ciao. See you in Dubai.
Yes.
Ladies and gentlemen, next up we have an interview with Andrew Chaikin, a man on the moon, the voyages of the Apollo astronauts. That's the title. Andrew is the author of the book Man on the Moon, the Apollo Program, released recently by Astra Publishing House, 2021. It's as fresh as it gets, apparently. Andrew had the opportunity to meet astronauts and people whose passion and persistence led to the first human landing on the moon. The discussion will be moderated by Mateusz Józefowicz. Mateusz, over to you. Enjoy.
Thank you very much. Can you hear me? Hello, Andy. It's great to have you with us.
Hello.
Thank you for accepting the invitation.
I can't quite hear you.
Okay. Let's see about that. Raz.
Your audio is not coming through my feed.
Okay, we'll check it. Can you hear us? Can you hear us now?
I can hear you. I can hear you fine.
Okay. So once again, thank you very much for accepting the invitation. Great to have you with us at this event on the Lunar Day, and we are going to talk about the lunar book and the lunar adventure that actually it reveals. So I had the honor to be translator on the book, so I've already went through this adventure, and I thank you. It's really a voyage, and this is what the title is about. So this is the voyages of the Apollo astronauts, a man on the moon, and this is a history of Apollo program. And my first question is actually, what is space history? Space exploration is considered a thing of the future or a thing of the present. So what does it mean to be a space historian, and is it really a closed chapter? Should we consider this as a closed chapter?
Wow. Well, so it's a great question for me personally, because when I was growing up and I was completely caught up in the space program and so excited to see humans going into space when I was young. And then I was in junior high school when Neil Armstrong and Buzz Aldrin made the first moon landing and the first moonwalk. And I was in high school by the time the Apollo missions ended. And I had no idea that there were people called space historians. I never dreamed that I would become a space historian. But really, space exploration is like any other aspect of human activity. We want to know what happened. Those of us, most of us who are not involved, want some way to share the experience. And one of the ways that we get to share the experience is because of historians who go in and talk to the people involved, talk to the people who actually do it, and find out what happened, why it happened, what it was like, that all of those questions that we would have being curious people. So I did that for Apollo. I did that specifically for the astronauts. I wanted to know, what was it like to go to the moon? What do you see? What do you feel? What do you think when you're standing on the surface of another world? And what do you think about when you come back and you see the moon in the sky? And those were the questions that were in my mind when I started writing the book. Space history, though, is something that is continuing even today. I mean, look at what's happening today. NASA is getting ready to send humans back to the moon with a project called Artemis. And you probably have heard of Elon Musk, who has a company called SpaceX and is doing amazing things with his rockets and spacecraft. So, and then there's the whole field of robotic exploration, the Mars rover Perseverance and the Ingenuity helicopter and all of the other robotic missions that are exploring the solar system. So space history is something that is ongoing, and that we will never run out of stories to tell.
You had a chance to meet the astronauts and actually to know them very well, both from personal conversations and from studying the material that they produced and they left. There is a whole archives of the material that was produced by the missions. During those conversations and during getting those people closer, do you think that they are willing to share this experience and are they getting very technical? Are they rather like cold technical guys, or do they get emotional? Because it is, I guess, it's a very emotional experience to go to space at all. How do they perceive it after all those years? Do those memories still remain vivid in them, or do they just go on to other tasks? Is there a life after the moon for them?
Yeah, it's a great question. It really depends on the person. Some of the astronauts were more technically oriented and not emotionally oriented. Others were more emotionally oriented. In general, I would say that they really experienced going to the moon as professionals. So, you know, whatever you do for a living, imagine doing it at the absolute, you know, top of your profession, at the absolute hardest, most important aspect of your profession. Imagine having a mission to do, and imagine that not only your own country, imagine that it was a matter of national prestige for your country, but imagine also that the entire world was watching on live TV. And you can begin to understand what that experience was. It actually took a little while for me to understand it because I was coming to it as somebody who had been on the outside and thought, God, that's an incredible experience. It must just be a complete, overwhelming, you know, emotional, you know, intellectual, and every other way it must be overwhelming. But it wasn't, because they were so focused on the job, and they were so trained, they were so well trained, they were so mentally prepared for everything that they did. Now, that is the general observation that I would make, but within that, they had many experiences that they had very interesting and vivid reactions to. The reaction to seeing the Earth become so small as they went away from it. You know, the moon is about 240,000 miles away from the Earth. And so when you get out that far, the Earth is so small that you can literally cover it behind your outstretched thumb. And, you know, it doesn't matter how much training you've done, nothing really prepares you for that. And they talked about that as something that had a great impact on them. Not necessarily that it changed them. Very few said that it really changed them, just a couple. Most of them talked about it as a change in perspective. And, you know, by the time I got to them, it had been, about 15 years, some cases more like 20 years since their flights. I would say the memories were still pretty vivid. And even today, all these years later, you know, more than half a century, yeah, they still have the memories. They still talk about it. The ones who are still with us. So I mean, there are many dimensions to the moon experience, and that's one of the reasons why it took me so long. It took 8 years for me to write the book.
Yeah. So was it actually difficult to get to all the intrinsics and all the materials related to the Apollo program? Well, from one perspective, this was a classified matter and strategic matter. On the other hand, it was transparent. How was it nowadays?
Not classified, not at all. There was a very clear boundary in the United States between the NASA program, which was called the civilian space program and still is, versus the military space programs. So no, nothing was classified. there were some things that were held back for many years, and that really was just the recordings that were made in the spacecraft when the astronauts were on the far side of the moon, outside of radio contact with Earth. There was a tape recorder in the spacecraft that was recording their conversations, and those were kept confidential. Was the rating on it, not classified but confidential, by NASA until the early 1980s. So my timing was perfect, because when I came along to do my book, beginning in about 1985, those tapes had become released. The transcripts were all available. And in general, I had no trouble getting the information I needed from NASA, all the transcripts of the missions, the communications between the astronauts and mission control, all of their debriefings that they gave when they came back from the missions about each phase of the mission. I was able to get copies of the video that they sent down from the flights, all of these things. So the hardest part was getting the astronauts, who were now, had moved on to other parts of their lives. The hard part was getting them to agree to talk to me. Some of them were easier than others, but again, that's one of the reasons why it took me 8 years. I had to convince them that I had really done my homework, so to speak, and I had really prepared at my end for the interviews that I wanted to conduct. And I think in the end, they were very happy with the process of my interviewing them.
Do you think that they are still on the mission of spreading like Mike Collins, carrying the fire? And so do they still willingly share this experience in order to encourage the new generation, or is it you said that you had some were easier to talk to and some were more reluctant? Why do you think is that? Is it just a personal issue?
Yeah, it's just the personalities, and even today there are some who are easier to. They will agree more easily to talk about Apollo, and some are less interested in doing it. I think at this point in their lives today, they're in their 80s and their 90s now. It's really a question of, they just don't want to give any more energy to it. But, for most of the time since Apollo, I would say that the majority of the astronauts were pretty much willing to talk about it. And there were just a few that were more reluctant. Neil Armstrong, for example, was a very private man and did not really enjoy the process of being interviewed in general. I think he enjoyed my interview with him, and I've certainly seen videos in later years that seemed like he was having a good time, but he was very selective about who he talked to. It just wasn't the place he wanted to put his time and energy. So it really does just depend on the person.
Actually, I have to tell to the Polish audience that this book is the first one published in Poland that covers actually the whole program and whole missions, because we know very well Apollo 11 and we know some other missions also quite well, including Apollo 13, so the successes and failures. But actually, this book covers whole program up to Apollo 17, and each subsequent mission was more and more interesting. And actually, this is not what we are really aware of. We really focus that the Apollo 11 was the iconic landmark, and what happens later, actually, there was no much information in Polish unless somebody wanted to dig into archives on their own and some studies. But this is for the Polish audience the first chance to really get to know the details of all those wonderful missions, and wonderful things were actually being carried out later. I have my favorite missions there. Do you find any of those missions particularly important, or do you have a favorite one? Do you think that they somehow went to some kind of climax, or should we continue? Is it a pity that they were actually abandoned after the 17th? There were plans for 18th and 20.
Right. There were 3 Apollo missions that were canceled, and that was a shame. You know, I mean, the moon is a spectacular place. It's scientifically, it's a absolute, I mean, scientifically, the moon is one of the most valuable places that we have in the solar system, because we can go to the moon and we can look back through the rocks on the moon and studying the surface of the moon. We can go back to the earliest history of our part of the solar system, and we can understand what happened in the very first period of time, just the first few 100 million years after the Earth and the moon were formed. And that may give us clues to the conditions that gave rise to life on the Earth. I mean, there's so much that we have yet to understand about the moon, and that's one of the reasons I'm glad that we're going back. It's also, as you will see from the book, a spectacular human experience, just the experience of standing on the moon on this, you know, there's no air, the sky is completely black. The sunlight, however, is extremely intense. And the astronauts all said it was a beautiful place to be, not only on the surface, but orbiting the moon and looking down at the moon from orbit. There's so much richness there. The experience of seeing the Earth as a beautiful oasis. They called it an oasis in space. The only color that you see, apart from the gray and tan colors of the moon itself, is this beautiful blue and white planet that hangs in the sky. So, you know, that's what I tried to put into the book, along with the details of what the astronauts did. You asked me if I have a favorite mission or several favorites. Certainly Apollo 8, which was the first flight to the moon. It was the first time humans went out of low Earth orbit and went all the way out to the moon, and they actually went into orbit around the moon. That story, I think, is one of the most exciting stories from a human standpoint, and that's one of the ones that I enjoyed writing the most. But I really did get something to enjoy in every single one of the missions. I mean, telling those stories is a fabulous experience. The experience of landing on the moon for the first time in human history, as Neil Armstrong and Buzz Aldrin did on Apollo 11. 50 years ago this summer was Apollo 15, which was the first mission with the lunar rover, the battery-powered car that took the astronauts across the surface, and they actually went up the sides of lunar mountains. They went to the edge of a giant canyon, and that was an amazing mission to write about. Every single one of them had something amazing, something remarkable, something unforgettable.
So, for you personally, was it just a research, or was it also an adventure?
Oh, it was a very, very deeply meaningful personal voyage for me, because I had grown up with Apollo. It had been the most important thing in my life. I was absolutely, you could say I was obsessed with wanting to understand what that experience was like. And so, and of course, the astronauts were all my heroes when I was growing up. So the chance to sit down with them and ask them these questions and talk to them at great length about their experiences and their thoughts and their feelings about it was just really one of the great experiences of my entire life.
Well, geology is very strong at the ERC because you've mentioned robotics. There is just behind the big wall here is a Mars yard built with robots that compete, and there are engineers, but there are also geologists who analyze samples those robots dig out. We actually hosted Harrison Schmidt in 2015 here, so geology is a big thing, and I really also enjoyed the fact that the book was not written only from the engineering perspective or human factor perspective, but also there was a lot about the environment, the geology of the moon. Well,
well, that was my training. You know, I mean, before I became a writer, I was trained in geology, and my goal before I got into writing, I thought I was going to be a planetary geologist. So actually, when I started writing A Man on the Moon, even before I talked to the astronauts, I already knew some of the geologists who had worked on the missions, and they were some of the first people I talked to in writing the book.
Yeah, and when you read the book, you can tell that there is a really big focus on the why should we go to the moon, because it's very interesting in terms of science, but it's also an environment to explore. Who is the book for actually? Is it for enthusiasts of space program, or should an audience look? Wider audience should take it also?
I wrote the book for everyone. I wanted anyone to be able to pick up the book and understand what they were reading. Even the technology, I worked very hard to explain the technology, explain the methods that they use to get to the moon, to land on the moon. I spent a lot of time explaining the moon landing, how it happened, for example. I explained the science. I mean, that was that had become my profession at that point, because a few years before I started writing A Man on the Moon, I was an editor at Sky and Telescope magazine writing about astronomy, and I started writing for other magazines as well about space exploration and astronomy for the general public. So everything I put into the book is meant for anybody to pick up and read.
Well, thank you very much, Andy. Our launch window is closing, but we have launched successfully, and we have launched in Poland under the title Człowiek na Księżycu, program Apollo, released by wydawnictwo Astra, wydawnictwo _astra.pl. We encourage everybody to actually get onto this voyage. It's a great adventure, and thank you once again for speaking to us and taking the invitation. Thank you very much.
Well, thank you for having me, and thank you for doing such a great job in translating my book. I'm so glad that the people in Poland can share the adventure.
It was a pleasure.
Thank you very much, Andrew. Thank you.
Il viaggio verso la Luna inizia in Europa.
A la Luna vamos desde Europa.
De reis naar de maan start in Europa.
Ik maak Artemis. Ik maak Artemis.
Going to the moon starts in Europe.
Die Reise zum Mond beginnt in Europa.
Reisen zum Mond beginnen in Europa.
Somos Artemis.
And we are Artemis.
Ladies and gentlemen, and I can promise you this one is going to be a really interesting debate, something tells me. And the title is Human Space and Suborbital Flights, Advantages and Challenges, with the participation of Artemis Westenberg, Explore Mars Europe, Grzegorz Wrochna, Polish Space Agency, Christopher Welsh, International Space University, Jason Michon, Stardust Technologies, Paweł Wojtkiewicz, Polish Space Industry Association. The debate will be moderated by Łukasz Wilczyński. Enjoy.
Hello. Okay. So thank you very much. First, I will welcome our guests. Let me welcome our guests joining us online. Hello, Artemis. Hello, Jason. Bonjour. Our debate today, our talk, will be about human space and suborbital flights, advantages and challenges that wait for us. So I have a first question to Chris, if I may, because I would like to start with, the question that will settle once and for all, I hope. The thing that was covered in media recently about, these suborbital flights of Mr. Branson, Mr. Bezos. So my question is, what is exactly a suborbital human flight? Is it a flight to space or not?
Well, a suborbital flight is a flight that does not end up traveling fast enough horizontally to go into orbit. The question about whether you go into space or not is a slightly different one, since there are two separate definitions of where space starts, and as yet we haven't managed to agree those. There's what's called the von Karman line, after Theodor von Karman. He proposed that space started at 100 kilometers. And then there's the kind of US definition, which is that space starts at 80 kilometers. And the reason this has become a thing in terms of space tourism is because the Virgin Galactic spacecraft doesn't go above 100 kilometers, whereas but the Bezos capsule does. And of course, since there's a certain amount of rivalry between the two, it's easy for Jeff Bezos to say, "Oh well, yes, Virgin Galactic. They're not actually going to space. It's suborbital. You can look down at the planet. You can float around as you like. It's fun, but of course, you're not really astronauts because you haven't been to space." I think this just shows the human obsession sometimes with trying to draw kind of very, big distinctions. I mean, if this was 100 kilometers, they wouldn't be astronauts, but I would be, because 100 kilometers were there. And does that make any sense? No, not really. I think this distinction will gradually go away. At the moment, we're seeing private people go to space, and that's good. And then we're seeing, obviously, people go up into orbit. But as there are more and more flights, there are more people going to space, as their job. The exact argument about is it exactly 100 kilometers or 80 kilometers, it's for me, it's like, is Pluto a planet or a moon? I know people get very excited by it, and I see it as a slightly kind of false conversation. So. I don't know if that answered your question, because I haven't told you where space starts, but...
Okay, but does anyone have a different opinion about that? We can count them on space or not? Artemis.
Well, the thing is, of course, the word astronaut is, of course, here a problem. Are you an astronaut if you just take a flight up with either Bezos, Branson, or perhaps even Elon Musk if he just goes up and down? And not, around the Earth. Are you an astronaut? That's the thing, because aren't you an astronaut if you trained to do what you do, instead of just, being a space traveler? I think you're then, or a space tourist. I don't particularly like the word tourist. The only thing, of course, with this whole discussion about Branson and Bezos is that we are forgetting Wally Funk. She wasn't allowed to be an astronaut in the 60s, and she should have been, because she was one of the 13 women who actually did better in all the tests, the pre-test, than the Mercury 7. So they should have been, these Mercury 13 women. She had to wait 60 years to go into space, and now we say she's not an astronaut. I think It's, for most people, I will go like, okay, yeah, I was just, a space tourist or a space traveler. But for her, I would want to make an exception. Let her be an astronaut.
Of course. So, yep, of course.
Okay. Can you hear me?
Yep.
I've realized that the International Association of Astronauts solved this problem by designing two logos and two kind of pins. Okay, those who orbit the Earth, they have a little circle added to the logo.
Okay, so easy. So actually, Artemis already partially answered my next question that was for you. Can you see any advantages for the space sector of these suborbital flights?
Oh yes, absolutely. If I'm a researcher, there are 4 ways for me to do my experiment in micro or zero gravity. I do a drop tower test, which obviously I'm not part of the drop, just my experiment is, and I'm observing it and measuring it. Then I can do a zero G flight, and now I can be part of my experiment. And zero G flight goes up and down several times, so I can do this experiment, and it's all relatively cheaply, like the drop tower test. And like I said, I can go there, and I don't need to be, very well trained or anything. I need to be healthy, I suppose, but that's it. So I can be part of my experiment. It's cheap. And I can test, whether it's okay. Now I do a suborbital flight. Now I think I need to train a bit for being a suborbital, traveler. So I train. Let's say that I'm, healthy enough and dedicated enough, and whatever the reason is, I can do it. And now I can again be part of my own experiment as a researcher. So there's a big advantage of suborbital flights because it doesn't come with the enormous costs of an ISS experiment, which would be the next level. I would be able to do the experiment myself. I wouldn't need to hand it over to an astronaut and explain exactly to the astronaut what I want to be done, and then wait for many, 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 many months. I think 9 months or 18 months before it will, or perhaps even a few years before my experiment flies. And now, with the nice thing with these suborbital flights, they are supposedly, we're at the start of these things, of course, but they supposedly go quite regularly. A bit like, a flight to Australia which means that I can, do my experiment within a reasonable time for a reasonable costs, and I still can be part of that experiment. So from a point of view of science and technology and testing, suborbital flights are sublime. They're really a good extra to what we already can do. Now thinking of, going into suborbital flights myself, one of these space travelers, let's say I have enough money and I do it. That's of course a whole different kettle of fish. This is about showing myself the Earth, but if I go into space with the present people offering it, whether it's Bezos, whether it's Branson or Elon Musk, I'm actually not, if it's suborbital, I'm actually not going to be able to see Poland, because I'm going to go up and down, landing quite near to where I started, or even exactly where I started. And then I need to be able to see only a few 100 kilometers, perhaps a few thousand. But like I said, if I go up in the Mojave Desert, I am not going to see Europe. I'm not going to see this blue sea with this beautiful coral island or this working volcano on Iceland, because I'm all too far away. So this whole idea that you go to space, you go to the edge of space with a suborbital flight, but the whole experience of seeing the Earth beneath you and, turn beneath you, and you fly around it, that will not be yours. And I wonder whether people who are signing up for these suborbital flights realize that the images we get from the International Space Station are not the things they will see. They will see the curvature of the Earth. They will see, the difference. They will see, this is our atmosphere and it's really thin and fragile and we should take care of it. But they will not have that, orbital experience. And that will be, I think, a big difference. And I wonder how many of them will be disappointed.
Yeah, that's a long discussion. But let's jump to the real space now. So my next question is to Professor Wrochna, the president of Polish Space Agency. Why should we send human to space in the first place, as the robots can do such a great job, as we can see on the Mars yacht, for example, today?
Well, of course, we have to distinguish first between the commercial flight, tourist flights, okay, and the flights when the human presence is necessary to control the flight, to perform experiments, to conduct research. In the first case, well, for me, it's not very appealing to be a payload, like a box or something, but there are people who wants to go there and who are ready to pay a lot of money. Okay, that is very good because this money goes to the development of the technology. It supports the space industry. So I think it is very good, and I welcome that. But considering the flights when the human presence is needed, well, we as a national agency have to find a balance between some expectation from people that, well, we are a proud country, would like to have our people on the orbit, at the moon, maybe at Mars, and so on. But on the other hand, we have to be aware that it costs a lot, and perhaps there are other priorities of the country, there are other priorities of other people not having those ambitions. It is not easy to judge, but I think the solution is quite easy. We perhaps aim about to have 1 or 2 representatives from our country in space. We already have one, Mr. Hermaszewski, who was already in orbit. Now, ESA just announced a call for astronauts, and something like 500 people from Poland responded to this call. So maybe we have 1 or 2 astronauts. Why not? Of course, we do not plan a human mission to Moon or to Mars ourselves. No single country nowadays can afford that. Even US the plans are always international. Of course, we would like to participate in those missions. We would like to participate with providing some important components for the mission, some systems. For me, it is important to ensure that Polish companies, Polish institute, they will get contracts for this mission. And coming back to your question precisely, I mean, the human presence is still needed. And if you read the novels of science fiction writers, especially Stanisław Lem, this year we are celebrating 100 years anniversary of his birth. You can see that we can expect many situations in space when the robots cannot do their job, when you have to decide immediately, and you have to decide using not only your knowledge, not only your skills you have trained, but also your intuition, your feelings. Therefore, certainly for some missions, human presence is necessary.
Okay, thank you. Maybe any of you can jump in with another point of view. Maybe Paweł or Jason. If you have, yep. Okay, so Paweł, next question to you, because I want to right now go to the business, right? You represent the Industry Association, but you are also a director of space of GMV, Innovating Solutions. Now the human spaceflight depend solely on public money. So my question is, when do you think they will start to be a profitable business, according to you?
First of all, I would like to back to the one of the first your questions. Personally, I don't think that people which are doing suborbital flights, they're astronauts. This is my personal opinion. I mean, to have to be like in space for 3, 5, or even couple of months, it's totally different from being in space. I mean, almost in space for the 5 or 7 minutes. So this is huge difference. But back to your question. I think that I mean, human space flights are always being really close to the PR and marketing. And I think that for the moment, and that was in the past as well, that for the moment we can observe that those companies which are wanted to provide those kind of services, space tourism, for the moment they are fighting for the visibility. So this is for the moment. But true behind of that, there is a technology which is developed by the companies, and the question is if somehow someday in the future Polish companies or Polish scientific institutes can join to this group of the companies which are able to provide the solutions and technology for this kind of missions. So some days ago, I heard that the DG of ESA, Aschbacher, said that it is really curious why European space industry doesn't have the capabilities to send the people on orbit, while other nations, they have those capabilities. On the top of that, why we don't have the industry which is able to do that, while other nations, they have private companies able to do that. So maybe there is a light maybe in the horizon that the European Space Agency, as an agency which have enough money, enough power, and enough technology to start the program of human space flight, not only to have an astronauts which are in fact using the other infrastructure to be in space. So this is my understanding, but for the moment, I think that the biggest benefit for the Polish industry from everything which is happening right now in relation regarding to the human spaceflight is a good PR of space sector. I mean, please tell me what was on the top, what was the hot news, and people can see that human spaceflight, it's something real. Nobody in Poland will know that ESA, for example, has fantastic programs for the universe observation or Earth observation. Everybody will know that someday, maybe in the near future, within 3 years, I, as a Paweł, can buy a ticket and go into the space, and this is something.
Okay, so as a PR person for space, I'm flattered, but maybe we could deeply go to the topic. Maybe Chris, you can add something from your side, because you are a spacist.
I'm a spacist, yes. Well, I think we have to think about what the word astronaut means. I mean, we can have these arguments about the distance, but it's really, what does it mean in a kind of cultural term? What do we understand? And of course, the early astronauts were heroes. And so in our heads, astronaut means hero. And so that's why some people want to be astronauts. But then if more career astronauts are flying space planes, then astronauts become more like airline pilots. Now, that's still a pretty good job, deserving of respect. But if we get really, really good at space, then saying I'm an astronaut would be like I'm a truck driver, you know? Or I'm a bus driver. And I'll go, yeah, I've been on a bus. Hey, can I have my bus wings now? Because I've been on a bus. And so you have to think about how things may develop in the future. If we are really successful at developing human spaceflight, it will become a bit boring, you know, and that's how we will know that we have succeeded, because all the wonderful technological things we do are amazing when we first do them, and then everybody takes them for granted, like live streaming, you know, talks all over the world from a lecture theatre. You know, 10 years ago that would have been incredibly ambitious. 20 years ago, people would have probably said it's too difficult. And the same, I think, will happen with space if we're good. People such as ourselves, we will always be enthusiasts about space because there are aviation enthusiasts. But, you know, most of us just get on planes. You know, I've flown in a plane. Can I have my, my little badge, please, to say that I've flown in a plane? No, it sounds silly. And that's how I hope things will develop. And this whole question about astronaut won't mean the same thing. There will still be explorers. Yes, you know, the first astronaut, you know, on Jupiter's moons, that'll be a big achievement. But, you know, just flying to low Earth orbit, you know, that'll be, you know, just every day.
Okay.
If I can add to that, I think you're right that it will become boring, and you will get bored very quickly. You know, you remember Apollo 13 movie showing that, you know, for Apollo 11, the first landing on the moon, I mean, millions of people or billions even watched TV, and then already the third flight was not transmitted by TV. Okay, not many channels, right? I think we will have the same today. If we have another astronauts from Poland, all TV channels, all newspapers will be full of articles on that and transmission all the day and night, right? But the fifth one, nobody would care.
I will go.
May I add something? Yeah, I never expect that I will hear that going to space is boring or will be boring. To be honest, yeah, but I think it could be like that in the near future if we'll have this only suborbital flights. If it will be like if. For example, you will be able to buy for €1 million a ticket for 2 weeks on orbit. That will be something. I mean, for me, it's a totally different.
Oh, let's be optimistic for that. I will go deeply right now into space to Artemis, because you are very famous of being a Mars advocate, and I want to ask you about this first mission to take people to Mars. Will it be commercial or governmental?
I think it will be governmental, because it takes a lot of organizing. It's not just money and a rocket. You know, it's the training of the people. It's the whole setup, because we're going to Mars, not for dinner, but, you know, because it's a bit too far for that. So we're going to stay there at least 4 weeks, perhaps 18 months. It depends a bit. You know, both time frames have to do with the orbital mechanics of both planets. I expect the people to land, I always say, is the 6th of October, 2033. And then I grant you that I might be wrong. It might be the 21st of October, 2033. But that's about the ballpark that we're aiming for. And we is NASA and other people that are building for it. So will we go to Mars? Will it be momentous? Well, you know, the thing is, if someone steps on Mars, and it will be more than one person, of course, it will be a group of persons, at least 4, we actually become a multi-planet species. And people will say, oh, that's just a nice slogan. No, it isn't. You know, if we can live there for 18 months and the next crew comes and does that also, and the next crew, you know, and you do that for, let's say, 20 years, then we're actually not just Earth dwellers anymore. And I always hope that that will make us pause and realize that not just that this planet we're living on is very fragile and we can muck it up, which we've been doing quite wonderfully in the last, 60, 70 years. But it's also, I think, that we will realize that there is more to life than just, you know, the grid, the grind of, you know, a job and everything. There's something to dream of. And I think that very interesting. And I'm actually very curious what Jason thinks of all this.
I personally think that, again, relating to earlier, I think there's going to be a big wave of space explorers. And I think, on my perspective, that it will be government, like you said, but I think there's going to be some components of the commercial sector, because it's been advancing quite a bit. I really believe it should be a joint collaboration internationally. It shouldn't just be one government. And that's what makes space wonderful. Everyone just wants to collaborate together and create these crazy ideas that will motivate the future generations to go to space. And I think if we can join forces between many countries and people, like the Artemis Accord, which is wonderful, we can make this happen. It is still, though, a case of we'll have to address like the mental health aspects of it and the human aspect of it. You're not just going to want to send machinery and whatnot. It's really about having the first people on Mars. Are they going to be able to cope with the mental health aspect and the idea that they're so far away from Earth? Obviously, a lot of them are going to be very excited about the prospect of it. They're going to be really, how would I say, taken by awe of how Earth is so far. But I think it might be like the first Apollo missions where after 3 days, they were a little bit complaining about stuff. I think technology got a lot more advanced. Obviously, the food won't taste like rubber, hopefully, anymore. So, you make an excellent point. We need the governance of the government, but I still believe that it's important to mix international collaborations and businesses in this, because everyone has a role to play for space, and it will advance by doing this together.
Jason, speaking of government, yesterday we had a brilliant talk with NASA Associate Administrator Robert Cabana, and he mentioned that we can see first people on Mars in the 40s, and let me ask you from your perspective, because we talk a lot about technology, governmental support, but what about psychology? What about our bodies actually as a human factor? Are we ready for that?
I think if we start acknowledging that mental health is awareness is an actual thing, and we start actually implementing it in our processes, and we stop ignoring it, people start listening to it and not just try to say, hey, mental health is not a thing. We can get ready for it. There is lots of work being done in the industry, obviously. I haven't been to the Space Symposium in Colorado Springs. I noticed there's not much work being done on it. But now with the unfortunate event with the global pandemic, a lot of people have seen that mental health is actually a key factor in this. And it's not just about putting someone there and expecting them to be like super tough and whatnot. We really got to be able to create these solutions for them to address that before sending humans there. So that might be one of the playing factors before we can go to Mars. And hopefully it can be addressed. I think it's a social issue on a global scale, because as kids and even as a man, we're taught that when we're kids, we shouldn't be crying, we shouldn't be we should be toughing up and everything. And I think it's we got to get rid of those stigmas and really start talking and being open about it. And I think it's really important that our heroes, the astronauts that have been there, can openly talk about it to help people really like understand that this is something that we got to address. And we're just all humans at the end of the day. And if we want to make humanity a multiplanetary species, we got to address this at the government level and business.
Thank you, gentlemen. What are the challenges that of this human space flight that has to be overcome in the following 5 to 10 years to meet these deadlines or timelines that are directed for NASA or SpaceX? Chris, maybe.
Well, actually, I was going to agree with Jason. In an earlier presentation, I presented a whole lot of ISU team projects that we done, and one of them was called Lunaris, which is interestingly also the name of an analog here in Poland. And what they were doing on that team project was they were looking at things that you could do on the moon to prepare for going to Mars, and they looked at multiple different issues. They scored them and then ranked them. And number one at the top was psychosocial issues. Keeping your crew healthy and sane for long periods in space, and that's if we're going to, I mean, to go to the moon and back, it's a few days, but if we're going to go further than that, I agree that is absolutely essential. I think that is one of the big challenges, and I agree that the pandemic has also shown, you know, how important that is. So, you know, I'm a physicist turned engineer. You might expect me to say propulsion or communication systems or stuff like that, but actually, for long duration interplanetary missions, yeah, the human factor has absolutely got to be taken into account.
Okay, so one challenge. Any other key challenges we have to overcome, gentlemen?
Before that, yes, from the psychological point of view, there is one more very interesting issue, and the question for the people which came back from space: what next? What after? There is a huge challenge. The astronauts which were on the moon, after back to Earth, they faced a lot of problems with the society, with the being again within the society. And I think it could be a problem also in the future if the human spaceflight will be very, very common. So imagine you were on the moon and you back to Earth, and you have a question: what next? What I will do next? What kind of feeling can be the same as being on the moon? And I'm not saying this because this is my opinion, but I wrote that in a very interesting book, which is described the whole Apollo astronauts and their life after being on the moon. And this is really good book. This is The Moon Dust, about the people which came back from the moon. I really recommend you this book because it's really interesting from this point of view. And regarding to the technology, I mean, I would say everything. Imagine that, like in aerospace industry, you have to improve even right now every technology. I mean, to make those flights safe for the people, to make those flights more friendly for the environment, and so on. So I would not indicate the technology which is really important, because when I would say propulsion, someone from the structure will tell me, okay, the structures are the most important, and someone from the software company will say, okay, without software you will not go anywhere. So so I think that this is the question, not about the technology, but this is the question how fast we'll do it. And what President Vrochna said before, I mean, it's not really easy to go to the moon, to the Mars within 5 years, next 5 years. It's really complicated, and to make those flights really much more safer than Apollo flights, because this is also a nice story about the safety of those flights. To make them more safe for the people, we'll have to, I mean, spend a lot of money, to spend a lot of effort, and to have a time to develop the technologies.
Any other ideas, key challenges? Because I would like to open this discussion to the public, and now will be the hard questions, right, to our guests. Okay, so I have a microphone. If you want to ask questions to our guests on site and online, I'm here. Just raise your hand. Okay, the first one goes here. Kamil, short question, please.
Okay, so we are discussing the mundane aspects, as Professor Welch said, that the space will be mundane. Well, we actually saw that in the movie Alien, where the people who made the first contact, legal lapses, the first contact were actually space truckers, not astronauts. So that's the mundanity. But my question here is, we are talking about humans in space. Recently, we were talking about robots in space. What about cobots and human and robot cooperation?
So I think Chris is for you.
Yeah, I can come back quickly on that. I mean, again, you do get this debate about humans versus robots in space. Again, I think it's another one of these false arguments. I mean, clearly, for some specific tasks, it makes more sense to send robots. For other tasks, it makes more sense to send humans. And a lot of the time, it makes more sense to to send both. But human beings like, PC or Mac, robot or human, my football team or your football team. So I view this as yet more kind of slightly strange human behavior on these things. Obviously, you would send both. I mean, robots are tools. Would you say we're only going to send the human beings? We're not going to send them any tools at all? No, of course not. And tools are a spectrum from a spanner to a robot. So.
Okay, so but before the next question, anyone wants to add to this answer?
Just shortly,
okay.
When we enter into the competition between robots and humans, it means we have already done something wrong.
That's the point.
Just again, let me point out to one of the stories of Stanisław Lem called Rozprawa in Polish, the court, when there is a competition between robots and humans, and you will see what is the end of that.
Okay, so I think the next question, Remco.
Sure, thank you. Over the past 60 years of human spaceflight, we have seen the big heroes from America, the big heroes from Russia, Chinese astronauts. We have seen European astronauts, of course, but they've always kind of piggybacked on American systems, on Chinese systems, on Russian systems. What is the position in the future of European human spaceflight in this context?
Yeah, yeah, and that was what I heard recently from ESA DG. That this is curious. Why not? Why European industry? Why we don't have our own human spaceflight program? We have excellent launchers, and maybe we are able to get the next step and create the program for human spaceflight. So, I mean. What is the position of European industry and Europe within this whole race? I mean, still, if we'll not, as a Europe, because it is impossible for one country or even two, if we'll not pay a lot of money, because we are talking about the money, and will not decide that we want to have this capability to put the human on orbit or our own launcher, and I will not go anywhere. We will still be behind of China, Russia, US, and even India, because they are going to have their own astronauts on orbit.
But there have been European proposals, for human space vehicles. I mean, I'm probably old enough to remember, but there was the Hermes mini shuttle, which was a primarily kind of French-German project within ESA, which would have gone on top of the Ariane 5, but the program went over budget. It was becoming very complicated, and that got cancelled. More recently, we had the automated transfer vehicle, and there was a proposal at one point to produce a human-rated version of the automated transfer vehicle, which could again be launched by Ariane 5. But none of these, I mean, the first one got cancelled, the second one didn't get approved. I mean, it really comes down to the ESA member states making a collective decision about whether they want to spend the money on this.
I think that Artemis...
The thing is always money, money, money. Yeah, right. We do realize that in America, the general population spends about 5 times as much on toys for dogs and cats than the whole space program of NASA cost. Everything, including outreach, including educational grants and everything. So, it's not really money. It's about where do we want to go? And let's face it, Europe isn't poorer than the United States. Definitely not. We have about the same number of inhabitants. We have high quality universities, high quality students, high quality education in general. We have the power, the brain power to do it. We just don't have the political commitment because it's too fractioned. And so that's why we don't have a human spaceflight program. On the other hand, you could say, if we can rent a cap instead of building the cap, that makes sense too. So you could say, we should have more astronauts, but spend more money in renting the cap. So, renting the rockets to get our astronauts up. Because in the end, we want to get to space. It doesn't say we need to own the vehicle. to do it. It's more that, do we have the commitment to send people to space, to train them, to really be a spacefaring continent, Europe, or not? That's what it is. And it's, like I said, money is a very silly argument, especially since we all...
But it's not the U.S. government that is buying all those cat toys, okay? It's the U.S. citizens, and so I mean I've used similar examples with chocolate, with makeup, with beer, in the UK for the same purposes. As a society, okay, it's true, but you have to distinguish between what the citizens spend their money on and what governments spend their money on.
Yeah, but the government spends money if the citizens think it's okay. And
exactly, and that's the problem.
In 2013,
the citizens don't think space is important.
Actually,
we think space is important.
No. They said the same thing in America. And there have been 3 times now a national scientific survey of it. 2013, 2016, 2019, I think it was. The last one wasn't done by Explore Mars, but by Business Insider. And we get numbers like 54% of the Americans think it's fine to double the NASA budget as long as it then includes putting humans on Mars. So, people want to spend money if they see something, momentous being done. And that I understand. I want to buy a really nice house, but if the price is a certain level, it does need to include certain things. So, so no, we keep asking that. Also, these questions found, and this is the reason also why the American Congress got into this business of indeed, in the end, getting humans to Mars. Why they do that? Because we proved to them that their voters want it. I believe, and Chris, I dare you, to organize between ourselves a similar survey of Europe. I bet that there are far more people enthusiastic about space and the possibilities than you and I think. Because when we did the first survey, Explore Mars, we didn't expect that 74% of the Americans would answer, of course, in 20 years' time, there are Americans walking on Mars. We were like, really? And the answer of 54% saying it's okay to double the NASA budget was astounding, because this question was put to them, and that could be said bad planning on our side, while sequestration, every department had to hand in parts of their budget because the Congress couldn't agree on the budget for the country. And, while that was going on, people were really worried about money for the education of their kids, for their healthcare of their parents, or whatever, money is spent on by the government. And still they said, if this is what we do, really what we do, then double the NASA budget. And that's one of the reasons why the budget of NASA has been going up and up and up quite easily, because Congress knows that it kind of got a okay from the population to spend twice as much, and twice as much as 18 billion is 36 billion, and we're not there yet.
I don't disagree with you there, Artemis. It's the relationship between, yes, we should spend more money on topic X, and B, I'm happy to be taxed more. And in general, my experience with the public is they don't realize how cheap space is. I mean, $36 billion sounds like a lot of money, but when you split it up amongst all the people and you look at it a week, I mean, I used to give a talk to the audience in the UK and say, would you give up 1 beer a month, to send a Briton to the moon? And it's the same thing, because most people assume that space is incredibly expensive when it isn't really, when you look at the population. So we actually agree on that, but I think it's a matter of the education of the public. If you say, please, will you spend a lot more money, if they think they're going to be spending a lot more money, then they react in a different way. We need to show them that space is cheap. Sorry,
Chris, Artemis, Pax Romana, because I have a next.
And actually,
next
there's
question.
one thing I need to say here.
I'll see you outside afterwards, Artemis.
I have a next question.
The Space Agency did a survey, and they found that the Europeans indeed are willing to spend like 3 times as much on space than we are doing at the moment. So yeah, it's not the problem. general population. The problem is politicians and where they feel they can score. And because of space projects always running more than, one government cycle of 4 or 6 years.
That's true.
That's the problem.
Okay, so truth. I have a next question, okay?
Yes. And I'll let someone else.
And next question is more peaceful for Professor Brochner. And Artemis, I think, too, Polish famous writer Stanisław Lem, we remind sometimes about him, wrote a book. The title was A Peace on the Earth. Peace on the Earth, and the main idea was that all kind of conflicts, all kind of wars was moved, get rid of from Earth on the moon. What do you think about realization of this idea? Thank you.
Thank you. Professor Feth, maybe?
Thank you very much. Well, I think the purpose, the idea of Stanisław Lem was not to picture the future in this way, but rather to draw our attention to the problem that even we go beyond the Earth, we go to the moon, the problems are still the same, right? So we better learn how to solve our problems today on the Earth, because otherwise we risk that those problems not solved on the Earth, they will explode somewhere else. I think that was the message Lem wanted to tell us, and I perfectly agree with him.
Artemis, because it was also a question to you.
Yeah, the thing is, I don't agree there for a very simple reason. If we as a group, this group with this panel would be sent to Mars, and we're 6 people, so that would be about right. We get to Mars, and now we need to, fend for ourselves because it's far away. We can't do help. We have a problem, we can do that, but then, it might take 20 minutes before we get any acknowledgements that we just said that. So the idea that we will export our wars to the moon and Mars. To the moon, perhaps it's quite close. It's easy to direct things on the moon from Earth. But Mars is too far away. In Mars, even if we are the first 6, we will have to contend to do it together. And if I have to rely that Jason, Pavel, Lucas, Chris, all of you, that you are, the only thing I can truly rely on, then I better make it work. And you will think the same thing. So the fact that we will be able to start over, because that's actually what we're doing then, by saying, every task is just as important as the next one. It has nothing to do with, being a lower cost task or a higher cost task. That will make a big difference. So I actually personally think that will be the big advantage of going to Mars more than to the moon, because we will be able to show humanity that you can overcome differences in religion, in gender, in all these other things, that we can work together. We can be one united front, and we can have a better society. Because for me, going to Mars is not about, establishing a piece of land for the Netherlands or for Europe or for whatever. For me, it is showing the world that human beings are actually capable of having a better communal society. That's what my goal is.
Thank you. And with this united atmosphere, despite different opinions, we came to the end of our talk. I know it was very hot, and it could be very hot discussion, because we have a lot of the topics to have around space flights, but our time is limited here. Thank you very much. Thank you, our guests joining online, Artemis, Jason. Thank you very much, Chris. Thank you very much, Professor Brochner. Thank you very much, Pavel. I'm Lukasz. Thank you very much for joining us here. I can see also some new further astronauts also joining us on the stage, a very little one. So thank you very much, and I'm coming back to the host. Thank you.
Thank you so much.
Witamy Państwa ponownie. To już taka nasza tradycja, od wczoraj aż tradycja, żeby każdy dzień podsumować, omówić, co się wydarzyło ciekawego, poopowiadać, poplotkować troszeczkę z behind the scenes, jak to się mówi.
Right, let's have a quick sum up of today and let's announce tomorrow's third day of this conference. Łukasz, what happened today? What interesting happened today? You know whom I would invite here if I wanted to bring about revolution. We just heard her online. You know, now this is the limit, the border of space here, so you know who the astronaut is now, you know? Well, we've had a fantastic day of challenges in the championship in the Mars yard. I saw the competitors really work in the sweat of their brow. They said they were happy with the results. I felt this tension, but a tension full of optimism. I had the impression that at one point you fell into one of the volcanoes, the Mars yard. No, I did have some fun with the rovers, and I saw an agricultural rover today because, you know, more and more companies are moving into the rover business. That it looked like a RoboCup rover. You know, the application of rovers that are the gist, the essence of this conference can be transferred into all kinds of industries. Yes, I heard that every fourth startup in agriculture focused on automation of agricultural processes with the application of rovers. Right, we are summing up this day. Do you know that weeds are now fought with laser, you know, because rovers go around the field, it identifies the weeds and fires the laser. You know, yes, indeed, this is the work. This is the point when the farmer actually becomes the manager of the field. They are not the laborer in the field. Yes, because they're busy with looking for a wife. So, well, tomorrow we're going to talk about application of these technologies, the application of satellite data, because tomorrow is going to be fascinating. So, yeah, tell us, why are we going back to Earth on the third day? Well, let me tell you that today was about what is already happening. That is, we are going back to the moon, and tomorrow is going to be about the past. Because these space technologies are already being used on Earth. We've been using technologies, you know, invented at the time of Gemini and Apollo. These technologies, with all kinds of transfer programs, are being used on the Earth too, and soon also such a program is going to be launched in Poland, and these technologies are going to be applied by everyday business. We have hard technologies that are prepared for space shuttles, But satellite data, for example, is something that's so easy to use. It's so easy to start a company that will use satellite data, and you can build a nice business model based on that. You know, space is here in our phones. Well, ladies and gentlemen, I don't know how well you know Łukasz. I know him quite well. He has this feature of character when when you bring up any space-related topic, he will go on talking about it until you say stop. Piotr. In the previous discussion, in the last debate, the participants of the debate, very key people in the whole debate, were trying to answer the question about where these differences come from between Europe and the US, and the thesis by Artemis said that there were deep-rooted differences in mentality and this this fragmentation and the fact that Europe is not a single state where decisions are made. So based on your experience in your discussions with internet users and the discussions that you stir up, what is the most important element in these discussions in our vantage point as Poles if we were thinking in Poland about devoting a big chunk of our budget to space research? Would there be immediate social green light on the part of Poles or not? Or would there be a big discussion? Well, it's difficult to answer this question. You brought up a big number of issues, so let me try and shotgun answer these questions, this dispersed question, so to say. Well, this fragmentation that you mentioned definitely is an issue. It's a challenge always, because if you have a decision to be made and there's a number of steps of this decision-making process, definitely that is always an issue. But remember, the private sector does not have this issue, like in the case of NASA, for example, which is a governmental organization where every decision has to go through a number of filters and sieves. There's a number of entities that collaborate, as you said, and everybody needs to give their green light, and there is always delay at some of these steps. And money is a second issue that is definitely of importance in the whole process. But remember that NASA does not have who knows what budget. Well, let me simplify this. You talk to a big number of people through YouTube every day. You hear all kinds of people commenting on these issues. If you were to ask the average John Doe, the Polish John Doe, about the added value, the real added value, a real reason to go to Mars, what would they say? Would they give such an answer? I talked to an older person riding a bike, next to the Mars yard today. He stopped and he said to a lady standing next to him and said, you see, they know how to solve issues in the space, but they've no idea how to solve our Earth problems. Down to earth problems. Okay, I see where you're going. So let me ask you, if an average person was asked in the times of the invention of electricity, if they were the average John Doe was asked about electricity, would they say, yes, this is fantastic and this will be useful for every single one of us? And frankly speaking, I don't think this is something that's going to translate. It's not something that John Doe is aware of this technology translating into their everyday life in the future, in the life of future generations. This is huge simplification, a huge streamlining of our everyday life for future generations, and it's something we're working for today. But are we not at a stage where we need to level up in terms of wealth of our nation before we spend billions on space research? No, this is not what it's about at all, because that's not the amount of money we're spending on this. Right. John Doe does not understand why we need to go to Mars. And explaining the future to John Doe, I don't think it's about talking about the future to convince them. No, I think it's better to focus on what John Doe already uses as of today in terms that it has been transferred from space research that they already use and find useful. I have, for example, my sneakers, are a bit space-like. So, if you go jogging in the morning, they are already using space technology. So this is why I want to encourage you to join us tomorrow on the third day of this conference. Or turn on our stream and listen and learn what we already have in our everyday lives thanks to the space industry. Because indeed we have our issues here on Earth. Sure, there are climate change issues, but how do we know about them? Well, yes, you will see tomorrow what the role has been in that respect of space research. Remember that space industry, that space research is not the issue of space agencies, national ones, anymore. It's already the issue of startups. The issue of pollution, of water pollution, it's all taking place here and now, and it's enough to show this knowledge in an attractive way to convince people. I think it's better to focus on what we already are using and what we have thanks to the space industry. Would you like to add something, Piotr? Well, I agree with Łukasz. You remember the story of this nun who sent a long letter to one of the Apollo program's heads in which she asked, why do you spend money on space missions while I see hungry children every day who are sick and hungry? And there were three ways, really. One possibility was to ignore that letter. The second way is to try and explain, and the third one was to make fun of such comments. Well, that director decided to go for the second solution and explain what advantages, what benefits we've already derived from space technology. So he managed to transform that person, that nun who was an opponent, transform her into a huge proponent of space industry to the benefit of humanity in the future. So I hope that thanks to this third day, we will make a small step in that direction. Yes, I need to have the last word. I'm the organizer, I have the badge, so let me say the last word. We encourage you to join us tomorrow. We're going to talk about NASA, about Pulsar missions, about ESA missions, all kinds of organizations that are here who are active in the industry. This is when and how we want to explain what benefits we have derived as society from the space industry. And interestingly, we're not going to be here alone as EORC, because we are going to have an Alpha Electronics festival in Austria, a connection with them directly. So we might talk about bandwidth a little bit tomorrow too, and focus on what we derive as added value from ERC and the space industry. Ladies and gentlemen, today we had a queue for our conference, for our area, the Mars Yard. There were children, there were young people, there were also older folks that were queuing to join us. So I think we owe you a congratulations for what you have done so far. Congratulations. Thank you very much for being with us today, and see you tomorrow.